Hello and welcome, everybody. Come on, let's make some noise. I know it's early, but especially for a Saturday. But thank you all for coming out. Thanks to all the folks who are also joining us online. Wanted to give people a heads up. If you're online, or actually even if you're here, you can, during the Q&A, you can submit questions on our Slack. You would have gotten a link when you registered in the confirmation email. Also, scattered around on a few tables here, there are also links, invitation links to the Slack as well. And it'll be the main stage channel on there is where you would ask questions. And we certainly welcome and we've appreciated yesterday all the questions we got here in the room as well. Wanted to thank you all for coming out and to introduce our first speaker. So most of you are probably familiar with Eric Raymond's formulation that he calls Linus's Law, which says, given enough eyeballs, all bugs are shallow, which is potentially true. It depends on how you choose to interpret that. But it doesn't really say anything about what do you do with a bug after you've found it. And that's a step that maybe doesn't get as much coverage. And so it's going to be really fascinating to hear Ben Callis talking about how do you actually report a bug to people who can do something about it? How do you communicate that? What happens with the bug after you actually find it. And so I'm really looking forward to seeing this presentation, and I hope you enjoy it as well. So we're going to talk about some lessons learned from reporting the bugs. Ben.
Thanks. Thanks for the introduction. So I'm Ben. I'm a PhD student at Dartmouth in Hanover, New Hampshire. If you're interested in applying, you should. We have a growing grad program in the CS department, and we need more free software-minded people. So please apply. I like computer security. That's like nominally what I do as a student, but really I care about free software. I am interested in the security of free software and not as interested in the security of proprietary software, which is often harder to analyze. And it seems like a lot of duplicated effort to reverse engineer someone else's work when they have the source code. So a quick definition here, fuzzing. This is a program testing technique that is basically just feeding programs garbage. So you have a program you want to test, you feed it a bunch of random crap, and this tends to be pretty good at finding crashes in those programs because it's very easy to observe a crash. So if I'm feeding a bunch of random trash to a program and it crashes, and I see like, core dumped, sig v, like I can recognize that and say, oh, I found a crash. That probably matters. That's a bug. That's something I should report. On the other hand, logic bugs, not so easy to observe with fuzzing. If I'm just feeding a bunch of trash to a program, and there's some subtle logical error, but it still exits normally and behaves, like more or less in a seemingly correct way. That's not so easy to detect automatically. But if the program you're testing is a program that implements a standard or a program that's been re-implemented a few times, then you can detect logic bugs in a lot of cases by just comparing one program to another. So for example, you can detect logic bugs in Apache by comparing its behavior to Nginx. This is called differential testing or differential fuzzing, and this is like what I do, what I spend most of my time on. Okay, so the HTTP Garden is a project I started last year, and the gist of it is we have a bunch of web servers set up, a few proprietary ones, but a whole lot of free and open source servers, and we send them random garbage, and we observe whether they behave the same or different, and if they behave different, then we go look into why. And this is a pretty easy way to find lots and lots of logic bugs in web servers. And some of these have mattered. So we found, we've gotten 20-something K of bug bounties out of this. So it's been a pretty fruitful project. Of course, we welcome contributions, but yeah, so the real reason we're doing this, though, is that there's this class of bug called HTTP request smuggling that got sort of well known maybe 5 or 6 years ago. And the gist of it is when you can induce discrepancies in interpretation between multiple web servers, you can sort of bypass restrictions that may be implemented in intermediary servers. And then there's downstream consequences of this, and the most interesting one is that you can construct requests that I can send to a load balancer, and then the load balancer may forward me a response intended for another user. So that's kind of the coolest thing you can do with this type of bug. And this is why HTTP parsing is something that I'm interested in looking deep into. So I wrote this fuzzer. I found a bunch of HTTP parsing bugs. And this is actually not super difficult. So I basically just wrote a generator for random HTTP requests and just shot it at a bunch of servers and observed the result. And this is pretty easy to do. Part of the reason is like string handling is just very difficult in C, and there's a lot of stuff that's written in C. And actually, string handling is not as easy as it seems in Python. There's a lot of stuff that's written in Python. And in fact, in like nearly every programming language, like this is actually just a hard problem to write a good web server. Is just not straightforward. And it seems straightforward, and that's part of why it is so challenging. But tools are very good at finding bugs in general. So if you want to find bugs, you can kind of just run AFL or any other popular fuzzer or differential tester and just kind of observe the pile of bugs that falls out. This is pretty well studied, and we need more people doing that. But if those tools don't work, then you can just write your own tools. If you have a feeling that a type of bug might exist and is not super well covered by existing testing tools, it's not that difficult to just go put one together if the bug is easy to observe. And that's fun. But reporting bugs is way more difficult. So you have to interact with people, and those people may not be so happy to have you tell them problems with their pet project. You need to be able to write clearly. You need to understand the bug, ideally. It's not so good to just dump a bunch of information and have no context. And none of this is fun. So this is actually terrible. So I have a big file of just bugs that I need to report, and it's like on the order of maybe 70 or 80. And it's just a bunch of work that I don't feel like doing. But I have to do it, and so this is what this talk is about. So step one is you want to have a minimal, reproducible, bleeding edge proof of concept of your bug. So if you found a bug, assume we've already done that. Next step is we need to be able to communicate what the bug is. So it should be our proof of concept, our demonstration of the bug should be minimal. It should be just enough to show the bug, and it should not contain any extra code. And you should not have third-party dependencies in this proof of concept. So I actually see this a lot in bug reports that I get tagged in, where people will give a proof of concept that has a ton of dependencies, and it's like somewhere down the chain is the library that they're claiming the bug is in. And that actually helps no one, because if you just claim that the bug is there, but you have all these other libraries involved, I have no proof that the bug is where you claim it is. It should be reproducible. So containers would be one way to do this. Nix would be another. You should not use words when code will suffice. So if you have a bug, don't bother describing it super in depth if you can just give like a one-line shell command that gets the job done. And then it should be bleeding edge. So if you're reporting a bug that is in like a Debian package to the upstream project, then you should go build it from source, just to make sure that the bug has not been fixed between the time of that Debian package's release and the present day. And when you build from source, you should build from the latest branch, because it's possible the bug that you're reporting has already been fixed, and you just haven't seen it yet because you're either using like a stable release or just the last release, and lots of stuff happens between releases. So always build from master or main before reporting your bug, just to test if it's still there. And definitely don't report upstream bugs based on like a Debian package, just because a lot of the time I know firsthand, I have lots of bugs that I've reported and that have been fixed, and some of them are like real security bugs that matter, and they just don't make it into Debian packages because either the maintainer doesn't want to get a CVE, and like I don't feel like going and getting a CVE, so then it just kind of sits there and nobody notices, and silently everyone's Debian packages have bugs that matter. So test that your bug is still there on the latest master and build from source. Next is show the ground truth. So if your bug causes a crash, give a backtrace. And give a backtrace with debug symbols and sanitizers. So if you're building from source, you can pass -f sanitize equals, and there's a whole bunch of options there. So undefined and address are two common ones. There's more if those don't get you good output. But essentially, these give more debug information in the crash. So when you have like you're indexing a buffer out of bounds, let's say, and you compile with those flags, then you'll get output saying, oh, you're indexing this buffer out of bounds. This is the index. This is the address you're touching. Like, it'll say, whether it's on the stack or the heap. So those kinds of things are pretty useful. Definitely compile with sanitizers. Compile with debug symbols so that the sanitizer output can say the names of your like globals and your functions instead of just annoying noise names. If your bug is in the implementation of a standard, then you should cite the portion of the standard that's being violated. So this is just so that you don't end up in a disagreement about whether behavior is correct or incorrect. I've seen this a lot of times when I was reporting some earlier bugs in that HTTP project. Before I was so familiar with the standard, I would just observe that there's one server that does something very different from other servers and kind of assume that that's a bug. That's not a very good approach. So for example, Go's standard libraries implementation of HTTP implements a really strange behavior in that like when they send error responses, they don't tell you how long they're going to be. And I saw there's like messages with no length. That's weird. Every other type of HTTP message will either have no length indicating no body, or it will have a length. And they would send messages with no length but containing a body. And I didn't realize this is actually allowed only in like some really weird circumstances, and they were conforming to the standard. And this is embarrassing to make a report that turns out to just be you being wrong. So cite the standard ahead of time, and you don't have to deal with that problem. If your bug is in a documented part of a project, then you should just demonstrate how the documented feature is not being implemented correctly. So if there's documentation saying that your function should behave one way and it behaves another way, that's sufficient. What you don't want to end up in is a situation in which you're arguing with the maintainer about the way a function should behave, but there's no ground truth. That's a very difficult argument to win. OK. This is like one of the most important slides in the deck, is don't be confidently wrong. So there's two ways to not be confidently wrong. The first one is to not be confident. So you should assume good intentions. You should be polite even when other people aren't polite. This can be hard, but not that hard. So just like take a step back from the keyboard and just kind of focus and think to yourself that like this is all really just people typing on computers and like doesn't matter that much. The other way is to not be wrong. And that's really, really hard. So you can't not be wrong. You'll always be wrong sometimes. And so approach one is definitely the better approach. When in doubt, submit a patch. So if maintainers won't fix your bug, you can just fix the bug. And in fact, this is like kind of the best thing you should always do. If you can submit a patch, do so. It's just that if you have lots of bugs, or if it's in some real strange code that you don't understand, then you're out of luck there. This is what's so great about free software. So respect maintainers' preferences. If a project has a bug template, then use it. So often there will be some form you can fill out for, if you find some kind of bug, they'll ask, what version are you using, what's your OS, things like that. If there's such a form, use the form. Don't just delete the form and type your own thing. Weirdly, a lot of people do that, and I don't really understand why, but it just makes you stick out and not so polite to the maintainers. If the bug template asks for information you think is irrelevant, just include it anyway, unless it's so irrelevant that you can't include it, then you can write NA or something. But what you think is irrelevant may not be right, and the maintainers probably know better than you do about their project. Lastly, report bugs through the official channel. So don't send emails to random people unless they say to do so. This is sometimes the official channel is good. So if there's a Bugzilla or a GitHub or GitLab issues, this can be nice because it's sort of a public record of the bugs, and it's not going to sort of slip through the cracks as easily. Often the best thing you have is a mailing list. Mailing lists are not as good. So if you only have a mailing list, if it's a well-maintained, real active mailing list, that can be fine. But if it's a mailing list that's a bug mailing list for a project that not a ton of people are looking at, this is often shouting into the void when you send a message there. So that's not always the greatest. But sometimes a maintainer, you submit a bug report, you think you've done everything correctly, and there's just low comprehension. So the maintainer just doesn't understand what you're saying. This happens. This is just the way the world works. If it's a security bug and you're reporting that bug privately, then you always have the option of going public. And sometimes that gets people's attention when a bug that you've reported in private was ignored, and then you report it in public, and suddenly people stop ignoring it. But if it's not a security bug, then if you really care about having it fixed, you should fork. Otherwise, you're out of luck. OK, so ways that you can contribute are go through the issues of a project you use and help people debug issues. So if somebody's reporting a bug and they don't have a minimal reproducible example, you can go write one yourself. You can fuzz things that other people aren't fuzzing and go submit bug reports. You can build things with sanitizers. So especially if you use a build from source distribution like Gentoo, sanitizers only cost you they make your programs a few times slower. So if that's fine with you, then you can build your personal software with sanitizers and observe bugs that no one else is seeing. And this is actually, there's a lot of cool bugs out there that nobody notices because nobody is building their code with sanitizers. So you can very easily find bugs in pretty large, supposedly robust programs by just building them with -f sanitize equals undefined and waiting for them to crash just after you use them in the totally normal way. And lastly, of course, just go find issues that describe bugs and fix them and submit PRs. One sort of hobby horse of mine is the robustness principle. So as many of you probably know, the robustness principle states that you should be conservative in what you do and liberal in what you accept from others. And the reason for this was that in early internet protocols, there wasn't a lot of specificity in the standards, and there was a lot of disagreement about how exactly things should be implemented. For example, in the early MIME standards, they said you need 80 character lines, but it wasn't clear if that was 80 characters including the line ending characters, or if that was not including those line ending characters. So it's either 80 real characters or 78 real characters, and people weren't sure which. So the robustness principle would say, always send 78, because then you're compatible with everybody. But when you receive 80, accept it too. So this is, in principle, a good idea. But what it kind of turned into is be conservative in what you do, but accept all garbage. So in practice, what this means is lots of especially sort of implementations of network protocols, you send them crap, and they just kind of try their best to sort of understand what you meant. And this leads to lots and lots of problems as soon as you need different programs to agree about the interpretation of some stream of bytes. So this is really bad, and you should spread the word about this. And if you're implementing a network protocol, you should consider being conservative in what you send and conservative in what you receive. For the early internet, this may have been necessary, but at this point, we can all be adults and we can all just implement things correctly. Great, so I have another deck of slides demonstrating a really pernicious type of bug that's very easy to find. And let's go through that. OK, so for those of you who are familiar with C, I have a question, which is what does this program do? Yeah, adds two numbers together, uses them as an index into this data string, which is live free or die, the state motto of New Hampshire. And how do you make it crash?
Go past the string length?
Yeah, just make those numbers too big or too small, and you'll index that array out of bounds. And if you go too far in either direction, you'll observe the crash. OK, so if I've added this check here to just make sure that neither of these integers is negative, and also that their sum is not too big, can you still make it crash?
Yes.
How?
No, maybe not. Nope, I thought wrong.
Well, you're not wrong. The answer is yes.
I mean, no, my first thought was still getting it to wrap around negative.
Well, that's right. So we check that each individual number is not negative, but if the sum is negative, then that would be fine, right? So integer overflow would get you there. So wrapping around would still make it crash. So the final question here is, can you still make it crash if I check that the sum is not negative? So it seems like the answer should be no. We've checked all the cases, right? Neither is negative. The sum is not too big. The sum is not too small. We should be fine, except it turns out that in practice we're not fine. And with the right compiler flags or the wrong compiler, this will still crash in exactly the same way. It's still vulnerable to the integer overflow. And the reason for this is because the C standard has some weird things that it specifies that are very unintuitive. So the C standard says like what you should expect from a normal C implementation. So things like the size of char being 1, and that printf is in stdio.h, and that global variables are initialized to 0. But then it also says things that are implementation defined. So those are things that are sort of up to the implementation to determine. So for example, how many bits are in a byte? Usually 8, but you're free to make it whatever you want on your special implementation of C. And that's defined in some header called char bit. Whether char is signed or unsigned is up to the implementers. How many bytes are in an int? As long as it's at least 2, you can go higher than 2. Whether when you right shift a negative integer, whether the signed bit propagates or not, that's also implementation defined. And then there's things that are undefined. So undefined things are like what happens when you overflow a signed integer. It's just undefined. So it's not like implementation defined, where the implementers get to choose a thing that happens when you do this for this operation. It's like the implementers get to choose that anything can happen when you do undefined operations. The same is true for when you use a value from uninitialized memory, or when you access an object out of bounds, or when you dereference null, or divide by 0, or left shift a negative integer. So just to drive that difference home, this printf will definitely print some number. We don't know which number, but it's going to print a number. This printf could actually do anything at all, according to the C standard. Now, in practice, there are a few things that this will likely do, right? This will likely just crash. You're dereferencing null. But like, as far as the C standard is concerned, the compiler is free to emit whatever code it wants when it sees this input C code. So in practice, though, when compilers see things that are undefined, they treat it as dead code, especially at higher optimization levels. So that just means your undefined thing is going to get optimized away in a lot of cases. In other cases, there are undefined operations that everyone just kind of agrees are technically undefined, but like shouldn't be, and so then the compilers leave them in. But like that could change at any point in the future. And the reason for this is that the C standard assumes that the programmer knows what they're doing, and also that performance is all they care about. So you can write better compiler optimizations if you don't have to care about signed integer overflow when you're writing your optimization. If you just can ignore that case, then great, you now have a better optimization, easier to write. So here's another program. Actually, before we get to this, let's go back to this program here. So we can see why, hopefully, why this fix doesn't work. And the answer is that, does this work? Kinda. The overflow, so the I plus j less than 0, that will overflow a signed integer, potentially. And so if we look at if we look here at this condition, this is saying if I is less than 0 or j is less than 0. So the compiler knows that after you get past this if statement, I and j are not negative. And then there's an if statement that says if their sum is negative. And the compiler knows, OK, I and j are not negative. And then here's an if statement that checks if their sum is negative. Well, that could only be true in two cases. One would be if I or j were negative, which we've already ruled out from the prior if statement. The other would be if there was an integer overflow, which is undefined, so we don't have to care. So the compiler sees this. It says, oh, great, this is dead code. And we can just delete this whole if statement. And this is really, truly what GCC will do. So at -01, but not at 0. So this is like terrible. And this is a great reason not to use C. And C++ has the same problem. Here's another interesting program. So it attempts to malloc a ton of memory. And then it just checks to see if the malloc succeeded. And prints a string about whether the malloc succeeded or failed. And this behaves the way you would think. But if we add a memcopy just after the malloc, and just a reminder on the arguments to memcopy, we're doing a memcopy into the result of the malloc. That's our destination. Our source is an empty string. And the number of bytes to copy is 0. So we are saying, oh, let me try to pull up that man page there just for you all to see. The destination goes first, the source is next, and the number of bytes to copy is last. So returning to the example, we're memcopying 0 bytes from who cares to the result of the malloc. So if you're copying 0 bytes from anywhere to anywhere, that should do nothing at all. But it turns out that's not what the C standard says. And the C standard says that if you are memcopying to or from any place, regardless of the size of the memcopy, then those places must not be null. And if they are null, then it's undefined. So what the compiler can do here is it can see, OK, first we have this malloc, and the result s may or may not be null. And then we memcopy into s, 0 bytes, which tells the compiler s must not be null, which then tells the compiler that if statement that checks that if s is null, that's dead code, because s can't be null because we memcopied into it. And the compiler will optimize out that put s. Not every compiler will do this. Clang will do this at -02. GCC, I don't think, will do this. Anyway, you'll see if you run this at -02 on Clang, this will print the crazy malloc succeeded, which should be impossible. So this is actually like a really widespread pattern, this whole thing of memcopying 0 bytes from somewhere into null, or from null into somewhere. And the place this comes up is projects that define their own string types. So if you look at like the Nginx source code, they have a string type that's just a struct with like a buffer and a length. And the way they store the empty string is the buffer is null and the length is 0. And then when you have a string copy function, well, that will just like look at the length and do a memcopy of that size from the buffer to some other buffer. And so you end up doing these memcopies to and from null all the time. And if you just run Nginx with ubsan turned on, you'll actually observe that it crashes almost immediately from memcopies from null. And I did report this, and we can go through and look at what the report looked like. So here's the report. You can see it was closed as won't fix. And the The reason for that is, so I'm showing exactly where the memcopy was, but the maintainer of Nginx at the time, who has now departed the project, basically said, since this is technically undefined, the expected behavior is obvious, and any compiler that miscompiles this code is broken. And yes, GCC is broken. So then it's just like, OK, essentially his response was just, we only use 01, and so we don't have to worry about this. This is like a weirdly common position. So of course, if you only use 01, for now that might happen to work. But like in the future, that could completely cause your program to fall apart. So this is a very brittle approach. Reporting, I actually found some similar behavior in Apache in mod FCGI, and they fixed that immediately. I submitted the bug report and like a example patch on the mailing list. They changed the patch, but they did fix the bug quickly. Nginx, these are still there. And in fact, I wasn't the first person to notice this, and was also not the first person to be told to get lost. So yeah, this is a common pattern. Fix it when you see it, but not everyone is receptive to actually merging those fixes. OK, another quick question that should be straightforward to those of you who are familiar with C is, what does this program do? It's just while one. Yeah, just loops, yeah. OK. What does it do in C++? You'd really hope it would be the same, but it is not the same. So in fact, in C and C++ have different definitions of which operations are undefined. So in C, this is perfectly fine. It just loops forever. In C++, this infinite loop does not make what the C++ standard calls forward progress. And this will actually get optimized by Clang into just exiting. It'll just exit. So if you compile this with Clang-02 or Clang++-02, and you run it, it'll just exit with, like, you'll literally have no main at all. Like, you can look at the obj dump, and main won't even be there. So the whole entire function is just optimized away. So this is terrible. And this is also relatively common. You can find these in the wild pretty easily. Just compile software with sanitizers and observe that things go really, really wrong. OK, so takeaways from this portion of the presentation is that C is bad. Like, C is sometimes the best tool for the job, but it's not a great tool. So C++, arguably much worse, because it's kind of like C with even more. Sometimes they're unavoidable. Like, you've got to use these languages if you're trying to interface with projects that use these languages, or for which their like native API is targeting these languages, and that's fine. Like, you should know these languages, but for new projects, if you can avoid them, consider doing so. But when they can't be avoided, use ubisan. So compile with -f sanitize equals undefined. It really makes a world of difference. You'll see all these bugs that were invisible to you previously, that just sort of bubble up out of code that seemed like it worked before, but actually may not on different compilers or different platforms. OK, so now that we've covered that, I have some links, and we can go look into some bug reports that I've made over the last while and critique them. So first, let's talk about this. I can't click links here. Let me copy this. OK, so gunicorn is a web server for Python. It's pretty big. It's like one of the more popular web servers for Python. I reported this bug privately initially. And essentially, the bug is that the server, it has some incorrect behavior with line endings. And you can get interesting results out of sending line endings in the wrong places. So the maintainer of gunicorn had previously, we'd corresponded over email, and we really did not come to an agreement about this. So I put it in public. And Yeah, pretty much his response was like, instead of treating this as the, like, if you know about request smuggling, this is a pretty obvious security bug. But instead of being treated as a security bug, he changed the name of the issue to, because he's sort of, in his opinion, the new HTTP standards are poorly thought out. So here, if we go down, he says we need to handle a new badly thought RFC that introduces this issue. And so this is sort of, I would say this is actually a relatively common type of interaction where you report a bug, you say which part of the standard is being violated, and the maintainer says, the standard is wrong. Yeah, yes. But, you know, I kind of just, if he's going to change the name, he's going to change the name. I make my case, and someone else eventually noticed and fixed this, this issue. Part of the reason for that this actually got fixed was that someone who worked at Canonical noticed that I was reporting these things in public and made an issue saying, like, we can't have that. And so then this sort of got the, yes. Another example of a maintainer being sort of, yes, yeah, great way to put it, is if you've heard of Lighty, it's a web server for like embedded devices, and it's pretty popular. They had a really weird bug, in my opinion, in his opinion, not a bug, which is that when you send them a request with a like syntactically invalid request method, then it will respond with the 501 response. And that means that the method was unrecognized, but it does not mean that the whole message is syntactically invalid. And the problem with this is that if you respond 501, then that's a cacheable response. So what you can do is if you have a sort of intermediary caching server that, for example, ignores null bytes on the ends of method names, when you send a request that has a null byte after the method, the caching server will forward it to the Lighty server that's behind it. Lighty will respond, 501, I don't recognize that method. And if the middle box does not, if it ignores those null bytes on the end of a method, then you've now put an entry in the cache under the wrong key. So I can make this more explicit. An example would be, let me try to find here in, yeah, so if we say get \r being treated as equivalent to get, it turns out that Google Cloud's default load balancer actually had that exact problem. So it would forward get requests with carriage returns on the end of them, and then Lighty would see that and say, I don't know what method that is, 501. And then when you send a get request to the cache, now you'll get a response that just says 501, which is, of course, wrong. So this is like a real issue that was exploitable, and you could use it on real websites to just like turn any page you want into a 501. And the maintainer of Lighty responded like this. Allow me to be super blunt with you, because I think you need to hear it. And then just a really long rant, to which I just responded, that was dramatic, sounds like something is really bothering you. So, I mean, sometimes there's really nothing you can do. This was actually fixed, and it turned out that, according to this particular maintainer's preferences, reporting this bug in the bug reports portion of the website is just the wrong place to report them, in his opinion. And if you want this sort of bug to be fixed, you should just go report it in the forum section of the website. And then he actually did fix it, which is very strange.
Reporting a bug in the place to report bugs was the wrong place to report a bug.
Because he doesn't think it's a bug. But if you put it in the forum, now that's not where bugs go. And so it's fine. So then he'll actually, if you just report it there, then he'll fix it. So now when I find bugs in this server, I just report them in the forum. Yeah.
He's implementing a feature request.
Right, yeah. Exactly. So you learn these lessons, it's specific to each project. But the important thing is not to take it super personally. People who are sort of lone wolves and develop these kinds of very successful independent projects often have interesting personalities.
So is the forwarding of the request with a null byte on the end or not by those intermediate servers, is that within the bounds of the standard?
It's not. So the interesting part of this is that
Can
it
you repeat
requires.
that question for the people online?
Bug in the proxy server than in the web server?
So it's a bug in both.
Okay.
It's the proxy server definitely shouldn't forward those requests, but when the web server receives them, it also should not respond. It should respond, this is a totally invalid request. It should not say, this is just a request I don't recognize. So it's a bug in both places. And these are very difficult bugs to convince anyone to fix. Because if you report a bug, especially one in which the bug is in one program, but it violates the security model of a different program, it's really hard to convince anyone that that's worth fixing.
Or they'll tell you it's worth fixing, but it's not mine to fix.
Yeah, yeah. But sometimes it's not possible to fix in the program whose security model is fine. Another good example, and I'm happy to turn it over to questions as well if anyone has anything to say. There's a lot of problems with the URL parser in the Python standard library. And so I wrote a little message saying, like, hey, I've rewritten this parser, and I like this parser, but it's kind of a ball of crud, which I thought was sort of putting it kindly. And an admin on the forums changed the text to say, it's unclear to me why it's written the way it is, which is fine. This is a long time ago, and I wouldn't have written that sentence today. But yeah, essentially, I went back and forth with different people about this, and I did get a response from the Guido, the guy who sort of started Python, and he was basically just like, no one will want this. And so I said, okay, I've heard it from the top, that's fine with me. The Python standard library does not aim to be correct. It aims to be the same as it was before so that people can rely on it. And that's just more important to them than having something that complies with the standard. And that's a perfectly fine trade-off, I think. If anyone has questions, happy to answer. So if there's questions, please raise your hand or just yell. But if there's not, I also have more of these I could go through as well. Yeah?
1 second.
Try to provide as much information as possible. And I don't know how many other people, but I've been around where they have servers, so that they'll shoot your thing down, right? Well, you need to bounce server. Why are you bounced the server? And I reduced it again. And here's the error, here's where it shows up in the logs, and I also went in the dev environment and found the same error. And, you know, it's showing up more than one place, so can you fix it? So, not a person they like very much, but also I've had more than one time that I brought the developer, either shared the screen or brought him over and going, here's where it breaks.
Thanks. Yeah, that's good feedback. OK, so here's another bug that I reported a long time ago that remains unfixed. The bug is that H2O, which is it's like Fastly's web server, has a problem with if you specify the length of the message multiple times, it will allow that and just pick one of them. And this is a pretty bad behavior because any intermediate server that was forwarding a message with multiple lengths, need not have made the same choice of which one is the one to go with.
When you say pick one, is it deterministic which one it's going to pick, or do you mean just picks one?
No, it is deterministic. So this server prioritizes the first, and OpenBSD's HTTP proxy relayD prioritizes the second. So in this example, I was just like, well, relayD and H2O are vulnerable to this sort of desynchronization attack. And no one responded. And I think part of the reason why no one responded to this, even though like this is a pretty bad bug, is because of how terrible this bug report is. I give no proof of concept. I give no version. I basically just dump some information, and then I just leave it there. And I'm totally unsurprised looking back on this that this got no traction at all. So this is me not taking my own advice from this talk. Here's another one. This one was one that I had reported privately initially. So this is a pretty bad one also. So the HTTP standard says if you receive line feeds that are not preceded by carriage returns, you have two choices. One is reject the message. The other is normalize it into carriage return line feed. The other is if you are not going to forward the message, you can replace that line feed with a space. That's pretty uncommon, but it's like technically allowed. So this one web server, which is actually weird, I'd never heard of it, but it was actually, it's like the #3 web server in terms of number of sites hosted, because it's like everyone's WordPress site is this for some reason. It's a weird one. But the gist of the bug is that they don't normalize line feeds to carriage return line feed. And you can do really interesting desync attacks using this primitive. And I feel like I made a very good bug report. I said how it violates the RFCs. I describe the behavior. I give reproduction steps. And yeah, end of the day, no one cares. I reported like 10 bugs at the same time as this one, and the other 9 were fixed. And this one, I was just told, we do not feel it needs to be fixed. And yeah. So, I mean, like, at the end of the day, like, this is fun to play with, and it leaves me an interesting demo showing how you can use this to do interesting attacks. But, like, I would really prefer for it to be fixed.
I was curious, you spoke about the bug bounties, the 20K. Do you look for, like, public ones that are looking for people to look for exploits, or you're getting the bounties just by finding things and things you're interested in? What are you doing in that area?
So I'm really more interested in writing tools. So I'm just going to write a tool that's as generic as possible and that can target as much stuff as possible and just sort of reap whatever comes out of that. And sometimes that means passing up a lot of opportunities. So I'm not usually seeking out bug bounty programs and like trying to find how does this company do that task. Most of the time, I'm just writing something very generic, finding as many bugs as I can, and then when I go to report them, if I see there's some channel to report security bugs that has attached bug bounties, I might use it, but sometimes it's so much more work to go through that channel that I still won't. But yeah, so those bug bounties, they were from Google's cloud vulnerability reward program. They're even some bugs that I thought like really didn't matter at all, they were willing to pay out for, which is sort of interesting. So if you're looking for to get involved in bug bounties, that's not a bad place to start. Oh.
Given that you've done so much analysis and deep diving and reproduction steps, when is the point that you fix this bug?
So this bug, in particular, I will never fix. And the reason for that is that this is fake open source software. So here, they claim that it's like free software, but they never merge any pull requests. And they just dump out code every couple months. So like this is like within their rights as a company to do, and I'd rather that they dump this code than that they keep it proprietary. So I'm happy that they do this. At the same time, like I know that if I submit a pull request, it will just be ignored. There are pull requests on this project that never get merged or are closed after years. So I have no hope that the maintainers will actually fix this problem. But in general, like in a more reasonable project, it's going to be a function of how comfortable I am with the code base. So if it's like a simple Python code base or a simple C code base that I can reason about, then I'm happy to fix the bug immediately. But if it's some terrible hierarchy of classes, then I will just report, and I'd rather provide lots of analysis than get involved in a tangled web like that.
Do you test Rust code, and you do find that significantly find significantly fewer bugs in that, or?
Yes. So I have 1 or 2 Rust libraries that I test. One is Hyper, and I found one bug in there that was really, really minor, and they fixed it quickly. And the other is Pingora, which is Cloudflare's HTTP library, and that actually has some pretty significant parsing bugs. So, like, there are fewer. You're not going to find the sort of undefined behavior types bugs in Rust as easily, unless they're using a lot of unsafe. But bugs that are just parsing bugs, you can still make those mistakes in Rust, but it's not as common as making those mistakes in C. So I would say I do see fewer. It's not 0.
Kind of in reference to this last one you just mentioned, you said that they wouldn't take any pull request. You mentioned earlier about forking the project. At what point would you consider doing that?
So if I used this web server and I was a big company, I would fork it 100%. I wouldn't trust these people at all. If you look at their release notes, they're always like block hacking attempts. It's very unprofessional. The people who are like responding to their security reports really don't know what they're doing. They make a lot of very strange choices. I really wouldn't trust. It's very difficult to even compile this code. So they distribute a binary. If you try to build it yourself, all sorts of weird problems. You have to use Debian 10. Like, it's just the worst. I would 100% fork this if I cared about this web server at all. But because I'm just testing it because other people use it, I personally won't fork it myself.
Are there any other questions?
Over there. Oh.
No, I found one bug, and they got on the line with me, and they reproduced the error I did, and they had to rewrite a whole module.
That's tough.
Was there another one?
There's someone in the back over there.
So it sounds like you said that Rust is one of the better, maybe the best. I'm curious what first of all, if you think it is maybe best is not the right word, the one that you come across the least bugs in, and then what would be the one with the most bugs that you, in your experience?
So most is 100% C. I think that one we should all expect. Least is harder. Rust has fewer bugs in these sorts. At least I'm only looking at HTTP libraries. So take this. You shouldn't generalize this to everything, but at least Rust's HTTP libraries don't have a ton of bugs, but they have some. Go has significantly fewer than that, and that's because they put a good HTTP library in the standard library. So then everyone just uses that, and you don't have all these different implementations. You still have a few. There's like one sort of large HTTP implementation in Go called fast HTTP that has lots of bugs. But in general, there's kind of 2 paths to being bug-free on these sort of protocol problems, and one is have a good language that's hard to write bugs in, and the other is just have somebody competent write a good implementation of that protocol and put it in the standard library and just batteries included, put it along with the language. So I would say Rust and Go are good choices.
So in talking about languages, we know what you like and what you don't like. What do you think about Python?
Yeah, so Python, you get a lot of weird issues, especially around exceptions. So Python's exceptions are really hard to reason about. It's pretty easy to find, even in the standard library, uncaught exceptions that bubble all the way up to the top and cause the program to crash. And I reported one of these in CPython, and I was basically told this was fixed by accident in the next release. And so I could see if I could find it. But they fixed the bug. They weren't trying to fix that bug, but it was fixed, and it was the bug that I'd found was it affected 3.10 and not 3.11. And they said 3.10 is going out of support tomorrow, so we won't fix the bug for that reason. And that was fair. The other really big problem that you see a lot in Python code, especially with network parsing stuff, is integers. People love taking stuff from the network and passing it right into the int function. Really bad idea. Because the int function, if we have Python on here, I can even show. Oh no, we don't have Python on here. Well, you'll have to believe me, the int function will take lots more than just ASCII digits. So you can give it Unicode. You can also give it arbitrary amounts of white space on either side. You can separate the digits with underscores, and you can, plus and minus are also accepted. So you can get all sorts of weird things with, also if you're inting in base 16, then you can prefix with 0x. So you can get these interesting discrepancies where you have one server that is interpreting, like, let's say, an HTTP chunk length, which is a base 16 number, by just taking that string and just dumping it into the int function. And so it's going to, if you put a 0x on the beginning of that chunk size, it's just going to ignore it. But an intermediary server might try parsing that same string using an int parser that just goes and parses hex digits until it hits something that's not a hex digit, and then just treats that as the number. So if you have 0x, that's going to be treated as 0. But in Python, 0x something will be treated as something. And this is actually a bug that it was like the majority of Python web servers I looked at had that problem. Same with Python URL parsers, port numbers. People just take the whole thing and put it into int, and that is not a very good idea.
All right, we are out of time for this session. Thank you.
Good morning, everybody. My name is Kyle, and I have the pleasure of introducing Brad to you. Brad, I have known for a few years now, had some wonderful conversations with him. He is a solutions architect at Red Hat and an automation evangelist, and is here to chat with you about the importance of properly structuring your architecture projects. So please welcome Brad.
Cool. Yeah, thanks for the intro, Kyle. Really appreciate it. Like Kyle mentioned, my name is Brad Crumey, and I am a solution architect at Red Hat. What that means is I go out and I talk about technology with a bunch of enterprise customers and try to convince them to buy Red Hat stuff. I'm not here on behalf of Red Hat today, though. I'm actually here on behalf of automation and the good things that we can do with it. So I'm going to share a little bit about kind of my philosophy around automation projects, specifically about how we organize our automation code. The tool of choice that I'm going to be showing today is Ansible, of course, Red Hat product. Can you blame me, right? But you can actually apply this using any tool you want, right? So you don't have to use Ansible for this if you don't want to. The method actually works for everyone. Let me start with a little bit about myself. First and foremost, I'm a native Ohioan. I was born and raised in Cincinnati. I will probably live in Cincinnati for the rest of my life, which consequently is a very common thing to hear about Cincinnatians. I have over 2 decades in tech. So prior to starting at Red Hat, I ran production environments. I actually did the work. I was a Linux sysadmin for a long, long time. And I consider myself a super nerd, although Ben, who was just up here before me, he like beats me in that category for sure. I don't get into C or Rust or any of those other languages. I do a little bit with Python, but not quite to the level he is. So excellent, right? I enjoy whiskey, so if you also enjoy whiskey, we can talk about it afterwards, especially like bourbon, but I don't discriminate. I'll drink scotch as well. I am the father to 2 humans, both of whom are adults now, and I'm also the slave to 2 felines, which is important for some of the conversation we're going to have today. You'll see why here in just a little bit, right? So I like to start all of my talks with kind of illustrating an example of the concept I'm trying to kind of teach you about, right? And this talk is about patterns, specifically embracing patterns in the designs of our application and IT service architectures. To illustrate that, I want to start with a definition and then go through a few steps to kind of show a pattern that doesn't have anything to do with technology, and then apply the same method to technology as well, right? So here's a definition of pattern. If you look the word pattern up in the dictionary, you'll find probably like 5 or 6 different definitions. This is one, specifically a natural or chance arrangement of component parts, traits, or elements. And since we're talking about natural or chance arrangement, I thought it was appropriate to talk about something maybe from the animal kingdom. So let's do that. What I've done is I have compiled 3 relatively simple traits that you'll find in animals throughout the animal kingdom, right? You guys get to guess. So this is interactive. You guys get to guess what animal I thought of when I chose this trait, all right? So first one, slender muscular body. What do you guys think? You guys are getting really, really far ahead. Actually, I thought about snakes, right? In this case, it's a Burmese python. Really slender, very, very muscular. If you've ever dealt with a snake, especially a python, they are very strong. Okay, next. Strong, flexible forelimbs. What do you guys think this one? Monkeys. That's actually a good idea, right? So somebody said monkeys. In this case, how about strong, flexible 8 limbs? It's an octopus, right? If you've ever dealt with an octopus or seen what they can do, they're very strong as well, right? Last one. Sharp curved claws. What do you guys think? Eagle. Really, really close. I chose a hawk, right? And you guys are kind of getting a little bit ahead of me, I think, because somebody said cat earlier. But let's put all of these together, right? And see what we get, right? So if we take our slender muscular body, right? And our strong flexible forelimbs, and our sharp curved claws, what do you think we get? That is a cat. Right? And in this case, we have what looks like a relatively typical house cat, right? So we didn't really describe a house cat, though, did we? We just described any cat. But what do we do if we want to describe a house cat or a different kind of cat? Well, we have to add detail, right? So let's add some detail now, right? First detail, the cat needs to weigh 300 pounds. That's a big cat, right? Yeah? Here's one that a lot of people don't really think about when they think about cats. Its eyes need to have round pupils instead of split. We're very used to seeing cats that have split pupils, right? Well, what cats have round pupils? Well, just so happens that it's all the big ones. So we added a couple of criteria, but we really didn't narrow things down other than, hey, it's a big cat, right? So this last one, I think, should narrow it down to a specific cat that we're looking for pretty quickly. It needs to have orange fur with black stripes. Tiger, right? Yeah, it's a tiger. But for the purposes of what I'm talking about today, the fact that it's a tiger isn't the important part. The fact that it's a cat is the important part. Because when we talk about automation and we talk about patterns, we want to try to dissect our patterns and use the most common denominators in order to enable the services we're enabling for our customers, right? All right, now that we've done this, let's do the same exercise, but we'll do it with tech, right? Real quick before that, though, I want to make sure that we kind of cover a different definition or a modification of the definition of a pattern. Well, in nature, things are natural or chance, right? The patterns that we see, they happen, I won't say arbitrarily because it's probably not the right word, but they happen naturally, right? In technology, things don't happen naturally. Things happen the way we want them to happen. We decide what the arrangement of component parts, traits, and elements are. So I just took that part out from the beginning of the definition, right? It's the same thing, just a couple less words. So let's apply that same method to IT service and its parts. First one, web-based front end, right? What might we have that is a web-based front end? Anything. Ben before us was talking about HTTP libraries, right? So he was talking about a lot of web-based front ends. In my case, I chose Node, right? Because that's a place where you can put, web-based code that will provide a front end, right? Next, API-based backend. What do we choose here? Any choices? Anybody have a backend of choice that they like? No? Okay. I choose Wildfly. All right, if you're not familiar with Wildfly, it's the upstream project for JBoss. All right? So you can get JBoss for free. And then extensible relational database. MySQL, good choice. I chose Postgres. Right? So let's continue, right? This kind of lays it out for us already just because I've chosen the components. But let's do the same thing. Let's add some detail, right? Our web-based front end is our presentation tier, right? Our API-based backend is our logic tier. They serve different purposes, right? And then our database is our data tier, right? Overall, though, what is this? What am I describing here? Web application, I'm hearing. Multi-tier app, 3-tier app, whatever you want to call it. That's what I'm describing. The individual components could be whatever you want them to be. At the end of the day, though, it's still a multi-tier application, so we're still following that exact same pattern, right? Let's add some details. Do that again. Presentation tier is HTML. I don't know who's going to use HTML in a presentation tier anymore, maybe a little bit, but mostly we're using other languages at this point. The logic tier is .NET. Ew. Right? Right? And then our data tier is SQL Server. Double ew. Right? So what are we describing here? Right? Microsoft Web Application, exactly. But the point is, exactly like with the CAD example, it's a multi-tier app. Right? Now, I don't often talk to customers that do things with Windows. I'm usually talking to their Linux teams or their operations teams who are working on Kubernetes or in the clouds. But this comes up every once in a while, right? The important part, like I mentioned, it's still a multi-tier app. Right? So how do we view our IT services and applications, right? So let's make a comparison between the way things happen in nature or biology, like the animal example, and how we might do things with technology. With biology, we have biological taxonomy. Who took biology in high school and remembers this taxonomy, right? Pretty much everybody, right? Now, I was talking to a gentleman yesterday in the hall who said that they do things completely differently now. They use the genome to decide this at this point, right? Which I didn't know, so my slide is already out of date. But, but the point here is we have layers, many layers that as you descend down this ladder, each layer becomes more and more specific or more and more unique, right? We group organisms based on the genome at this point, I guess, but on shared characteristics, right? So those organisms that have the shared characteristics toward the top are going to have more. The more specific we get, they're going to have less and less and less shared characteristics, right? And the lowest step on the ladder in this case is an individual species, right? So if we apply that same taxonomy, but instead of biology, we do it with technology, right? First thing is, it's a whole lot less complex. We have way fewer layers, right? You can group your components based on their function, what they do, right? And then you can subdivide those functions into different types, right? And I'll give you guys good examples of this here in a little bit, right? And then the lowest step on the ladder is a specific application stack. Not just an application, but the entire stack, the entire landscape of that application, right? Same applies here, though, with the biological taxonomy and the technological taxonomy. The further down the ladder you go, the more specific you get until you're at a unique application or landscape, right? So let's go into more details about the technological taxonomy, right? A function, right? So we had kingdom, phylum, class, et cetera, in the biology side. On the technology side, we start with a function at the very top. You could think of a function as the high-level purpose or role of a layer or a component of your application stack. So think web server would be a function. Database server could be a function. Server, just operating system, Linux operating system could be a function, right? So these are the high-level components. If we go down the taxonomy and get a little bit more specific, we go into a type. Let me get past this little animation real quick. And the type is going to describe the composition or variety of that particular function, right? So instead of just web server, we have Apache web server, or we have IIS web server. Instead of database server or database instance, we have Postgres database, or MySQL database, or DB2 database, right? And then we go one more level down, and we have what I call a landscape. Now, this is often referred to in Ansible land as the site configuration. So you can call it that if you like. But the landscape is really the specific implementation of a large set, or a set, it doesn't have to be large, of functions and the respective types that you've chosen for your particular app. So you can see, as we're building these things out, you can see the patterns emerge with everything that we build, right? Because not everything uses the same type across the organizations that we're trying to enable. These landscapes are the snowflakes, right? These are the individual things that are going to be very, very unique in our environment. Okay? At this point, you're probably thinking, okay, we were going to talk about automation, right? And we haven't talked about automation at all. So yeah, let's actually get into the automation part, and I'll show you how the pattern here applies with Ansible. All right? So let's kind of translate some of those different components or different ideas with what we do in the world of Ansible. So functions, as the building blocks of our application stacks or the building blocks of our landscapes, they get converted, well, not converted, but they get represented in Ansible as an Ansible collection. So quick show of hands in the room. Anybody familiar with Ansible, use it on a daily basis? Oh, excellent. So you guys are probably familiar with kind of the history of Ansible a little bit. Up until 4 or 5 years ago, everything that you could do, that you could automate with Ansible was included in the main Ansible package, right? 2019 came along, and we decided at Red Hat, of course, because it's our project, we decided we're going to split that stuff out. The main reason for that is so we could actually do more rapid releases of the Ansible core engine. And we weren't beholden to all of the community or third parties to release Ansible because we were waiting on content from them. right? So we separated out what we call content collections and made it more modular, which has actually accelerated the release cycle for the Ansible core engine significantly. And it's also made the community around automation content from our partners much, much better as well, right? But a collection you could think of kind of as just a way to group automation capabilities that are alike for a particular use case. So think Cisco iOS, for example. There's going to be a collection for Cisco iOS. Or Nginx has a collection for all the Nginx stack, right? Types, since we're getting more specific here, our types gets translated into Ansible land as an Ansible role. So for those of you who said you're familiar with Ansible, you've probably seen Ansible roles before, right? It's one of the common things that we try to use as much as possible. There's a huge community around it on Ansible Galaxy, where you can consume roles. You can actually consume collections out there as well. Thousands of them that are available out there. So in a lot of cases, you might not have to do this yourself. But those types, like I mentioned before, are the individual implementations of a particular function. So instead of just being web front end or web server, we're going to have web server and then Apache web server or IIS web server, right? And then landscapes, going down the taxonomy a little bit further, are combinations of those functional types that we've chosen for our particular IT service or application, right? And those in the Ansible world are represented as Ansible plays and playbooks. You could write it all into one big playbook if you wanted to. You could also write it into multiple playbooks, one for each function, and then combine those playbooks into a playbook of playbooks using includes. Right? So what does this look like? Let's give you an example of what an Ansible collection looks like. Right? So this, I used a tool that just was released a little while ago called Ansible Creator. If you're not familiar with Ansible Creator, it is available for anyone who wants to create an Ansible project, either for a collection or for a playbook project. It'll initialize the entire directory structure for you, put things in the right places so you don't have to worry about creating it all yourself. It'll do other things like add a dev file if you're using dev spaces. It'll give you a dev container file if you're trying to code in dev containers in Visual Studio Code as well. It'll automatically configure that for you, which is awesome. So let's go through this collection project or repository. You guys are using source control for your Ansible, right? Yeah, good, okay. And talk about what this is. So at the very, very top level of the directory structure here, it's called front end. So this is the name of the collection, and it matches our function. Right? So we have a front end collection. It's going to configure our front ends or our possible front ends. Right? Going down the stack, that collection might also include Ansible plugins or modules. So for those of you who already use Ansible today, the collections that you pull in from Ansible Galaxy, you're probably using them in order to get to the modules that have been created to do automation work. Right? You're probably still going to do that. But that's not the only purpose of an Ansible collection. The other purpose for an Ansible collection is exactly this, is creating a place to put roles that have a similar kind of use case so you can put them all together and call them as one namespace. Right? For use cases that don't have modules or plugins available in the Ansible community, you can create your own as well. They're written usually in Python, but if you're doing things on Windows as well, PowerShell. Okay. And the collection is also going to include the Ansible roles that we talked about, one for each type of that particular function. So in this case, we have our front-end collection that provides a front-end function, and then we have three types. We have an Apache type, an IIS type, and a Node.js type. Right? So you can start to see how we can kind of collapse these patterns we use into more manageable chunks of automation code and repositories, so it becomes easier to use long-term. Let's do the same thing with the Ansible role structure. Now, I'm not going to go into the individual files inside of the Ansible role itself. I'll explain a little bit. But from a role perspective, you'll notice that we have the top-level directory is front-end roles. And then inside of there, we have a directory for each of the roles that we're going to include in a particular collection or for that function. Apache in this case. And each type, if we're using taxonomy, each type has its own role. Right? So now, we have an Apache role, we have an IIS role, and we have a Node.js role. Right? The role functionality gets modularized. Right? So if you're not familiar with Ansible, the entire purpose of an Ansible role is to create a shareable, standardized way to automate a particular thing, right? So in this case, we have the example of Apache. This would be a shareable, standardized way to install and configure an Apache HTTPD web server, right? It's going to have defaults that are included with it. It's something that's very important when it comes to Ansible roles. You'll set what your default configuration might be and set them as variables in this defaults directory here for Ansible. You could think of the defaults as the same kind of configuration that if you were to use this role in an Ansible playbook, right, without any parameters set, without any kind of variable set, these defaults would take over and be what end up being applied to your configuration. Something that I tell my customers pretty regularly as well is the separation of your automation function and your configuration is really, really important or imperative. So you'll notice I gave you examples of a collection, I gave you examples of roles. I didn't give you examples of playbooks quite yet. The reason is we want to keep that separate because our playbooks, our individual configurations, the variables that we set for our landscapes that we want to configure need to remain separate from our functional automation code, right? Our automation code is what it is. We need to make sure that all of our site-specific data stays separate, all right? So let's give you an example of a playbook project. I mentioned Ansible Creator before. You can create a collection project or you can create a playbook project. This is what a playbook project looks like pretty much out of the box. I've renamed a couple of things just to let you guys see it, right? So the project name is going to match the landscape you're trying to apply, right? So this could be, in my case, awesome app. It could be application 123. It could be financial services payment app or something like that, right? The collection requirements are defined inside of this project. We're not defining the collections or putting the collection repositories or directory structures in this project. We're just referring to them using a requirements file that says, I need to pull this collection in from here. From either Ansible Galaxy, pull it in from Ansible Automation Hub. If you have a tarball of the collection that you've tarred up and said, hey, we're going to go get it from this web server, you can do that, right? Your inventory is a directory structure. I'll explain why this is important in a little while. But your inventory is going to include your to-be configuration. This is the configuration you want to apply with your Ansible project, right? And your variables get defined in subdirectories called group_vars and host_vars. We'll go into a little bit more detail about that as well. Okay? Then you're going to have playbooks for each function of the landscape. I mentioned this before, but you'll notice in the example here, I have a front-end playbook, and I have a back-end playbook, and I have a database playbook. One for each of the functions in my three-tier, multi-tier app. Right? And then we also have a consolidated landscape playbook. This is often referred to as site.yaml instead of landscape playbook.yaml, which is a playbook of playbooks. And that can be used to configure the entire stack of the application. Every single server that might be included in an application, or maybe it's a container and you have to configure it. Maybe it's a Kubernetes namespace that you're deploying to, would be considered, be included in one of those function playbooks and then included in the landscape playbook. Okay, so let's talk about organizing the site-specific data a little bit. Okay, the first thing you want to make sure you do, and this is just a good practice, right, is identify your single sources of truth, or just sources of truth, because you might not have a single one, and use them for your Ansible inventory. Right? So if you have a CMDB or an ITSM tool that keeps track of your systems, use it. Right? There's no reason to reinvent the wheel and write a big old text file out with your Ansible inventory when you can run a Python script and grab everything from your CMDB. Right? The data from those multiple sources of truth should not overlap or contradict each other. This should be pretty self-explanatory. If you have conflicting data, you're going to have conflicts with your automation. Right? Conflicts when you're building your inventory. And then you should combine your single sources of truth into one inventory using a dynamic inventory plugin. A lot of the collections that are out there from third-party vendors, think ServiceNow or Cisco, they include inventory plugins in order for you to build your inventory dynamically from a source. AWS has one, Google has one, Azure has one. So if you're working in any of those clouds, you can build your inventory based off of what you've got in EC2 already. Right? Next, we want to differentiate between our as-is and to-be information. Right? So when it comes to Ansible, at least, we collect the as-is information mostly in the form of Ansible facts. So it's facts about a system that exist already. They're inherent to that particular server or system that we're automating against. And by default, we collect those when we start an automation. Right? You can turn that off if you need to. We could also have an as-is kind of project, if we want, that defines what our desired state is. Right? And then when we automate, we can then transfer the automated to-be into the as-is. Right? The managed to-be information gets represented as variables in your Ansible inventory. Right? So it's a project directory that you have all your playbooks in, and you have your inventory in, and you have your variables in. So it's one place for you to modify your to-be architecture, your to-be configuration. I already mentioned this, but define your Ansible inventory as a structured directory instead of a single file. The main reason for this is because it's easier for you to go look and say, hey, what's the variable that's set for this particular system in my inventory, or for this group of systems in my Ansible inventory. Right? And then restrict the usage of variable types. So this one is really, really important. In Ansible land, there are 22 different layers of variable precedence. If it sounds like a lot, it is. Right? The method that I'm showing you here narrows that down to 3. So you use group variables in your inventory, host variables in your inventory, and then your defaults that are defined in your individual Ansible roles. Right? You want to avoid scoped variables and extra variables. So scoped variables are ones that get applied for a particular scope in Ansible somewhere other than where you want them defined, right? And then extra variables are ones that you pass on the command line when you're running your Ansible playbooks, right? You want to try to avoid running, putting variable data on the command line if you can. You should be able to. So let's take a look at inventory a little bit deeper now as well, right? This is a pretty typical Ansible inventory file. This one is YAML formatted. For those of you familiar with Ansible already, you'll know that the typical format for an Ansible inventory is INI format, right? Essentially, it's just a list of the systems that are in our inventory that we want to automate against. This one's formatted in YAML. It could be in INI. It could be in JSON as well. At the end of the day, when Ansible looks at your inventory, it translates it to JSON anyway. Right? So you'll see in the inventory here, we have a list of hosts. We have, at the very top level, a group called all. And we have the hosts that are included in all. Then we have the children of the all group, which is pretty much any other group in our inventory, which includes web servers, app servers, DB servers. Each of them has their list of hosts as well. Right? Each function, since we're talking about automating a particular application stack, each function in your application stack should have its own inventory group in the inventory. That way you can apply that configuration for that function to that group very easily with a single play. The variables need to be set in your group vars and host vars instead of the inventory file. So you can actually set variables in this inventory file if you want to. But if you start setting variables here, it becomes really, really messy. Right? So putting them in the subdirectories is a way, way better option. Right? It simplifies variable precedence as well. Like I said, instead of 22 different levels of variable precedence, you're down to 3. The other important thing is inventory groups can contain other groups, right? So you can do nested groups of hosts in your inventory. You can do intersections of groups when you target them in Ansible, which is really, really awesome. So you could say something like, I want to automate against all web servers, but I have web servers that exist in 3 different data centers. But I only want to automate against the systems that are in web servers and also data center 1. You can do that. Or you could say, I want to do web servers, but not servers that are in data center 2, for instance. Those are the kind of things you can do in your playbooks when you're targeting your servers to automate against. Okay? And of course, individual hosts, like I said, they can exist in multiple groups as well. And for those of you who are Red Hat customers, if you have the same host in multiple groups in your inventory, it still only counts as 1 license. If you do it right, yes. Yeah. All right. So let's give you examples of inventory variable files, right? So each group is going to have its own group vars definition file, right, where the variables are set for that particular type. You could actually set variables for multiple types in this if you want to, and then you can use conditionals to determine which type you're going to apply to a system, right? So in this case, we have web servers and DB servers that have some variables set for the Apache listen port and also the SSL listen port, right? And then for the database, we have our Postgres listen port. Now, these are all defaults, of course. If we wanted to set them to something different, change the value of the variable, right? Relatively straightforward. Okay? The variable names and keys should be meaningful, right? So this is something that's another good practice that came from the Ansible community of practice a long, long time ago. Your variable names and keys should match the role that you're calling. So, or at least have a prefix for the role that they apply to. So in this case, we have Apache HTTP port and Apache HTTPS port. Well, that prefix to those variables matches the Apache role that we're using from our front-end collection. Right? Same thing with Postgres. The PostgreSQL listen port matches, the prefix matches the name of our PostgreSQL role from our database collection that we created. Right? Then, of course, variables that apply to all hosts go in the all.yaml file in your group vars directory, right? So you can apply something to everything if you want to. In this case, we're setting the application version or app version, right? That one is one that is not doesn't have a meaningful prefix. Maybe we use it across all of our different roles that we're applying, right? And then, of course, individual hosts can have their own specific variables in the host_vars directory as well. So if we want to set something more specific for just one system or just one or two systems, when we have a group that includes 100, we can go set that for that individual host in its representative file. We've got some playbook examples as well. So let's go through those. So the functions are going to get contained, like I mentioned before, in their own individual playbooks that call the role for the individual type. So these examples you see on screen would be the entire playbooks. The first one, for front end, we have an entire playbook that'll do the whole thing because we've separated our automation logic from our automation configuration. Right? So that one says we want to configure front-end web servers, and we're going to do it on the web servers hosts. Right? Become means we're going to do privilege escalation and do this as root because why not? And then we're saying, hey, the role bpcrewme.frontend.apache is the one we want to apply to this server. Right? The playbooks can include other roles as necessary for the host. So, for instance, if this is all on Linux architecture or Linux infrastructure, and you use the same distribution across all of your systems and you've standardized the configuration for your Linux hosts, you could create a collection to do your standardized Linux configuration. It could be called like, my name here .linux as the collection name, and then you have roles for everything that you apply under the covers. Maybe time synchronization. You could have a time sync role. Maybe disk configuration. You have a disk configuration role, right? And then you can just put this in a list in these playbooks and say, hey, we're going to apply our Linux time config and our Linux disk configuration roles, and we're going to do our front-end Apache role. Right? And it can do it all in one go. All right? The functional component playbooks then get aggregated into a single landscape. And this is what the entire landscape playbook would look like using this example. It's just a YAML file that says Ansible built-in import playbook, and then you give it the playbook name. It runs them in order. Right? So this actually probably isn't the right order. We probably want our database first. Right? But we can make things very, very simple if we start using these patterns and applying things using just a couple little rules around our Ansible projects. So how do we scale? Right? Because if we're talking about enterprises or we're talking about commercial use, this is going to have to scale. We're going to have to be able to use this over and over again and be able to have multiple teams consuming the automation, right? Okay? The patterns follow your architecture. This is something that's very, very important. Before I came to Red Hat, I worked in a production environment for over 20 years, right? We had the same patterns of applications that were used over and over and over again. Now, we had like 15 different patterns, but we used the same things over and over again, right? Every once in a while, we would have something else that we needed to add to a particular application stack. The cool thing is those new architecture elements can become a new function. So for instance, if you have to add a data caching layer with something like Redis, you could create a data caching function or data caching collection that has a Redis role, and then apply that configuration to the appropriate systems that need to have that Redis function applied or that data caching function applied. Right? And this new functions become new Ansible collections, like I mentioned, and then new types become new Ansible roles. Right? So you can just rinse and repeat with these new functional components of your applications and do it over and over and over again. Right? Now, I don't know about you, but when I was working in a production environment, and every customer that I talk to nowadays, they have multiple teams, and each team is kind of siloed into their own particular use cases, right? Well, the good thing about this is domain experts can remain domain experts. And more importantly, each team can create and maintain their own Ansible collections, right? So if you have a web infrastructure team, they can create the collections for doing web infrastructure. If you have a networking team, they can do create all the collections for doing networking, and so on and so forth. There's no reason to have one centralized team do all the automation. Now, the uphill battle with this is getting all those teams to adopt Ansible as the tool they want to use, right? But if you show them how easy it is, usually at least one person on that team is going to say, yeah, I want to do this. Usually, not always. The next thing is something that you can do. Publish, share, and reuse the collections and roles that you create. There's no point in creating this and trying to automate and trying to scale it if all you're going to do at the end of the day is have every team create the same stuff over and over again, right? So publish your Ansible collections. Create a release as a tarball on GitHub if you want to. If you're using GitHub Enterprise or GitLab or whatever, you can create a release there. Upload it to Ansible Galaxy if you're allowed or if you want to. Right? Ansible Galaxy is the community for exactly this. Share your collections out to everyone else so they can use them too. Right? If you are a Red Hat customer and you have Ansible Automation Platform, we include Private Automation Hub for this. The upstream project for that is called Galaxy NG. So if you want to enable it yourself without paying us, you can go get Galaxy NG and publish all your stuff to a centralized location on your own. Share your Ansible collections. Make automation functions available to everyone else. This is going to require a lot of evangelism from inside of your organization if you're working somewhere. It's going to require somebody who's pushing the idea of let's use Ansible, let's use these Ansible collections, let's not reinvent the wheel, let's standardize the stuff that we're doing and do it over and over again exactly the same way, right? That'll help to enable standardization through democratization. Because as you convince more and more teams to adopt this method, to adopt using Ansible, or whatever tool you choose, it doesn't have to be Ansible, then everybody can be on the same page. And all of a sudden, you're talking the same language when it comes to enabling your infrastructure or enabling your applications, which is a beautiful thing when everybody's on the same page. It doesn't happen often. And then reuse your Ansible collections as much as possible. Don't reinvent the wheel. Only create a new collection when there's a new function that requires it. And of course, roles when there's a new type inside of that function. This also kind of helps you prioritize some of the things you need to do. So I don't really touch on this, but I'll mention something about it. When you have a function that you use regularly and a role inside of that function that you use regularly, and you all of a sudden have a need for a different type. Let's say you're doing Apache web servers and more Apache web servers and more Apache web servers, and then some team comes along and says, no, you know what, we want to use Nginx. You can just create a new type when you need to, create a new role when you need to, and put it into that collection. Do all the testing of that behind the scenes, and then all of a sudden, creating the playbook to do Nginx becomes really, really easy. And in a lot of cases, you might not even need to create it, because I know Nginx releases a lot of their automation stuff on Galaxy already. Right? And with that, time for Q&A. Any questions?
Are there any questions? Oh.
Yeah.
Excellent talk. Thank you.
Thank you.
So at the end, I was hoping you'd get into more of how do you manage the interdependencies between the collections? How do you install them? How do you maintain them?
Okay.
If I got things like I got to make changes to my playbooks, but now it's in a collection and a role in there, but I'm not, someone else is writing that. How do I change it?
Right.
Do you
Yeah.
get submodules? Do you put everything, that sort of thing?
Yeah, so I don't really go that deep into it, but I can talk about some of those things a little bit. The first thing to kind of touch on, how do you manage the dependencies of your collections and those sort of things? Along with that separation of Ansible engine and the content that was shipped along with it, we introduced a way to kind of manage dependencies in a more, we'll call it cloud native way. And what we did is we introduced what's called an execution environment, right? Two reasons for that. The first one is the prior way of managing all of your dependencies was using Python virtual environments. And if you've ever worked in a Python virtual environment, it's a pain in the butt. And when we're talking about scaling across an enterprise, maintaining a Python virtual environment on one machine is pain enough. Doing it across 3, 4, 5 machines that are doing all of your Ansible is even worse, right? So what we did is we created this concept called an execution environment, which is a really fancy way, or not really that fancy way, to say a container image that has everything in it, right? So what you will do as probably another project or a sub-project of your collection is you'll create either a subdirectory or have it in a completely different repo, the configuration for your execution environment for that particular function. Right? And that execution environment is going to include the collection requirements that it needs. It'll include the Python library requirements it needs. It'll include the version of Ansible core you want to use. It'll include any binary dependencies you have. So if you have a command line utility or something you want to use, maybe you're using Git to pull something down and do things with data. You can install Git inside of there as well and do those things you wanted to do. So you're going to have another project for that execution environment. And then you'll use the Ansible developer toolset, which is available from PyPy, Ansible-dev-tools. It'll install every single Ansible developer tool that you need, except for the Visual Studio Code extension. Then you'll use Ansible Navigator, which is our new kind of CLI text-based user interface for interacting with Ansible. The reason for that is because you can use execution environments right on the command line, right? So Ansible Playbook is still there, still under the covers. You can still use it if you want to. The disadvantage is you have to maintain all those dependencies on one system in one Python virtual environment, or manage Python virtual environments instead of execution environments. Yeah.
Any other questions? All right, I didn't see any in Slack, so thank you.
Awesome, thanks guys.
No. No. Okay. All right, you guys hear me now? Yes. All right. So originally with this talk, I had a bunch of slides prepared, but I'm going to probably be skipping over a lot of them because I did a dry run the other night of this. And I found that with the demo and the background of everything, it took about an hour, and the time allotment is 50 minutes. So I'm going to give the TLDR of it. First of all, let me introduce myself. My name is Justin Ehrlichman, and I currently work. I'm based out of the Pittsburgh metro area, and I've been in the IT field off and on since 2003. I currently work as a senior level IT support specialist for a company called Schneider Downs, which is a CPA firm located in the Pittsburgh area, but they also have a presence here in Columbus. I want to thank my coworker Bridget for helping me with some of the physical stuff and providing feedback for me. So in my job and all my IT roles, I am very deeply entrenched in the Microsoft world, so much so that at one point I was working as a contractor for Microsoft, providing Microsoft 365 support. But I have a very soft spot for Linux and all things free and open source. And one of my favorite things about my current role is I get to automate things through PowerShell, like Active Directory, Microsoft 365, and Exchange Online. And I also have experience with PHP and the LAMP stack. So I'm going to skip a lot of these slides, and I'm just going to give you the TLDR version of it. So basically, I love using Linux on all my home machines. And an application I really like playing with is GarageBand. Who here has ever used GarageBand? Oh, good. Okay, good portion of the room. Okay, so you know, I wanted to bring that experience to Linux, and I was doing some research on some different DAWs, and there really wasn't any DAW that provided that experience out of the box. So knowing what I know about open source and how it can be modified or extended, and how DAWs use different, you can use different plugins with DAWs, I was looking for a way to achieve that. And being the strong-willed, determined person that I am, I found a way to do it through Ardor and their Lua scripting. So, so I'm just going to get right into the demo just for the sake of time. So one of the, I have different goals for this project. My project, in case you didn't see it on the other slide, is called Logical Ardor. And it gets its name from the fact that GarageBand is basically a stripped down version of Apple's Premiere DAW, Logic Pro. We're just going to get right into it. So when you, actually don't mind me looking at my phone because I have some notes in here that that keep me on track. So when you first launch Ardor, normally, it looks a little something like this. So, you look at them, and somebody who's new to music production like me is looking at this like, what do I do here? Like, what is all this? So, one of my goals was, to have this little menu pop up so I can do various things and make it a little more obvious like GarageBand does. So I'm going to launch Ardor, and then what happened to Ardor? Oh, there it goes. Okay. And so you have this little menu system that pops up. So, I can choose what kind of track I want. I can choose a drum track. I can use an instrument track. You can record audio or vocals. You can do, a guitar track. And then we have the session player, which I'll show you when we do the instrument portion of it. So let me give you a brief rundown of how Lua works in Linux, or in Ardor. So, if you go to Edit, and then go down here to Lua scripts, you can load in the various scripts you have. They're usually located in two places. One is within your home directory, within your dot files. In the .config file, there's an Ardor file. And then you go to scripts, and you can write your scripts in here. There's also some Lua scripts that come with Ardor pre-installed. So if we go back into the script manager here, let's say I wanted to load a script here. I'd click Add Set, and then you can select the different scripts you have. So each of these various action scripts, they correspond to different buttons over here towards the right. You have the new track over here. You can change the drum kit right here. You can open up MuseScore for sheet music. Detect the key, the audio to MIDI script. This changes the instrument for the session player. This just changes a regular instrument. This changes the guitar plugin. This gets the tempo for an audio loop. And then this changes the vocal presets. This changes the pitch of an audio loop by key and scale. And then we can time stretch an audio loop to a fixed tempo or BPM. So I have a GitHub repo for this, and I'll have a QR code for those of you who may be interested in this project. Just waiting for Vivaldi to load. Oh, wait a minute, it might have already loaded. Okay, so this right here is my my GitHub repo right here, and when it's done, I'm going to have like all the different YouTube links on how everything works, and I have an install script for Ubuntu that basically puts all the files in the right place and configures everything. So Also with the Lua scripts, what you can do is, we'll go back into Script Manager, and we have these action hooks. So you see load guided menu. What that does is it loads up that menu. If you load up a blank session, you can just load that menu up and then pick what kind of track you want. And then I have this autosave snapshot thing that saves it every minute. And that allows it the integration with MuseScore, so we can view MIDI regions as sheet music, since that was one of the goals. So, let's see. Okay, so, all right. So, first thing is we're gonna talk about the drums. So my goal here was to have a wide variety of drum kits available, and to have the drum kits automatically follow an audio loop. I always thought that was a neat function in GarageBand, and that was something I was very interested in replicating. So that was one of the first things I tried to replicate when I first started this project. But before we get into the drummer, I do have to talk about where you get loops in Ardor. So there's 3 different places. Here is the Ardor bundled content. You get this if you purchase a subscription version of Ardor. You get these beats and these chords and these chord progressions. However, those are open source, so I've included them in my install script, and I put them in a folder called Drum Loops, Chords, and Progressions. And I've added some additional drum loops here. We have these drum patterns right here, which are under an MIT license. And then we have my favorite loops, the drum jockey loops, which they're not under an open source license, but they are under a very permissive license that allows me to use them in this project. So, and then another place to get loops is go to Library Downloader, and you can download different loop libraries. And the third place, and this is my favorite part, if you go to Session and then Import, we click on Search Free Sound, and we search for a keyword. It'll search freesound.org for different loops that you can download. So it's gonna ask me to verify my account in Freesound. And then we're going to click OK. And then it's going to download the loop. It's a little slow because the Wi-Fi is not the greatest here, but let's wait for that to load up. And we can play that loop. And then if we import it, it becomes part of your free sound library that you can reference for other projects. So with that out of the way, before I show you the proper way to do drums, I'm gonna show you guys something, another way that I did it. When I first embarked on this project, this is one of the first things I was trying to replicate, and I was a little bit desperate. So I asked the Ardor forum if they knew of any Lua scripts that can follow an audio loop. So somebody suggested the polyphonic audio to MIDI script. So I'm going to demonstrate that here. So I'm going to create a new drum track. And I'm just going to do electronic drums. And then what I'm going to do is I'm going to draw a new MIDI region right here. and then hit the control key and select both the audio region and the MIDI region. And then we're going to hit the audio to MIDI script. And this is a script that I wrote. This is the script that comes with Ardor. And so if we play this, you have drums that are actually following the loop. Now, as you can hear, the drums are following the loop, but in my opinion, I don't think they sound very good, but they work. So let me show you the proper way to do this. So I'm going to get rid of this MIDI region, and I have a script that will estimate the tempo of the audio loop. So we can either set it for the entire project or set tempo markers for the length of the loop. So I personally like to set it for the entire project. And so when we do that, the audio loops don't necessarily follow the tempo set in the project, but the MIDI loops do. So if we go back to drums, chords, and progressions, and we add in one of the drum jockey loops. Actually, I don't want to use this one. I want to use, this one, one of these basic beats. And then we move the end marker over here. And then we can duplicate it so it fills the entire track. And then let's play it and see what it sounds like. And we can come over here and hit the D button or hit Alt-D, and we can change out the different drum kits. And I want to draw your attention to the different synths I'm using. I'm using the Ace Fluid synth and the AVL drum kits. The Ace Fluid synth uses sound fonts, and so does AVL drum kits, but AVL drum kits actually has visuals associated with the drum kit. So if I select the Black Pearl drum kit and then double click on the plugin, you can see a visual of the actual drums. So, and I want to draw your attention to one particular drum sound font I have loaded here called Alyssa's Drum Kits. And this has over 31 different drum kits we can go through. So I'm just going to play this. And then we can go through the various drum kits rather. Okay, so let's say you wanted to edit the loop. So what you want to do, if you want to reveal the piano roll, you hover your mouse over the bottom of the track. And what I've done with Logical Ardor is put in a patch file. So you can have the various drum components assigned to their notes by the general MIDI standard. So if, for example, I wanted to put in a hand clap, let me actually change the drum kit first for one that actually has a hand clap. So we'll go to the electronic drum kit, and we just put them here. And you want to make sure when you're doing this that you have snap turned on, so it snaps to grid and it'll be on beat. So if we if we play this, we'll just play this portion. You can hear the hand claps that I put in. Now, I know what some of you are probably thinking. Well, the tempo's already written in the file name. What if it's not written in the file name? So let me show you that. I'm going to show you one of my favorite lo-fi loops. Let me see if I can find it. It's all the way down here. Ooh. Right there. And so I'm going to get the tempo of that. And it comes back with a tempo of 100. So if we play it, you can see that it is now following the lo-fi loop. Pardon me, I'm just bringing up my notes here. Software instruments, okay. All right, so let's get rid of these two tracks. And you know, with the software instruments, you know, the goal was to have a full range of instrument sounds out of the box, and to easily be able to switch between the different instrument sounds, and be able to view and edit MIDI regions as musical scores. So if we go back into Ardor and we do a new track, I have 3 different synths and a sampler. So we have here the Ace Fluid synth, which you saw with the drummer. It uses a special sound font called the General User sound font that has over 259 different instruments that you can play with. So you can just go through the different instruments. And then if you want to change what plugin you want to use, all these synths all have a ton of different presets in them. This one is called Yoshimi, and it's very, if you ever used LMMS, it's very similar to a synth called Zenad Sub-Effects. And the reason I picked this synth is not just because it has a ton of presets, but it has one of my favorite synth sounds in it. If we go to Fantasy and then Road Space. That's a pretty cool synth sound. And then let me exit that. And then we're going to check out Surge XT, which has a ridiculous amount of instrument presets to choose from. Like, you could just go in here all day and just sample and just check these out. So, just show you a couple. Okay, so, and then we have a sampler. And what a sampler does is it basically turns a sound into a musical instrument. So a few weeks ago, me and my buddy were driving around, and we're both into electronic music, and we heard this song called Bow Wow. So I took the main vocal, which is Bow Wow, and then chopped it up, and then turned it into a sample, and we get this. And so if you go up and down the different pitches, the more you go up, the faster it goes, and it gets higher pitch. So yeah, that's the sampler. So let's see here. So if you wanted to record a MIDI region, you would just draw a region right here, and then let me switch back to the Ace Fluid synth, and then just draw in your different notes. Another way to do it, and then we can also obviously record something. So let's we'll do one of the poly synths, I guess. Maybe this one. So you would arm the track for recording. And then make sure the playhead's at the beginning, and then hit space. Then I'm going to mute this other track right here so it doesn't distract us. Hit the space key and start, and then you start recording. So, and then you can just play it back. In case you guys can't tell, I'm definitely not a musician. So, so one of the goals was to be able to open up and edit a MIDI region as sheet music. So I couldn't really find any plugins that were stable enough that were able to do that. So I found a way to integrate MuseScore. So we're going to use this script to open up the MIDI region in MuseScore. And now you can see it represented as sheet music. So if we go to input a note, well, it's supposed to, well, it's muted. That's why it's not working. So it hooks up to whatever synth it's connected to. So if I change the instrument here, we go back into MuseScore. So one limitation of this is it doesn't have the ability to directly edit the region onto Ardor. So there's two ways to do it. One way is to use MuseScore to record onto the track since it's connected to that particular track. So I'm going to hit spacebar, and then we're going to go down to MuseScore, and we're going to play it. So, And then once it's done, you do have to go to the special edit, the internal edit tool, and remove that little label there. It'll just play as grand piano. And then you have to use the scissors tool to clean up the region a little bit and just get rid of the unused space. And that's one way. And the more cleaner way to do this, let me turn off recording, is to just export the MIDI to a file. And you want to make sure that it is standard. It's a standard MIDI file. And then you save it. And we're just going to overwrite that. And then I don't need to save changes in here. So with that track selected, go to session and then import. And then we'll go to browse clips. And then there's my file that I saved. We're going to import it. And then use the internal edit tool to get rid of that marker right there. And then you just play it. Okay, so one thing, so I was on YouTube one day, and I noticed that Apple had just released Logic Pro 11, and one of the things they released was called a session player, and it kind of follows the same idea of the drummer, where you have instruments follow along with whatever you're playing or an audio loop. So I saw that, and I'm thinking, ooh, shiny thing. I'm wondering if I can do that in Ardor. So, and then it turns out there is a way. So if we go over here to Session Player, I'll just load up the Ace Fluid synth, and I'm going to bring in my favorite lo-fi loop again. And let me just line it up there. And so the way it works is it goes by the key and the tempo of whatever you're doing. So I have a script that will get the key of the song. It calls a Python script in the background, and then puts the output there, and it's F major. So I don't need to set the project key right now. And then we also need to get the tempo of the song. So get the tempo, and then we'll go to my chord packs, and then we'll look for an F major chord. And scroll down. There we go. So we have a chord progression right there. And I'm going to change this to a bass since the main loop is already a piano. Guess we'll do acoustic bass. And then we're going to duplicate this track once. And then you have the acoustic bass kind of following along with the audio loop. So we can also change the instrument if we want. And the way it works is it uses an arpeggiator and a MIDI strum to attenuate the notes. For those of you who don't know, an arpeggiator is basically something that plays a note in rapid succession. This particular arpeggiator, what it does is it plays the same note in different octaves. So to the human ear, it sounds like it's going up and down different notes. So, and another way to implement this is that audio to MIDI script I showed you earlier with the drummer. So just going to remove this track. And then just going to put in, I'm going to put in another loop right here. So get rid of that, remove. And then let's go to, I'm going to put in that one I had in the beginning. And then we'll create a new software instrument pack, or instrument track, rather. And we'll draw a MIDI region. And then we'll select control and then select them both. And then we're going to generate some MIDI based on this audio loop. It's going to transcribe them to notes. So, so now when we play it, it adds a whole new dynamic to the piece. It does sound like Linkin Park. You know what? That's a good point. I never really thought about that. Okay, so let's say, like, what's cool is, let's say you wanted to see what that audio loop looks like as sheet music, and you want to print it. You could do that with the MuseScore script. So we're going to do that, and you'll get this little message that says if MuseScore shows a blank page, you may have to wait a minute or two for it to Ardor to write it to disk, and that's why I have that one script that autosaves. So we'll see if it comes up blank or not. And you see, we now have that audio loop represented as sheet music using MuseScore. So, let's see. Did I get everything? Yep, got everything there. And then next thing we're going to cover is the guitar. The goal was to have like a ton of guitar presets to choose from. So I have two plugins for that. Let me get rid of these tracks first. Remove. And then we're going to create a new record guitar bass, and we're going to take a look at GuitarX. And you'll have to excuse me because I really do not know how to play guitar, but it's just to demonstrate everything. So who here remembers a song from Green Day, The Boulevard of Broken Dreams? So we're gonna, we have a preset for that, and if we play it, you get that effect. I also have some Eric Clapton presets, like from Wonderful Tonight. So if we play it, and then I also have some of these metal presets. Okay, and the other guitar plugin I have is called Ratatouille. And what Ratatouille does is it uses what's called neural amp modeler files, which uses machine learning to model different physical amps, and people can upload them to a site called Tone Hunt. I have preloaded some NAM files that were on GitHub. So we could just go through the various and hear how they sound. And I also have some impulse responses, which kind of simulates the speaker cabinet that the amps are in, and that also changes the sound of the guitar. So that's basically the guitar. It's pretty straightforward. You could use, this guitar script between the plugin between Ratatouille and Guitarix. So yeah. Let me get my notes out here. And so the next track is the audio and vocal track, and the goals here are to be able to transpose an audio file by key and scale, which Ardor doesn't really have the ability to do by default. Be able to stretch an audio loop to a fixed BPM. And then be able to select and switch between different vocal effects, just like you do in GarageBand, and then have an easy to set up auto-tune that follows the key of your project. Basically sound like T-Pain. I know some people don't like that, but I do. So what I'm going to do, let me see. So I'm going to load in two different loops here. And then we're going to load another loop here. I'm just going to load this one. So I want this loop to follow the key of this loop I have, the top loop I have selected. So I'm going to get the key of that loop. So it comes up as E minor. So what we could do here is we could set it as the project key, and then if we want to change it to E minor, this script will do that. It's the transposition script. Now you can see that I have my project key automatically set there. However, if I select that, when I tested this the other night, that part of it is not working right now. It's something I'll have to debug later, so no big deal. We can just select the key manually, and it will analyze it and transpose it for us. And so if we play it, you can hear that it's in the same key, that they're both in the same key, but they are out of time. So to fix that, we're going to use the time stretch tool and we're gonna actually, we need to get the tempo of this loop right here first, and then set it as the project. And then we're gonna time stretch it to the project BPM. You can also put in your own BPM if you want, but I like doing it by project. So it's running a little bit. My computer's running a little bit slow this morning. I apologize. Waiting for that to analyze. And then now when we play them, they're both in key and in time with each other. The other thing we wanted to do was the different vocal presets. GarageBand has different vocal presets that we can go through, and I've implemented some of them into Ardor. So if we go to new track and then record audio, we can record a blank audio track. I'm not going to demonstrate that because the mic's going to go crazy. We have these different vocal presets. So I'm going to select dance, and it loads in some plugins. And my goal here was to try to try to replicate the sound of the different vocal presets in GarageBand as closely as I could. So I'm going to import a very terrible sounding vocal. I'm going to give you guys a fair warning because it's me. So here we go. And we're going to import it to selected tracks. And then let me just close that out. And then we're gonna play it. My condolences to your ears.
Testing out vocals in
GarageBand. What we can do is we can change out the different vocal presets. So we can make it sound more bright.
Vocals in GarageBand.
And you can see it changes out the different plugins.
Let's see how this sounds. Let's see how this sounds.
I can make myself sound like a robot if I want to.
In GarageBand. Let's see how this sounds.
I can give myself deeper vocals.
Let's see how this sounds. Testing out vocals in GarageBand. Let's see how this sounds.
So one of the other goals was to have easy to set up auto-tune that follows the key of whatever you're working on. So I'm going to go back to my favorite lo-fi loop. See if Susan, I can. There it is, right. Where's it at? There it is. So I already know the key is F major, so I'm going to turn on this auto-tune plugin, and then I'm going to set the T-Pain preset, And I already know it's an F major, so I'm going to set the key to F major, and then we're going to play my vocal.
Testing out vocals in GarageBand. Let's see how this sounds. Let's see how this sounds.
And so when I change the vocal presets, it keeps the auto-tune settings. So if we go to like the edge vocal right here.
Testing out vocals in GarageBand.
We can do tube vocals.
Let's see how this sounds. Let's see how this sounds.
It's supposed to sound like you're in a tube, but apparently
Testing
I need to work on
out
that.
vocals in GarageBand.
Okay, so let's see where we're at. I know we're a little short on time, but in the words of Steve Jobs, one more thing. Another cool feature of Logic Pro 11 is the ability to do stem separation. And what stem separation is it takes a song and splits them out into different instruments. So let me get the script loaded here. And make sure make it 13. Stem separation. And then let me load up a song. Should be in my downloads folder. Okay. Downloads. No, I did not want to highlight. Here we go. So this particular song that I'm loading, it's made by Glenn MacArthur, who is the creator of a Linux distribution called AV Linux. That's made. It's a distribution that's made for audio production. So this is and again, my computer is running a little bit slow today. So while this is doing that, let's go over some key takeaways. I'm gonna continue to demonstrate it, but I'm just gonna go over some key takeaways so there's not silences. So key takeaway is if you want to have these kinds of cool experiences that you have in GarageBand, you don't have to go buy like a Mac, or you don't have to buy like an expensive DAW for Linux like Presonus Studio One or something like that. And I have my this is my contact information, and I also have a QR code for my GitHub for those of you who may be interested in this project. So let me go back to see where we're at here with the import. I'm glad I took some time to let that import. And now go to my script, and usually this takes about 10 minutes, but it's probably going to take longer this morning. So, we want to call the script. And we're going to do drums, vocals, bass, and other, and all the other instruments. And it's calling a Docker container, and this is going to take probably about 10 to 15 minutes to run. So while that's running, wanted to get everyone's thoughts on this. What does everyone think? What's your feedback? Yes. Mm-hmm.
Somebody that uses Audacity a lot, so for the comparison to the...
So Ardor, just like Audacity, does have the ability to record music. The difference between, for me, and you'll have to excuse me, I'm still new to music production myself, but the big difference between Ardor and Audacity is in Audacity, it has very limited MIDI capabilities, or none at all. So I couldn't use Audacity for this project. And I like Audacity. I use it a lot to change the pitch of different songs. Another musical program, if you do a Google search for GarageBand alternatives for Linux, one of the apps that'll come up is LMMS. LMMS actually has the opposite problem of Audacity, where it can sequence and record and edit MIDI, but it can't edit and record audio. So it makes it, not good for this particular application. So, what other questions does anyone have? Is there anything I can answer regarding the one of my scripts, or I'll do my best to answer questions regarding music production. Yes, sir.
Oh. This is a dumb question. But I'm looking at that, and that seems very complicated for my use case. Okay. Yeah, Ardor seems very complicated for my use case. Is there a simpler program that can actually create music that's available on Linux?
The simplest, yeah. There's, is there a particular app that you had in mind? I'm just curious.
Okay, I've created an app for my grandkids, and it's for an Android phone to use, and it includes both notes and drawing.
Mm-hmm.
And I need to update the notes a little bit more for the app, and it's a little bit better sound, and I need to get more into tunes with notes. Excuse me, more into tune with notes and music and that kind of stuff, which I don't know hardly, which I'm very ignorant on.
Yeah, so my goal here basically, it is a little more, complex to use than GarageBand, but it replicates the functionality and the scripts kind of help onboard new users who are new to music production with the different dialogue menus. So yeah, so that was basically my goal. I don't. You had a question, sir. In the corner here. Yeah.
Yeah, I was just hoping you would go through some of the Lua scripting. Like, I don't know if you're how long you've been using it, but like, how did you get started? Figuring out you want to do this, and then I can pair that with a Lua script.
Yeah. So let me show you guys my some of the some of the resources that I used. So there's two main resources here.
Did one of you guys have a question?
One is in the GitHub repo for Ardor. There is some example scripts that you could follow. So if we go into share, and then scripts, you can follow these example scripts, and they do various things. And then the way when I first started this project, I really didn't even know what Lua was. So I had to take a YouTube tutorial on how to do it. So the other resource that I cross-reference is the Ardor manual. And if we go to the Ardor manual, and you could see the different properties and methods, and you can kind of compare them to what's in the sample scripts and kind of cross-reference to see what you want to do. Now, did you want me to go through one of my scripts? Okay. So let me show you the tempo script. So let me get there. So it's in. So for the tempo script, so what it does is it's going to, so with the Lua scripts for Ardor, there's certain components you have to put in. You have to put in all this information up here. It talks about what the script does and who made it and a brief description. And then you have this, this function that needs to be in there. And within that function is the main code. I have a little dialog box, and it checks to make sure that it's an audio region, and it makes sure you actually have only one region selected. And there's three ways that it gets the tempo. Let me see if I can. So first way it gets the tempo is by doing string matching in the file name, and then it sets it that way. The second way to do it is based on another script that's supposed to output the tempo in the Ardor example scripts. However, it doesn't actually calculate and set the tempo markers. So what I did was I asked one of the developers how it does the calculations, and I implemented those calculations, and it sets the tempo marker there. And the third way, if the sample is like below like 4 or 5 bars, that second method won't work right now. So what I do is I have it call two tools, SOX and BPM tools, to estimate the tempo, and it estimates the tempo that way. So yeah, to get from just being somebody who played around with GarageBand a few times to knowing a little bit of Lua and writing all this took me about 10 months. is I'm not a full-time developer. I mean, I do some scripting for my job, but you know, it's not something I do day in and day out. So it was something I was doing on my own time, and I was learning along the way. So yeah, that's basically it. Looks like this is almost done. Does anyone else have any questions?
Yeah, I had one. So this may be just like not having tested this stuff far enough. A lot of the stuff that you're showing is used with kind of like canned loops, which are typically pretty simplistic as far as music. Have you tried doing it with like live audio stuff that's recorded that may be like more complex? Like I'm thinking like a jazz tune that does like a lot of modal stuff, like, and see if those scripts can pick up like the key there.
You know what? I think at one point I did try doing that, and I think it did actually pick up the key, but it's been a while since I've done that. So right now, what it's doing is it's importing the various stems into different tracks. So that's going to take another minute or two. So it already did the drums, and now it's doing the bass. Yeah, the disadvantage, the reason why this takes so long is because I don't have an NVIDIA GPU with CUDA. So it's using like a language model to do it. So it's using the CPU, and that's significantly slower. So let me get rid of the original track here. And let's play it. So let's solo the vocals. And you can hear it has extracted out the vocals.
They were young, stark, and beautiful.
And then we can solo the bass. And I really like the bass work in this song. And then we can solo out the drums. And then you have all the other instruments down here. So that's basically Logical Ardor in its current state. Thanks, everybody.
Thank you.
Hello and welcome back, everybody. Glad to have you come back here after hopefully a nice lunch for you all. I wanted to start off with a couple of administrative announcements. First off, one of, I guess, our presenters earlier today left a USB-C expansion card here. So if you need it, go over to the registration desk and pick it up. I also wanted to let folks know there are a couple of changes to our schedule. So if you have the schedule on your phone or device, refresh the page. At 1 o'clock here, instead of having the Raspberry Pi presentation, we're going to have Don Vosberg talking about teams. And in the 5 o'clock position in this room, we have, instead of the robotics presentation, we're going to have one on machine learning. So a couple of folks ran into trouble making it here today. So fortunately, we have people who stepped in to help us out and make sure we didn't have any empty space here. So first off, I want to give a real warm welcome to Don Vosberg. He has spoken here at OLF. I lost count of how many times. It's been fantastic to have him come out here and present for us on a whole variety of subjects. But in here today, he's going to be talking about team dynamics. So Don, come on up and take it away.
Thank you. Okay. Hi, everybody. My name is Don Vosberg. I'm an open source enthusiast, and my day job, I work for SUSE. I've been there for 21 years, and I've been coming to Ohio Linux Fest, which it's only a couple hours away from home, since the early 2000s. So it's a joy to be here. I proposed this session along with the one that I'm giving at 5 o'clock, which is about old dogs can learn new tricks. So, so this one is more of a soft skills session about teams, and hopefully it will be something that is meaningful for you. I found out I was doing this not very long ago, so. The making of a team. So why does it matter? Every time that well, first off, who am I? I've been in IT since 1990. And I learned first computer that I actually worked on was in college. I had a course in BASIC on the only computer that was on campus, which was in the basement of the admin building, and we had to use punch cards, and I got a B. So I wasn't really great, and I was not a programmer, but my life worked out to where in 1990 I started working as a sysadmin, and I got thrown in. When they hired me, they said, well, we think it's part-time now, but it'll grow into being a full-time job soon enough. And the part-time part lasted 2 weeks. And within 6 weeks, I was working 65 and 70 hours a week. So I've learned a lot in those days. So I've been married to the lovely lady pictured here at the Oregon coast since 1983. We have 4 sons, one of whom lives here in Columbus, but we've lived in the same house in Anderson, Indiana since 1988, so I'm an old guy, and I hope you excuse that. But I've been on teams in a lot of situations, both at work and off work, so I've done a number of dramatic productions, including one this last spring on Anne of Green Gables, so I've been involved in teams at church and teams with my family as well. So hopefully this will not be a presentation that is me reading talking points. This is a presentation based on real life lessons, and I hope you can learn some things too. So whenever you do a presentation, I always start with, why in the heck should I care about this, right? So why should I care about teams? Because life is a lot bigger than just you and me. It's, we're all involved in being a teammate somewhere in our world. And the world of open source has tons of teaming. The community is one of the key features of open source. So all of us get to be part of a larger community than just our own little circle. And life is so much richer when you get to share it, when you have people who are acting like sandpaper to smooth out the rough parts of your life and knock off some rough edges. And when you get to help other people with that too, in your own gentle way. I'm sure you're all gentle. And we need you on our teams, wherever we are, especially in open source, and Ohio Linux Fest people. We're always recruiting to have people that are participating, that are a part of it, that are making stuff better. And this is something that you can take with you. Now, I learned pretty early on that a lot of what I've worked on early in my career is at the bottom of a Midwest landfill. I remember going in to meet with my boss one time. I had been working on a Quantel mini computer. Have any of you ever heard of a Quantel mini computer? Yeah, okay. So I go into my boss's office and he goes, "You are so good with that computer. You are Mr. Quantel." And I said, "Don't ever pigeonhole me with one technology because it's going to go away." And a month later, they filed Chapter 11. So these are things that you can take with you. Life lessons like being a teammate and being part of a team is something that carries on beyond all the things that you worked on. I was actually in charge of a data networking team at Bank One Financial Services, which doesn't exist anymore. It was bought by Chase and eliminated. And after I left there, everything that I had worked on was sold off and parted out and disappeared and went into the ether. So you all have stories like that that are part of your life too, I'm sure. But what are the things that you can take with you? Being a teammate is one of those. So what really makes a team? What makes up what a team is involved in? And we're not going to talk about the Cincinnati Bengals or the Ohio State Buckeyes, sorry. This is a bit about being on a different kind of team. The kind of team where you participate both as a co-worker and as a leader, as a friend, as a partner. Here are some things that are important about good teams. First off, you want them to be coherent. You want them to hold together. You don't want to go to one person on the team and get a different story than the other people. And you also look for teams that are effective. So if they're given something to do, a challenge ahead of them, they can be effective and complete their mission. And thirdly, collaborative. You want a team that's going to work together with each other and not just get stuck, each person doing their own little silo of things and not cooperate together. And it's important that a team is resilient because every team will face difficult times, opposition, challenges, people who are sick, people who leave, things that happen that are bad, that you got to learn how to work through those times. If you haven't been on a team long enough to encounter those challenges, you will. I'm just going to say. And you also want a team that is confident, that feels like they're here for a reason and they have purpose and they're able to do things and they know they can do things, even if it isn't everything. And actually, part of that is knowing what you can't do as well. Enjoyable. I'm lucky, and I've been lucky enough to be on some teams that are really fun to be part of. And we enjoy being together. We enjoy doing things. This is an important part of being a team. And even to the point where it is enviable. So, and I'm blessed right now to be on a team at my work where we are really the envy of some of my other colleagues who do not have the same kind of cohesion and team. And finally, you want a team that's going to be great. So what makes a team that is all those things? So here's a picture of our team. And I'm on a team where I am the only person on this team in North America. All of the rest of them are mostly in Central Europe, but we have one teammate that's in New Zealand and another one in Brazil, one in Dubai, two in Canary Islands. So we're spread out all geographically and everything. But when we get together, there's a lot of goodness that happens out of this. And this is our picture from this year, and I'm kind of cut off there on the side. But we enjoy being together and doing things. So I have a good experience from which I'm drawing to share with you about teams. So what are the life lessons for you as a teammate? So today I'm not going to talk about being the manager. I'm not going to talk necessarily about being the directly responsible leader for the team. But what are the life lessons for us as teammates? What are some things that we can do? So here are some things that I've found in my experience that matter a lot for being a teammate. And they come into two different categories. The first one is character. And what character is not like somebody in a cartoon or an actor in a play. It's more like who you are. And some people say character is who you are when nobody's looking. But in fact, these become very evident when you're part of a team. So these are some characteristics of a teammate. Trust, stewardship, and we're going to talk about those two in depth. The other ones I'm going to save for future talks, but you can certainly understand and read conceptually what these are about. Integrity, being able to be thankful or express gratitude. And we're coming up on a season of gratitude, so this is a useful concept there as well. Persistence, sticking with things, availability, and humility. These are character elements of a good teammate. The actions that you can do to encourage some of those are things I'm going to allow you to read and take with you. This deck is going to be published. I'm not going to spend a lot of time on these today, but you can certainly understand how they would align with some of these characteristics. So, and I separate them out because some people try to paste on actions that don't align with their character. And all of us have met those kind of people. We had a colleague one time who would always say, "Hi, how are you?" and then just lambaste you because somebody told him that you need to greet people pleasantly. It was a paste-on action. It didn't represent who he really was, but hopefully these actions can represent who you really are. Encouraging, acknowledging, learn and teach, which seem like sort of opposite things, but they actually work together. Getting a sense of timing, learning how to deliver, solving instead of just bringing up problems, being a part of the solution, looking up, not just staring down at your desk or your phone, but actually looking up to see what's around you and being an inspiration for others. So these are things that make a good teammate in a broad sense, both from the character side and from the action side. So we're going to talk about a couple of these characteristics today to help us to learn how to be a better teammate and actually go further. So this is an example of a team that I've been a part of. So this last year I was teaching at a technical summit. So internally, they split up all the people that do post-sales support and consulting services for our company, and they offered 5 different summit meetings for 4 days for these people, and we gathered together, and I was responsible for 7 hours of content during these 5 sessions, 3 in Utah and 2 in Amsterdam. And this team, with me, we were assigned a fun, silly project of making a spaghetti tower with marshmallows and other things to see who could make it the best. I'm from Indiana. The guy next to me is from India. Next to him is Mark from France, and Emilio from Italy, and Tanya from Bulgaria. So it doesn't matter necessarily where your background or your geo is. You can build a successful team and work together. So the first thing is trust. Trust is a hard thing, and I'm not talking about the kind of trust that you make when you're trying to hide all your money from Medicaid or, you know, it's not the financial trust part. It's the human side of trusting. So what is trust? Trust is actually both a noun and a verb. So in its noun form, it's defined as the assured reliance on the character, ability, strength, or truth of someone or something. And then the verb is sort of like that. It's to rely on the truthfulness, accuracy of, or place confidence in, to hope or expect confidently. So some of us are given a trust, or some of us are trusted, and some of us have to learn how to trust others or be trustworthy. So this is an important concept. So with trust on your team, there is freedom, because I know I have the trust of my boss, which I have to because he's 4,000 miles away from me. I have the freedom to do my own schedule, to work hard and know that he trusts me to do this. And at the same time, there is motivation in that when I feel trusted, it's motivating me to continue to earn that trust, because trust is an hard thing to earn and an easy thing to lose and break. Third thing is appreciation. So when there is trust, you feel appreciated if you are trusted. And when you trust others, it's an expression of that for them. And finally, confidence, that if I know I'm trusted, it gives me the confidence to do well. So when I'm challenged with a certain task, presenting, learning something technically, I tend to go beyond the pale because I know I'm trusted to do those things. And conversely, without trust, you find suspicion. Well, I don't know. I don't know what he's doing. He didn't show up for that meeting. I don't know. I don't know if I can trust him with this task. Or blaming. Well, he must have done it. He screwed it up, and shouldn't have given him that. Or grumbling. I don't know why she's acting like that. She just needs to find a different job or get out of here or get a different, and insecurity on the same side. So the first three are almost like external expressions, and insecurity becomes something within ourselves that without trust, we become insecure ourselves. And if we know we can't trust someone else, it makes us feel uncomfortable and uncertain in our position in the team. So trust really matters for these ways. So how do I become trustworthy as a teammate? Or how do I help someone else become trustworthy as a teammate? First off, follow through. So I earn trust by when I'm given something to do, I don't just do it, I do it like to the nth degree. I do it super well. Second thing is to own your stuff, so that if you are trusted with something and you're not able to do it or you have trouble, you don't resort to blaming and suspicion. You own it and say, I should have done a better job, I can do this. And then the third thing is over-deliver. Now, you don't always get to over-deliver, but when you have the opportunity to over-deliver, it makes a big difference to the rest of your team. I'm in a technical product management position at SUSE right now, but I often say that I'm more like putty, that I fill in the cracks when I see them. I don't just go, oh, there's a crack. I try to over-deliver and be the person who can help connect the dots or pull the right person in or help do something even if it may not be directly on my job description. Handle knowledge with care. Now, I'm saying this because sometimes people are given knowledge that might be harmful if it was shared with the wrong persons. So be very careful about how you handle knowledge, and at the same time, don't think that you know it all, because you will not be trusted if you act like a know-it-all. That's another one about owning your stuff. But handling knowledge with care is very important. And finally, becoming trustworthy, you need to learn how to trust back. So if someone trusts you in your team, if you're a good teammate, you learn how to trust others and have great expectations of what they're going to do to deliver. So the second concept that we're going to talk about today is stewardship. Now this sounds kind of funny. Trust is one thing that I can kind of get. What the heck are you talking about when you say stewardship? So stewardship is a noun that talks about conducting, supervising, or managing of something, especially careful and responsible management of something that is entrusted to your care. So this is almost like a corollary to trust, in that I am given something to do, I am a steward of it. This person in this picture with the beard smiling, not the guy with the hat, the other one. You might recognize Jeff Lindholm on the other side. He's come here before. He's from Michigan, and he's been at Ohio Linux Fest numerous times. But next to him is Miguel Perez, and he was our director for 2 years. And he became the person I thought of when I considered the term stewardship. And if you can put your name next to a positive character trait in people's dictionaries, then you're making progress. And when I say stewardship, it's because he was given the job of being our leader, and he made our team a better team before he left to go on to the next phase of his responsibility. So he got promoted last month, and he's not on our team anymore, but he's stewarded his time and responsibility on our team very well. So much like with trust, we want to know why stewardship matters for a good team. So with proper stewardship, there is respect. You know that I earn the respect of others. I respect others in that process. I leave things better. So when I start with something, I want it to be better when I'm done than it was when I began. Commitment is a part of stewardship. And some people shy away from commitments and they roll their eyes or seek to minimize their commitments. But if you are a real steward of your position, of who you are as a teammate, you will take advantage of those commitments and keep them well. And then finally, leadership by example. So it's one thing to lead because you've given the positional authority to do it. It's another thing to be a leader because you are stewarding the opportunities that you have very well. And conversely, without stewardship, you get empire building. So we had a person in our, I'm sure you've had them in your experience, who decided that they wanted to get to the next position and the next position and be in charge of more and more of their world, and everybody else was simply feeling like a pawn, or you leave the rest of your team in a shambles because you're trying to simply get to the top and be the boss, and that is not what stewardship is about. Scorched earth, and I'm sure none of you have ever experienced the scorched earth process, but you can certainly think of examples in your experience where somebody felt like they came in and blew it up and moved on. That's not a good feeling if you're on that team. Shallowness. No one wants someone who is simply reading slides. I actually was flown into a meeting where we actually had global representation, and the person in the front read us a slide deck that all of us had already presented in person before. And when that happens and you feel like this person doesn't really understand the topic, they don't understand me, they're not really taking their job very seriously if all they're doing is reading slides. Don't be that guy, right? And then departures without fond farewells. So if you imagine yourself on the team that you're in now, when you think about when you have to change teams or when something happens that your team is no longer there, you want to look back at those photographs and think of them fondly, and you want to remember the person who was a teammate well, and that means stewardship has happened. So what can you do to foster stewardship? And you might recognize these people. They're walking around here. I actually took this picture earlier today. So here's some ways that you can foster that kind of stewardship. First off, take responsibility. So sometimes you are given an opportunity to do something and you know it's going to be hard, but don't shy away from that if you're stewarding that particular opportunity. Take that responsibility and do it. The second thing is empower other people. So one of the things that I always try to do in my work is watch for when somebody has done something super well and recommend them for the next thing so that they can then broaden their reach and their expanse of what they're able to do and capable to do. So be a part of empowering other people's success. Third thing is that demonstrate your commitment. It is not about just writing things onto a resume or putting things down on paper. It's about living it out and a demonstrated commitment that makes you a better steward and a better teammate. Fourthly, understand the trust that is given to you. And sometimes we look at an opportunity or a job or a task as though it were a burden instead of a trust, as though it were difficult for me instead of something that's going to show that I can demonstrate commitment and be a good steward of what opportunities I have. And finally, lead and leave with the same grace. So when you are leading in a team or in a team situation or any kind of situation, make sure that you are leading with the same grace that it will allow you to move on to the next project and the next team and be a part of stewarding your opportunities as you go forward in your career. So do you have any questions, or does that stir anything in your mind about making a good team or being a good team? Do anybody have stories they might want to share?
Kind of a broad question. Like, so obviously you work with like a multinational team. Are there any road bumps in this whole process because of different culture and language and the things that you run into?
Yeah, so good question. So the question is, I work on an international team, and what are some of the challenges and road bumps that go along with that? So obviously, the biggest one is time zones. Because most of my team is on Central Europe time, so I'm done with meetings by 1 o'clock p.m. my time every day. They are very gracious to not make me get up at 4 o'clock in the morning or 3 in the morning or whatever. They've been very gracious. And some of that is just the whole approach to work in Europe is very different than it is in North America. So there are very strong rules about required time off, and they take that very seriously to the point where it contrasts pretty greatly with some of the management expectations that we have in North America. So that makes it a little easier. But obviously, English is our common language. We have French speakers, Portuguese, Chinese, Hindi. I have one Pakistani. So we have a broad language group, obviously Germans and Dutch and French and Spanish and everybody else. So we speak in English. It does make it challenging when you have a work survey and you're asked to give comments anonymously. They all know when it's me because I'm the only native English speaker, but I also get to edit all their slide decks. So before things get presented, I get to do that. But it is challenging for sure. But when you have that trust atmosphere, it really makes it a lot less of a barrier because they know that I'm taking them seriously and they're taking me seriously. I was the one who's the outlier. I'm the weirdo. I'm the one that has to fly, across 6 time zones to go be with them. But they were very gracious toward me, and it makes it easier for me to trust in return.
Well, I worked with international teams, so I had 4 clocks on my desk. So I knew what time they were there. And I worked in India, which they go home and they can't work overtime. So if I looked at the clock and it was too late, well, I have to talk about in the morning. But I also start early in the morning, and more than once they go, Doug, what time is it in the U.S.?
What time is it where you are?
Yeah, and a couple times it was 6 in the morning. They go, what are you doing there?
Why are you up?
When I come to work, but I had 2, 3, 4 hours intersection with them where other people would show up at 9 o'clock and they'd only have an hour time to talk with them.
Yes, and I think secondarily, manage your asynchronous communications well. So things like if you leave a Slack message for someone, you want them when they open it up not to go, oh crap, this is terrible. You want them to wait. If it's going to be asynchronous, that's not the place to deliver bad news, right? So asynchronous needs to be, okay, we need to talk, let's talk about this when we're both there together. Trying to manage those kind of barriers is important, and that's a good point.
Are there any other questions? I didn't see any on Slack, so thank you.
Great. Well, thank you very much for the opportunity to share today, and have a good OLF. The speaker's at OLF, so it should be up there.
Good afternoon, everybody. Hope everyone had a great lunch. Quick challenge. So let's see. We've got a shirt here from 2010. Anyone got anything older on right now?
I got the same shirt.
Oh, we've got a match.
I'm a trendsetter, apparently.
Trendsetter.
I got another one back there, too.
Oh, sweet. Okay. So a couple matches. Cool, cool. Well, I'd like to welcome Bob Murphy to the stage. System admin, Linux enthusiast, an EFF member, which if you would like more information about the EFF, it is right outside the door, and has been coming since 2007. So take it away.
Thanks. Good afternoon. Thank you all for showing up. So before I get started with this, I'm going to preload this a little bit. At the end of this presentation, we're doing a mini raffle, not the one that was just up on the screen, a mini raffle right here for the presentation machine. Okay? Which is not super new technology, but it's sufficient to run 3 VMs and the presentation, so it's not nothing. So we're going to talk about that when we get to the Q&A section, and I will give this away at the end of the presentation. You get the computer, you don't get any of the screens. Those are all there. That's not yours. So let's talk a little bit about TMUX. Now, some of you might be saying, what is this? It sounds like some experimental drug you see ads on TV. It doesn't sound good. It's what's called a terminal multiplexer. It lets a user in a single terminal window do multiple windows, manipulate those windows, do a lot of stuff within a single SSH or console session. It's very useful, especially if you're in a place like you're on a server that's not working correctly, you're on a TTY, you're on a VMware session, and you don't have a full desktop available. It can be really useful. And it's also excellent for if you're on a limited connectivity to a remote machine and you might get cut off. It's super useful for that. I'm going to explain a little more about that in a minute. So about me, I got a nice introduction already. I've been using Linux for a long time. I'm an EFF guy. If anybody wants the slides for this, and you'll notice the slides are all in glorious text because this is a text utility, so the slides should be in text as well. So those slides are available at murfnj.neocities.org. And you might think, hey, that sounds like the old GeoCities with all those horrible web pages. Yep, this one's going to be bad too. So there are good ones. Mine is not one of them. And if you have questions, you can email me, not during the presentation, but you're here, so that's not a problem. But if you have questions afterwards, you can email me at murf@weirdness.com or contact me on the Fediverse with Mastodon or whatever other program you like at murf@gardenstate.social. So how to install it. I'm going to get into some of the details of some of the other stuff later, but how do you install it if you wanted to install it and follow along with this? Most versions of Linux have it in the regular repos. It's very easy. Red Hat, if you're using old Red Hat, it's yum install Linux. If you're using anything modern, it's DNF install TMUX. Did I say Linux? I did say Linux. TMUX. What's that? Yeah, it just aliases it over. On Debian or Ubuntu, apt install TMUX. Arch is similar. Pacman -X -S TMUX. Slackware had it in the default install for me on the Mac. You need to use either Homebrew or Mac ports, whichever of those is your preference. So brew install or port install TMUX. If you're doing this if your Linux you're using is through WSL, sorry. But what you would use is whatever Linux distro you're using within WSL, you would install it through that. Windows does not have that natively that I have seen and when I looked into it. So to get started with TMUX, you simply type TMUX at a terminal prompt. Okay? And what it does is it pops up another terminal prompt, looks just like it did before, except at the bottom you'll see there's a status bar with some information in it, and there's some useful stuff in there. This is your basic screen. Now you're within a TMUX session. If you want to do something, if you want TMUX to do something for you, you need to hit a command key before you to sort of bring its attention to it. So that command key is Control-B. When you hit Control-B, the next character you type will go to TMUX as opposed to your bash shell. So I'm going to just demonstrate that quickly. So I have a screen here. I'm just going to type you know what? I'm going to SSH somewhere first. I'm going to do SSH Alma. Yes, and I think on the top and bottom too.
bear with me for just a second here. Let me resize my window. How are we doing? We look okay on the left side? Nothing exciting's happened on the right anyway, so it's over the edge. That's okay. So we're going to run tmux within our Alma session. Now you look, it just popped us back to another bash prompt, which is fine, because that's how it's supposed to work. You can see on the bottom it says bash, because that's all we're running. On the right, you see Alma.example. Now I do want stuff on the right. You know, I spoke too soon. There is stuff happening on the right-hand side of the screen. It has the time and date. I forgot what was over there. The time and date's over there. So that's useful stuff if you have multiple windows open or you're not sure which one you're in. So we're in tmux now. So if I do Control-B and the question mark, it pops up our help. Obviously, if you were just in a regular bash shell, you don't get that. This is tmux's help. And if you're frightened by all of that, yeah, I kind of get it. There's a lot of options in there. I'm going to talk about that later. And I'm not nearly talking about all of those options, so don't panic. So let me not get ahead of my slides here. So here's the feature that initially drew me into the screen and tmux, what the heck is a terminal multiplexer world, okay? You're working on a system, you're on your laptop, on Wi-Fi, all of a sudden you have to close your laptop and walk somewhere else, so you're losing your network connection, okay? Ordinarily, if you had just SSH'd into that machine and you didn't do something to accommodate it, you would lose, when you drop that connection, you would lose your connection and you would lose all the work you're working on. If this happened unexpectedly and you can't prepare for it, there's nothing you could do about it. This is something that's great about tmux. tmux continues to run on your machine, even if your session is interrupted. So let me demonstrate. So we'll start something. Nothing important, but if this was an important running task, there it is, it's running. Now let's say something happened, and I'm going to hit that and say, oh my goodness, you don't want to, yeah, sure, okay. So now we've lost it. Ordinarily, what happens to that process that's running? It's gone. You can't do anything about it. So we're going to open this up, and I'm going to try to size it for the screen, which I did not anticipate, but we work with it. So I'm going to SSH back into that machine. And now I'm going to do a command. I'm going to do tmux. Now remember, I had already started tmux. I'm going to do tmux A, which is going to attach us to an already existing tmux session. Now, you can name all your sessions so you can have more than one. We're going to keep things simple and just do one. You can do tmux A, and it's going to attach to the first running session, of which there is only one. Boom. Now, you notice the program I was running, when I abruptly disconnected it, is still running in the background, and we pick up right where we left off. Now, for me, from what my purposes were, this was enough to sell me on this. Okay, I'm in. This is awesome. You know, because I did that, you know, I had problems like that a lot. This is great. So that's the first feature. And like I say, for me, I could have closed the book right here. But it does so much more. It does other useful stuff. So let's go back here. So now, if you know you're disconnecting your session, you know, SSH sometimes is a little funny. If you just disappear, sometimes it'll hang out there. If you do Control-B-D, it disconnects your screen session as if it were dropped. But then you can exit your SSH session cleanly and get out. So if you know you're going to do it, you can cleanly get out of your tmux session and then come back to it later. You don't have to quit it. You could tell it, yep, you keep running in the background. I'm going away. I'm coming back later. So super useful. Like I say, you can name your sessions. I don't really get into that in this talk. But if you say you want to have a couple different sessions running, you can absolutely do that, and it works. Oh, by the way, little interactivity. If you have questions, feel free. I might hold them off till the end because we're going to have a Q&A at the end. But if you're lost and you need a quick, just let me know. Can you change your control keys? Yes, you can change your control keys. I talk a little bit about configuration later, but I don't go too deep into it. But I'll cover that more. The answer is yes, and we'll talk about it more later. So here's a useful feature that you might like. So you know what? I'm gonna exit. Nah, I'll leave it on here. So we can do multiple windows. So right now we have one big window with our stuff. What I'm going to do is I'm going to open a second one. So right now, actually, I should have left btop running. So btop is running. What I can do is Control-B and then C for create. Notice it pops up another one. Now, if you didn't know otherwise, you might not know what's going on. So let's just, get a couple things on the screen here. That window is just sitting in front of our btop window. So if I do Control-B, N for next window, btop is still back there. So now I can have two bash shells running simultaneously and just connect to them as if you were in 2 separate terminal windows. Is it working? Okay. So that's a useful feature. Let me see how far I got ahead of my slides, which I always do. Oh, okay. No, I'm not too far. I get all enthusiastic and I start running. So Control-B-C creates a new window. Control-B-P and N switch to the previous and next window respectively. I only have 2, so they're not going to look all that different from the demo that was there. You can also do Control-B and a number for at least the first 10 sessions, and then you will move to that one directly. So if you have 5 windows open, you can go from 1 to 4 by hitting Control-B4, and it brings you to the 4th one. They start with 0, but you can all deal with that. You're Linux users, you could deal with that sort of thing. Okay. So split panes. So we can have separate windows that you switch between, but what if you want to see a couple things side by side? Let's go here again. Let's do Control-B, and what I'm going to do is I'm going to hit the % key, which is going to give us a vertical split in the lines. And you see now the window on the right is active. So what I'm going to do is I'm going to open a different machine over in that window. And let's do a horizontal. Let's do Control-B and then the double quotes. Now we've split that window in half. So let's do, okay, and I'm going to move around between these windows. I'm going to do Control-B and the right arrow, and it's going to move us to the window on the right. And you'll see it's not super easy to distinguish, but we have different colored lines. So the green line shows us that the one to the left is active. If I go Control-B, you could see the one on the bottom right is active because it's the one that's got the green outline. It is not the easiest to discern thing, but it's still there. So let's do another split. Let's go crazy and make this all silly looking. So we'll do that. Terminal height's too small for BTOP over there, so let's do, I don't know if I aliased that back. Oh. I don't have a key in that direction, but that's all right. So I'm going to move up to this top one, and I'm just going to leave that sit there. So you can see we have one SSH session, and we are into 4 different VMs, and you can jump between them and do whatever you want, monitor what's happening on all of them. Useful? So let's see. Again, ahead of my slides. So Control-B quote does it horizontally, Control-B % does it vertically. There are that help page that had 18 zillion commands. There are all kinds of commands to change your proportions, to move the partitions around. There's a lot to it. We're gonna get to a little easier way to do that. You can move between panes with Control-B-O. If you only have 2, that means the other one. You're on this one, go to the other one. Or you can use Control-B and the arrow keys. That's how I was negotiating with the 4 different splits. You can get rid of a pane with Control-B-X, and you can convert a pane into a window with Control-B and the exclamation point. I don't know why I wrote out bag there. It might have not looked clear when I looked at it otherwise. So let me show you another neat feature. This might be useful. This does not replace your orchestration software by any stretch of the imagination, but may be useful in some circumstances. Let's go back to our example. So I'm going to go into command mode. So I'm going to do Control-B, : that puts us in command mode. You see how the bar at the bottom turned yellow? So I'm going to do set synchronize panes, and it does tab completion. Thank goodness, because synchronize is tough to type. So now it looks like nothing happened, right? But now if I do, it happens on all 4 at once. Yeah, you do have to type the commands correctly if you want things to happen. It doesn't fix that for you. So there you go. There's our 4 separate VMs. Well, 3 VMs and the host machine. I am actually SSH'd back from a VM into the host. So, like I say, this doesn't replace Ansible because, of course, if you do RM, -RF, and one of those machines is in a different directory, things might not happen the way you expect. This could go poorly for you. But for some things, this may be a useful feature. And to undo it, by the way, which I'm going to undo, back to command mode, and you just do the same command again, and luckily it keeps command history within your session. So now it's off. Now I'm only typing in 1. That's a neat feature, but dangerous? Yes. So So that goes into all visible panes. Copy and paste. So has anyone here, this is the example I brought up in the intro. Has anyone been at a TT, like you have a machine and it's supposed to come up to a graphical interface, but it comes up to a TTY? And now you're trying to solve things. You have your username and password. You're like, oh, it didn't work because there's a wrong UUID and FSTAB, so it doesn't boot fully. And all I have to do is copy, a 32-character UUID of random characters from one place to another, and I have no cut and paste. Anybody else been there? I've been there. It's a pain in the butt. Tmux, if you have enough of a system to get Tmux running, Tmux has its own copy and paste things. I've used this. I was in a VMware environment previously, and we used to do that. The VMware console, oh, it's great, I can get in. There's no copy and paste out of it. You're stuck. So I found this. Thank goodness. This is a fantastic feature. So within your Tmux session, there's a copy mode with Control-B, left square bracket. I'm going to botch one of these, by the way. It'll happen. Control-B, left square bracket, puts you into copy mode. Then you select your text with Control-Space. Then you use you use the cursor keys, get to where you want to start, hit Control-Space, do your cursor keys to outline your text that you want, and then do Control-W to clip it. Then you can go to another window or pane or somewhere else on the same screen, and you do Control-B, right square bracket to paste it. That's a little different than screen. This is one of the differences with screen. So it used the same key to start and stop your highlight.
Does this word wrap, or are you selecting a rectangular region?
That's an excellent question. I'm pretty sure it word wraps, but we're going to find out in 1 minute. Yeah, because I don't remember which it does. We'll talk about searching the buffer afterwards. Let's go on a journey of discovery here. So we're going to do, which one am I in? Okay. So we're going to do Control-B, left square bracket. I hit Shift first, and I move these around. So I'm going to try it again. Control-B, left square bracket. Now I'm in copy mode. I hit a wrong key. So let's go up here, and let's find out which one it does. So I'm going to do Control-Space. I've made that mistake before, by the way. The curly brackets do something else, and I don't know what it is. I didn't do the square bracket. I did the curly bracket. That was my typo. So let's see. It does word wrap. There's the answer to your question that I did not know immediately. So let's go a little less extensive. We'll just get the shell out of here. Control-W to end that clip. And let's play a little bit. Control-B, O, we'll go to another one, and we're up here. Now I will do Control-B, right square bracket, without Shift this time, so things happen the way I expect. There you go. There's your paste. So on this graphical machine, it would be easier to use the mouse and just cut and paste. But when you don't have that luxury, this can be a lifesaver, at least for me. So I found that to be a really useful feature in a number of circumstances. There is also, now one thing that, did I hear a question? No. There's one thing that is a little bit funny. When you're in this, you can no longer like scroll up with the mouse to go through your buffer, but copy mode is a way to get through it. So if you do your Control-B left square bracket, you can now scroll up through as much buffer as Tmux has. Now, it has a lot more than that. It's just that's where that session starts. So that's why it ends that quick. So to scroll back into the history, you use copy mode to do that. And there are other features in copy mode which you usually don't get, particularly if you're on a more limited terminal. If you're on GNOME terminal, you could search your history. With this, you can actually do, I've already done Control-B, left square bracket. You can use Control-S to search forward for a string, but more useful, because you're usually at the bottom of the page when you start this mode, you could do Control-R to search in reverse up through your history from your Tmux session. So usually you start at the bottom. So I'm already in mode. Control-R, I forgot it while I'm sitting here. So we'll do Control-R, search up, because that was in the fortune that was run there. And there you go. You could see it searched up backwards through and has already highlighted that. And if you hit Enter, you can actually do the next one. It'll go through your entire history for each successive version of that. All right. Going through this much faster than I thought. So we will have plenty of time for questions. That went the wrong direction. So Control S forward, Control R backward, and N goes to your next occurrence. And again, I'm not nearly covering every feature of all of these. This is a tiny scratch of the surface of what Tmux can do. So mouse support, you can actually get some limited mouse support. Now, of course, you have to be on something graphical that does this. If you're in a TTY, mouse support probably isn't going to work out for you unless you have already loaded mouse drivers for your TTY session. I forget the command for that, but you can get it. But if you're in a situation like this, what we're going to do is we're going to do set -G mouse on. After we go into command mode again, Control B, colon, set -G mouse on. Now, I should be able to do things like, this mouse is a little funny, glitched out. Ooh, I can change the divisions between these. Now, there are commands to do all of this if you're not in a position to do the mouse, but that's a useful feature. And there are some right mouse button menus. Control? Yeah. There are some other features within mouse mode. To tell you the truth, I don't really use mouse mode on this a lot. You know, when I'm using Tmux, it's usually because I'm in a command line world and I need more functionality. I've usually left the mouse behind by the time I get this far. It does, however, work in PuTTY. If you're going from Windows machine to a Linux machine, the Windows mouse stuff will work within PuTTY for that, just as an aside. Oop. So mouse support. Oh, so talking about configuration, we're back, Morton C., to your question. Configuration. You can, when I was doing research, now I was using Tmux and I was doing stuff, but then I did some research to get a little more information. I went through so many guides for Tmux, and they're like, okay, here's Tmux. Here's how you remap all the keys. And I'm always like, why are you leading with that? What does this thing do? What's our purpose? Because apparently lots of people don't like the default key bindings. I agree with them on some of them, but I just deal with it because I work on a lot of different machines, so I don't want to count on my configuration being the way I like it. Tmux's configuration is insanely rich. You can change nearly everything. If you're thinking, can I change this thing to, yeah, you almost certainly can. It's in there. And there also that command mode where we set stuff like the mouse and we set synchronized panes is also very powerful. And as I was going through research, I found that someone, one of us, one of our types, actually wrote a compiler in the configuration and the command mode of Tmux to prove that Tmux itself is Turing complete. Okay? That's a journey of discovery. Okay? So if you think, can I do this in Tmux? The answer is probably yes. If you want to write a large language model, you probably can. It's probably not a great idea, but sure, you probably can do that. So that's pretty much, I don't get into the configuration of it because like I say, I tend to run it straight up and I just deal with weird key combinations. That's me.
It's worth pointing out the default key configurations are designed purposely not to conflict with them.
No, you are nearly correct. They are set to not conflict with Emacs, actually. Yes. Control A is a big no-no in Emacs, so the Emacs folks get all bent out of shape with screen. This was done that.
It was also designed to be able to be nested within screen with the...
Was it designed to do that, or was that just a happy circumstance? I was going to mention that later.
I remember reading the design decision so that you could run them because the keybind was separate.
Yeah.
But who knows? I don't remember the source, so I can't say for sure.
I thought Emacs was the driving factor behind it, but people didn't like Control A. Yeah. So we got Control B, and I'm fine with that. And that is a good byproduct. I'll circumvent one potential question coming. People say, can I run Tmux on my machine and then SSH into a machine and run Tmux over there too? You go, oh, you can. Yes, but no. You can, but you're treading into dangerous ground of not being able to control something. So if you want to do that, running screen on one and Tmux on the other is a real easy way to circumvent that potential problem. You can, like on your remote machine, change your key bindings over there and avoid it, but you could run screen over there and make it work. So, okay, so I am pretty much done with the formal part of this. Too quickly, but that's very on brand for me. Sorry, I was raised by New Yorkers, and the more familiar I get with this, the faster I talk, and I get through it very quickly. So Tmux is a super powerful tool. If you're living on the command line and you're remoting into machines, give it a look. it really does a lot of useful stuff. And I'm saying that I'm just showing you how it works. I don't get a commission for TMUX. You know, take a look at your leisure. If you want to contact me for questions afterwards, we're doing questions now, but Murph@weirdness.com, on the Fediverse, on either of two accounts, gardenstate.social or Hackerstown Murph. And the slides are up there again as well. So I'll open it. Oh, and before we start with questions, if I can get my helper up here for a minute. So I'm giving away the presentation computer. It is a Core i3 of undetermined generation, I think generation 1. It's got 4 gigs of RAM. It is not a computing powerhouse, but it is enough to run 3 VMs and the presentation at the same time. So it can be something, if you are here and you like Linux, but you don't have a machine that you can do it on, this is the perfect thing for you. If you'd like a low-end machine, here you go. No money, just come up, ask this fine gentleman for a ticket, and I will generate a random number and give it to somebody, I hope, because I don't want to take it home. It's got 4 gigs of RAM and a fairly new 256 gig SSD, so performance is really as good as it's going to get with this. It's not terrible. You've seen it. It's not, you know, it's not dying. I'm not doing it. I'm not running Crisis on it. You know, it's all text. But, you know, it is what it is. And you get a keyboard and a mouse and a power cord. You do not get my video cables. You cannot have those. I need them for other things. I have all these weird adapters to plug into this. Those you can't have. So, while I'm answering questions, please come up, take a tip. Please, somebody, come up, take tickets. If only one person does it, I'm okay. We got people. So good. Okay. Now I'll open it up to questions while we're distributing, and then we'll pull a number.
Thank you so much. I'm going to ask 2 questions so he doesn't have to bring me the microphone twice.
Sure.
First, I assume this is built on N curses or something like that, or
I do not know
did
what
they
it is
just go
built
to
upon.
ANSI escape sequences and skip curses?
I'll bet it's built on one of those, but I don't know that it's necessarily N curses.
Okay. The other thing was, as someone who's used Screen for years and didn't know about TMUX, is there a relationship that's causal between those two systems? Did one come first?
I believe Screen came first. TMUX, I believe, was later on. People saying, hey, we can do this better. I used to get questions when I did the Screen talk, so why don't you use TMUX? Screen is old. It's like, they both do most of the same things. The Venn diagram of what they don't do, you know, the circles are very close together. There are only a few things on the fringes. If you need to do the serial port stuff that Screen is really cool with, TMUX does not do any of that stuff.
Gotcha, but if it's Turing complete, you really need to use TMUX.
Yes, if you want to write your LLM in it, yeah, you got to use TMUX. And TMUX, if you set up your panes in your windows all sophisticated, and then you detach and reattach, Screen loses all of that, TMUX keeps all of that. So if that's something you do frequently, TMUX is probably the better tool for you. If you're doing serial port stuff, Screen is absolutely essential for that because TMUX doesn't do it. Other than that, most of the stuff in the middle, use whichever tool you're happier with. It's not, I've heard people say Screen is too bloated, use TMUX. Okay. You know, if you're at a point where a couple of $100K is going to make the difference, sure, go on economy, but for most people, use whichever one you're working. If you like Control A better, then use Screen. You know, it's not a big distinction.
I had a couple of real comments more than anything else.
Sure.
Screen, I'm pretty sure predates TMUX by quite a while.
Oh yes, absolutely.
From what I've seen of its capabilities, it goes back to when you had to use a serial terminal to connect to a machine.
That's what I was talking about.
Yeah.
Actually, that's not its exclusive thing, but if you need to do that serial port stuff, Screen is an awesome tool for that.
Yeah, and TMUX struck me as a bit more modern interpretation. So the other thing is when I transitioned a few years back, about the first thing I did was I remapped Control B in TMUX to be the Control A for Screen. And had muscle memory, and it seemed to be easier, and I'm not an Emacs guy, so that's that.
Hey, if that makes life easier for you, go for it. TMUX gives you nearly unlimited configuration options. Map it to whatever makes you comfortable. Anyone else? I thought I saw another hand somewhere.
Any other questions?
Behind the pole behind you.
I was wondering if you can say anything about on how tmux works using Vim. I know someone talked a little bit about that last weekend in Seattle, but I didn't know if maybe you would have anything to add on.
I do not know of any conflicts between tmux and Vim. It would be news to me. Yeah, I've never had any problem, but I'm not a super heavy Vim user. So possibly there's cases that there's a conflict that I've never run into, but I unfortunately don't have any information for you on that. If there are, hey, shoot it to me in an email. I'd be interested to know, and I'll try to look it up. But if you find the answer you're looking for, feel free to email it to me or send it to me on the Fediverse. I would be interested in that. I wasn't aware of any. Anyone else?
Okay, so suppose I'm using tmux on this laptop just because, oh, I like a setup where I've got a SQL window open in half of the pane and like I arrange this. Does that survive through reboots?
No.
Okay.
No, it's a program that's running in memory. So
Right.
it'll survive you disconnecting. It'll survive the reboot of, well, if you're running it locally,
Right.
no, it will not survive a reboot.
Okay.
If you were running it remotely and your laptop rebooted, your remote session would stay running.
Right,
But
right.
yes, if you're running it locally and you reboot your machine, no, it's a process running in
Okay.
memory.
And it doesn't have like a save to...
No.
Okay.
No, it's not at that level. That you can do, but it would be a new session with the windows the way you like them.
I just had a quick comment. There's a lot of configuration that you can do with tmux, but that I don't want to do with tmux. So if you search GitHub, there's a lot of people who have done that configuration stuff for you. My tmux is one that I personally have used, and I like it a lot. It just adds some like battery management stuff to the screen at the bottom and things like that. So I just wanted to shout that out.
Yeah, my primary use for this is at work and for doing some of this stuff, and it's always on different machines, so I don't bother configuring it. I just roll with the defaults, but that's me. If you want to configure something, believe me, can I configure? Yes, you can, because you can configure everything.
Anyone else?
More questions? This is way quicker than I was thinking. Questions, comments? No questions on the command line presentation software that I was running? That usually comes up too at some point. Okay, it's called MDP, Markdown Presentation. And it renders your Markdown into slides, but it does not do word wrap. So if you'll notice at the end of my lines, words are mercilessly cut off at the sides. And someone said, can you fix that? I'm like, no, not that I know of. I looked through all the settings, and I didn't see anything that says cut words off cleanly. So, or hyphenate or something. No. If there is, let me know, because I never found it, and I just said, well, you know what? I'm going to have to deal with ugly edges. But it's a useful thing. I used to use one called TPP, but it wasn't supported under anything. If you'll notice, I'm running my presentation from the Debian VM because it's not packaged in Fedora or Red Hat. So I circumvented this by just going, well, okay, Debian has a package. I'll just SSH into the Debian machine and run my presentation from there. Oh, and whoever wins this doesn't have to download the slides because they're already on here. So if you want the slides really bad and you didn't want the computer, you could still take a ticket and you will get a copy of the slides. Are you serious? It took 20? Holy moly. Okay. So, any other questions, comments, criticisms, innuendo, anything? No? Okay, so I'm going to go back to the screen where I had this. So I'm just going to, that look random enough for everybody? Yes. Thank you. The silence was killing me there. Okay, so we've got, if it does 30, I'm going to have to do it again because you've got the 30 there. I think I gave away 30 by accident. I've got 29. Okay, if it hits 29, I'm going to do it again. So we've got 1 to 30 minus 29 in the mix. Actually, I should make you take it since you're holding 29. 16. Come on down. Okay. Despite the fact that that's the end of what I had scheduled, I'm more than happy to go over anything else, I will give this gentleman the passwords, which are really so super secure, you have no idea. Any other questions about TMUX or old machines or weird command line presentation software? I am game for it. Just hit me up. I'm happy to talk about it. Thank you all for attending, and thank you for your patience.
Not quite. Doo-doo. Good afternoon, everybody. About ready to get started here. A quick reminder that if you are an Ohio resident, to please check out the opportunity to upgrade your license plate to an awesomely designed Ohio Linux Fest license plate out there, and vote for the design. Even if you can't get one, vote for one. There's one correct one. I would like to welcome Ethan here, who has gone from service desk all the way to VP and senior manager at Federal Home Bank of Chicago. And his biggest passion is helping others who are interested in moving along that track. So take it away, Ethan.
Yeah, thank you. Yeah, well, and first, thanks to everybody at the conference, all the volunteers, all the other speakers, everybody that has attended the talks. This has been a good experience, and appreciate everybody that helps participate to make it happen. I wanted to talk about my experiences a little bit. One of the things that I've had to go through is learning everything the hard way, I think. There's been a lot of times where there has been an easier path, and I have not known what that path is and have had to make all of the mistakes. So let my mistakes benefit you along the way. If I haven't made the mistake, it's only because I haven't had the opportunity yet. So my contact information will be a part of this as well. At the end, you are absolutely welcome, encouraged to reach out to me if you have any questions, if there is anything I can help with. I very much want to be able to do that. And I want to talk about a handful of things, and we will get into those after this disclaimer. Everything that I'm about to talk about, first of all, my own personal opinions. You're going to find folks disagree with that all over the place. I am not here as a representative of any organization, and there is a good chance that a decent handful of the things that I'm going to talk about today doesn't apply to your organization. Each organization, each person is going to be a little different. One thing you should be aware of, though, is if you think you're an exception to it, unless you're pretty confident that you're an exception to it, you're probably not. So why am I here? I want to see positive change in the industry. I think that we have an interesting challenge with getting folks into management positions out of the technical track. We've talked about this as an industry for a long time, and the idea that what career progression looks like for engineers, systems and administrators is they hit a point where they're like, I've been doing this for a while, I'm not sure what's next, I want to make more money. I think a promotion looks like whatever my boss is doing. And we go from engineering into management, and those are very, very different things. The skill set that moved you into a senior position or a lead position as an engineer is not necessarily that same skill set that will get you further. And if you've ever had a bad manager, which I suspect most of us have had, that stinks. That's terrible. That's a really miserable experience. I would like to see less of that in our industry. So my hope is that by going through this, we can avoid more bad managers. I am here to dissuade some of you from going through the management track and encourage others. My story, I'm going to go really briefly through this. I started as a self-employed web developer, decided that customers stink, trying to corral college students to be productive and get work done on a timeline stinks. Decided to get out of that and went into retail, did management of commission sales staff there, then decided I actually really wanted to be back in IT, just not in the capacity that I was. Started all over again as a consultant on help desk, went through a handful of different roles, as you can see there. What's important, the last transition that I made, and this is a story that is one that is dear to me and I think probably tells you more deeply about why I'm speaking right now than anything else. My last job transition was from a government role, had a pension, incredible job security, got bored with the role, wanted to do more, was looking for new experience. I would get calls all the time from recruiters, and the recruiters would say, hey, we've got a position we'd like to pitch to you, and I would start with, I have a pension that I'm vesting in. I have government benefits. It has to be better than that. One person said, I think we should keep talking. We had that conversation. Wonderful organization. They have all these spectacular things. We really think you should do it. I made the jump and said, okay, let's try it. Gave up the pension that I was vesting in, the benefits. Showed up, day number one, all of these promises about 37.5-hour work weeks and great work-life balance and transition and wonderful community. And I pulled up the very first day, rolled my chair over to my new coworkers, and the first things out of their mouths were, we're so glad you're here. We are exhausted. We're working 70 hours a week. Everything sucks. Our families hate us. I haven't seen my kids in 4 days. Second day on the job, I'm working 7 p.m. Phone call comes through to one of my coworkers. It is their child asking for help with homework at 7 p.m. while we are still in the office, and the response was, I told you, I'm busy working. Figure it out. Click. This is the level of stress that is being induced upon these people. Over the course of the next few weeks into months, I realized that all of those challenges, all of the issues, the reason why everybody was having such a hard time was all because of management. That team was not trusted. They were not involved in discussions. They were not given opportunities to participate to make things better. It was very command and control. And I realized that the opportunity to make a difference was there when we had a reorg. So here's the part where I start trying to dissuade some of you from going down this track. There are other options. Management may not be for you. That may not be something you're excited or interested in. If you're looking for different work, more work, you can look at larger organizations or smaller organizations within your same role. Depending on what those companies look like, depending on what those departments look like, you may have an opportunity to become more of a specialist in something. You may have an opportunity to touch more technologies. There are great opportunities, even with lateral moves, that you may want to consider if you're just looking for more, if you're just looking for a change. Don't discount that as a possibility. Okay, here's the part where I really try to dissuade a lot of you. There's a lot of reasons not to do this if you're coming from an engineering background or developer background. The first one being you have to let go of the keyboard. And that one is one of those very much variable truths. There's some organizations, there's a decent amount of organizations, in fact, that allow you to move into a management role and still be hands-on keyboard with some of the work. Mine was not one of those. We have a very hard cutoff. We're a highly regulated entity. And so when you move into a management business role within the organization, you instantaneously lose all of your engineering development permissions. It's a hard cutover. You walk in one day and you can't do anything. It is a different skill set. It is interesting, though, that a lot of the skills that you learn in engineering and development do apply. You just have to understand how the models of the things that you learned apply to a management perspective. Instead of dealing with code and functions and binaries, you're now dealing with very similar, very complex problems, except the result is almost, if anybody's familiar with roguelite video games where everything's sort of variable and you're like, oh, I'm just going to do the same thing I did last time and you get completely different results. That is what it's like being in management. Your teams own your destiny. The reality is if I go into work and all of my teams just say, hey, I don't think I'm going to do that anymore. I'm the problem. I can't go to my boss and be like, listen, they all revolted. It's their issue. My boss is going to come to me and go, well, that sounds like a you issue. Why would that have happened? And so understanding that you really, in a lot of ways, are the servant for your team. There's a lot of people that get into management with the idea of, I know best, so I want to be able to tell people what to do because then we can do it better. That doesn't go well. You work for them more often than they work for you, but it is very symbiotic. Advancement and recognition looks very different. The results come from your team, right? There's some other items lower on this slide that cover that more in depth, but the reality is that there's a lot of moments where when things go poorly, you get to take the blame for it. And when things go well, you have to give your team the credit for it. And so when you're in that situation, what does it look like for you to get recognition, for you to get advancement? And that's where other things come into play. You can't just say, hey, look at this great code that I wrote. Look, it does the thing on the website. Look, the database is is running 10% faster than it was last week after we optimized it. Somebody else always did the work. And when something went wrong, it's because you failed to plan, you failed to get people together to get it done. So you have a ton of responsibility and don't often take a lot of credit for it. One of the other pieces, and this is one of my favorite parts of being in a role like this, is that you have to make decision without all of the information that you'd like. Especially as you move up within an organization, as you have multiple teams. There's a mental model that I really like to use personally. The idea of the map is not the territory, right? Everything is an abstraction. And so when you're interacting with somebody else has hands on the keyboard, and they come and they explain to you what happened. You're getting an abstraction of what they did. Now, if there's another layer in between you, they're explaining it to someone else. That person is then taking what they think is relevant information and abstracting it to you. So you've had several layers of information filtered out before it gets to you. And if you have to do that across several different groups, you don't have the full picture. You have a general sketch of what somebody thinks the territory looks like, but all you have is a map. And you hope that you're making the right decision to go down the right path based on that information. And you hope that somebody didn't forget to draw the big river that's in there, the landslide that's about to happen next to the road. This is the part that can be really fun. You can get to all sorts of decision-making skills and opportunities. And this is one of my favorite parts of it, but this is terrifying for a lot of people, especially when you're coming from a role that is used to, show me the code. I know exactly what it looks like. I know exactly what's about to happen. I know what is in there. I wrote it. I put it together. You don't get that control anymore. Along with that, people are not computers, right? The binary pieces. If I go tell somebody to do something, they may or may not do that. I have to go a lot further in a discussion to make sure that they actually understand what's being asked and that they're actually motivated to do it and they want to do that thing. This can be a really big challenge. This is another part that I see a lot of folks struggle with when they come out of technical roles into a management role. You're so used to just putting the command in and you get back the result, and that doesn't happen. One of the best pieces of advice and worst pieces of advice I ever got came from the same person about 3 weeks apart. The worst piece of advice I'll share with you as well. And that piece of advice, this was 25 years ago probably, as I was managing a retail group. We're all setting up the new schematic, moving televisions to where they belong, get it set up on the screens, and he walked by and he said, I need you to stop doing that. I pay you too much money to be lifting TVs. Now, the thing is, I probably made $45,000 a year living in Madison. I wasn't being paid that much money to start with, but it was this idea of you're better than them. We pay you more. We want you to focus on different things. There was this idea that they were different. There was some sort of separation there. A couple weeks later, he came back, though, and this one I actually fought with him on at the time, and it took a long time for me to realize it, but everything is a function of management. If somebody has an attitude problem, that's your fault because you haven't had that conversation with them. You haven't addressed it with them. You haven't coached them through how to have those conversations. If you have internal conflict on the team, you probably have legitimate issues, but that's your problem for not giving the people the skills that they need in order to work through what those conflicts are. Everything is a function of management. Somebody shows up and they're wearing clothing that's inappropriate at work. You have not conveyed to them the proper dress code. You have a hygiene problem with somebody. It's because you were too afraid to talk to them about it the last 3 times that it happened. Everything that happens, everybody's attitude, everybody's way that they show up, the deliverables, somehow comes back to you and the responsibility that you have to make sure that you're moving forward. I'm not going to go through this entire list. I will stop momentarily. But the last 2 pieces that I do want to talk about are the next 2 bullets on here. Performance management and feedback is hard, as I just mentioned. Sitting somebody down and telling them that their work was not good is really difficult for a lot of people. And for the people that it's not difficult for, they're not doing it right. right? Like, if I'm gonna sit somebody down and say, hey, your work sucks, that's not good. If I feel confident enough to say that, I got a big problem. And if I don't feel confident, it's because I don't know how to frame it to somebody, and I'm probably gonna shy away from doing that. That's a real issue. That is very difficult, and that is a different skill set, certainly, than what comes from a standard sort of engineering role. And the other one, consistently needing to navigate difficult situations. I know this is a family-friendly event, so I will keep it family-friendly as much as I can, but the more blunt way of putting that is sometimes you just need to sit in front of a group of people and eat a poop sandwich and smile while you do it. You can disagree with everything that you were saying. You could have put a fight up in closed doors with your management team. You have given all of the feedback. You completely disagree with the organization on some decision that they've made or something that is happening. And your job, after you walk out of that room, is to go smile and tell people that they have to do this and that you're in support of it because that is what the organization is doing. And that's hard. That is very difficult to do, especially in the first few years. Okay, a bunch of other stuff on that slide. We can talk about any of those in the Q&A later, but if you're still interested, let's talk about some of the good parts of it, some of the interesting components, some of the reasons why we want to keep moving forward. Why, after everything that I just talked about, would you want to make a transition into a management role? The personal impact is a big one, right? I shared that story at the beginning about my coworkers at the time that were like, hey, this is miserable. This sucks, this job sucks, we're working all sorts of hours, nobody pays attention to us. You have an opportunity to change people's lives. The reason that I moved into the role that I did, and I knew that at some point I was probably gonna get back into a management role, but I didn't think it was going to happen for another close to 10 years. I really enjoyed my engineering career. And we had a reorg and split some teams up, and one team all went over to one area, and we were gonna make a completely new operations team. And I was a consultant at the time, and was given the opportunity to become the full-time employee as the manager of that team at that time. And I realized that that was the chance for me to change people's lives. I was gonna have a team of 5. And you have the ability in a role to have such a positive impact on so many people in ways that you don't even know. The idea that you can have folks that come in that feel trusted, that feel good about the work that they're doing. We always talk about the part about coming in and, oh, you spend more time at work than you do with your family. And there is a component to that, right? There's something about just not being miserable for 8 hours a day in the office. But then when people go home, they can be better spouses, they can be better parents, they can be better children to their own parents. The impacts that you have in a role like this ripple through all of that. That is the part that constantly keeps me motivated in this type of role, is knowing the kind of impact that you have on people's lives and their families. And that's a big deal. There's some other pretty cool stuff that comes along with it too. The more obvious ones, right? The corporate impact. You can change the direction the companies are going. You can change the way that you're doing things. When I rebuilt my team in 2018, then we brought in Ansible, and we went from 35 hours a weekend patching servers within a couple months to one person for 3 hours doing it, no more outages every Monday morning, trying to figure out what's going on. And all of that time that you suddenly freed up, you can start working on standardization and other aspects. You can start working on automation and provisioning pipelines and improving your CMDB. And things generate a flywheel as you continue to make those improvements. You build your own opportunities. Personal growth is another fun one too. This is one of the things that I know lots of folks in engineering roles really are passionate about, is this idea that there's always something else. There's always a new technology. There's always something coming down the line. There's always another thing that I can learn about, with a new library that I can find and take advantage of. Management has that too. Very quickly you learn that one of the most important things you can do is start reading psychology books and understanding behavioral psychology. That topic goes incredibly deep, and your teams can suddenly become interesting experiments on many of those psychology lessons. There's incredible depth in that space. And I mentioned it earlier, but the framework of your skills that you built in those engineering roles, the troubleshooting skills in particular, very much apply to management components. I would highly encourage you to consider that part of it. Sure, the actual troubleshooting is a little bit different, but if you're familiar with systems thinking at all and understanding how things correlate to each other, how they connect, how they impact each other, just using the lens of systems thinking can keep you busy for a lifetime in a management aspect. All sorts of new challenges. And then the other part that comes with it is a very moral and ethical profession. You will be presented on at least weekly basis, if not a daily basis, with moments that you are going to have to make very difficult decisions. Is this appropriate? Is this the right decision? Do I need to tell someone about this? Can I tell someone about this? Is this appropriate for HR? Am I supposed to keep this to myself? Are we making the right decision? You are constantly given the opportunity to keep folks and the organization steering down the right path. Okay, so we've talked about all of the parts for why you wouldn't want to do it, why you shouldn't do it, reasons why you might want to do it. Even if you're not considering moving into management yet, there are some lessons here that also very much apply for whatever you're looking for. Even if you're looking for transitions within engineering development roles. And the biggest one is responsibility leading the way. Take on more responsibility. There's a sense that if I'm doing great in my current job, then the company owes me. I deserve a promotion. I deserve a recognition. And what you deserve is to keep your job. And I don't mean that glibly. I mean that very seriously. If you're doing a great job at the job that you are currently assigned to, then you continue to earn your ability to sit in that seat given the opportunity. The way to move on is to find the additional responsibility first and worry about the title later. Those will come. But the responsibility part is the piece that I think a lot of folks get backwards. And as I have conversations with people over the years, that is often the sentiment of, I'm doing so well at this, I don't know why I can't get promoted. The reality is most of the time it's because somebody is doing their current job and meeting the expectations of the current job that they have, but they're not doing anything additional that shows that they're either interested in taking on more or that they're capable of taking on more. So from a person who's looking to get promoted, often the argument is, well, I've made the investment in the company, so why won't they invest back in me? The flip side of that is you're not making an investment into the role that you're looking into, so why would we make that investment back to you? You're asking for a large jump of trust, particularly when it comes to transitioning out of an engineering role into a management role and a people leadership role, right? Because of the difference in those skill sets, that becomes a really tricky thing to get people to just buy into. Just because you're a great developer does not mean that you're going to be great at leading and motivating people and making the ethical decisions and building roadmaps and managing budgets. And so the first thing you'll want to start doing is asking for more responsibility. If you're interested in making that move, find opportunities to take on more. It feels unfair, but it's the chance to prove that you have the skills to make that transition. You're building trust with folks to give yourself that opportunity to make the move. It is okay to say that you want a promotion as part of that, though, right? Be very clear. Hey, I'm doing this because I want to build my career. I want to grow. I want to make this transition. I want it to be a next step for me. And I'm willing to put in the effort to show you that I'm serious about it, to show you that I can actually do the things that I want to do. Then you are going to build trust with folks. You're going to find a way to start moving forward. There's two pieces that I would clarify as part of this, though. Number one, you have to understand the limits of your own manager. They don't have the power to promote you to their level, right? So if you're going to your direct manager They can't do that. I don't know any organization, there may be, I'm sure there's exceptions, right? Back to the initial disclaimer. But I don't know any organization that allows someone to promote other folks up to the same level that they are at. So understand that you're gonna have to work with your manager on that, but they cannot solely make that decision. The other part with that, there's a good chance that they actually don't know what it takes to get promoted. Lots of folks, myself included, have never actually asked for a promotion. At some point, somebody has come across and said, hey, we think that we have a need, and we think that you have the skills for what we need, so we're going to put you into that role. Are you interested in doing that? That's great. But that being the case, nobody actually explained what the process was to lead to that conversation. That may not have happened for them either. So be aware that they may need to go do some research. You may need to go do some research on understanding, hey, in this organization, what is the process for that? Do we have to do nominations? Do we have to have particular ratings at the end of the year for performance reviews? What does that structure look like? That's probably a conversation that needs to be had with HR, and your manager may not know what that is. The other one is an important note. We talk about how you're asking to take on additional responsibility to show people that you can handle the additional skill, or you're asking to take on more responsibility so that you can show them that you're capable of performing those tasks, that you're saying, hey, I want this to become my job. This is what I want to do. There's a part of that that you need to be able to build the confidence that you can do that. Now, you also have to go through a very similar conversation of trust building when you are switching organizations, right? I have to convince somebody without actually having them see my work ethic, without having see what I've done on a daily basis for the last however many years at my current organization, that I can actually do those things. And so if you're looking for a promotion and you're looking to transition out of an engineering role or a development role into a management role, that requires trust. It additionally requires trust when you're switching companies. And so to ask for a promotion out of a non-management role into a management role and get hired into an organization can be very challenging. So I want to warn everybody with that could be very, very difficult to do because you're asking people to take a huge leap of faith on you. What I will say is that some of you may not have another option. If your organization is one where you have built a bad reputation that you haven't been able to shake, even though you've made some changes, you had bad conversation, bad luck, very little movement, there may be a whole bunch of reasons why you need to change an organization to make that happen. What you may need to do in that scenario, if you're having a hard time getting that transition to happen as well as a company change, is make a lateral move and make that part of your interview conversation. Hey, I'm interested in doing this. This is something that I'm really passionate about. What I really want to do, though, as part of this agreement for me coming to your organization is to move into a leadership role in the future. That is important to me. And you set the stage. You set it, the line in the sand and say, hey, I'm willing to come invest in you as long as you're willing to invest in me and put me on this track. Any organization that hears that as part of the interview, number one, is usually excited. That means that you're interested in growing, you're interested in changing your skill set, that there's other places that they may be able to move you to in the future. And that's a great opportunity for them. So be upfront with that as you have those conversations if that's what you're trying to do. But be aware that you may need to make a lateral move in order to get that to happen. Okay, a couple skills for where to get started. Right, I'm ready to ask for more responsibility. Where are some of the things that I can assist with that? There's an important differentiator between management and leadership skills. And this will be the time where I'll ask for audience participation. Anybody want to share what they think the difference is between those? Yeah.
I could be off on this, but it seems like management kind of plots the direction, but leadership guides the team along that direction.
Yeah, that is very close to how I would also frame it. I don't know that there's a great way that I can come up with off the top of my head to say, here's the perfect definition for it. But the general sense is the management is the push, right? Hey, I need you to go do this thing. Here's the project, here's the deliverable, go do that thing. The leadership is the pull. Hey, I'm headed this way. I think this is a great idea. We should do this. Why don't y'all come with me? Can I get you to come buy into this concept? And both of those are important parts. And you have to learn both of those to be an effective manager and an effective leader. And so you're going to want to start developing both of those skills. From a management perspective, delegation is a really hard one, again, especially coming from technical tracks. You're used to being able to just put your hands on the keyboard and do the thing. And knowing when, hey, do I have to be the person that does this, or can I get somebody else to do that? That becomes an important component of it. So knowing when you can delegate, that rapidly becomes an important skill once you do move into a management role. Systems thinking is another one. I mentioned that earlier. Donna Meadows has a great book called Primer on Systems Thinking, I think. If you look up Donna Meadows, it's certainly her most popular book in coaching. Hey, this didn't go terribly well. How can we help make that better in the future? Those start becoming important management skills as easy things that you can pick up to show folks that you've got that capability. The leadership skills, the emotional intelligence, this is a difficult one, again, coming from engineering. You're so used to working with computers. The computer doesn't really talk back, or at least if it does, you can get into an argument without upsetting anybody. Conflict resolution, trust building, all of those components. Starting to understand the psychology components of how you're interacting with people, how you make them feel safe, how you tell somebody that their work wasn't very good and make them happy coming out of that conversation because they had an opportunity to improve and not just feeling like they just got beat up because it wasn't up to expectations. And then have patience. This all takes time. So if you're sitting here today and you're like, hey, I'm ready for this, I want to do it, I've been waiting for my opportunity. If you haven't had that conversation with your manager, if you haven't had that conversation with HR, if you haven't started taking on some of these skills and these responsibilities, you need to give yourself time to be able to start building those and showing people that you can do that. And this can be one of the harder parts of the role in general. One of the challenges of being in a management and leadership role, especially as you move up within organizations, is that you have delayed feedback. Great thing about writing code is you can write the code and then pretty much immediately know if it worked or not. Is it doing what I need it to or not? One of the really big challenges of being in management, especially senior management, director, C-level roles, is that you make decisions about roadmap, you set strategy, and it's a 3-year decision. And you've got to wait 3 years to find out if it worked. And sometimes you realize that at year number 3, you're only halfway through where you thought you would be with that roadmap. You've got another 3 years to go. And so you've got to wait 6 years to get feedback on if that decision was right or not. That can be very difficult. All right, things to do. You start working on the skills, you've got an idea, you've got an approach. What can you actually just start doing right away to try and make progress towards making a transition? Number one, build relationships. The further you go in a management and leadership career, the more and more the relationships become the important part, more than anything else. Start finding people across the organization that you can connect to. Hey, I'm Dave, I work in IT. I was just curious, I've seen you around. What department do you work in? Again, curious, what does your department do? How does that tie into the business? Start understanding who people are in the organization and how things work. Search for perspective and focus on strategy. This is another tie-in. This comes with building those relationships with folks. That is a step that will help move you along in that direction. But getting an understanding of why decisions are being made very much will help you in this journey, and it's going to help you in an interview quite a bit too. One of the things from a individual contributor perspective, it's so easy to criticize decisions that have been made across the organization. I cannot believe that they did this. These idiots, I know better, and I'm the lowest person on the totem pole. This doesn't make any sense. Why would they have done this? You're missing so much context as to why that decision was made, as to who was involved in the decision. And understanding that the initial reaction of like, this seems like the dumbest thing I've ever heard. I can't believe I work for this company. And then understanding that there are so many things that you don't know that went into that decision becomes very, very important. So start understanding. If you don't understand why a decision was made, or if you disagree with the decision, I can't believe they did this, instead of being angry about it, start asking questions. Go find people who would be close to that and start trying to figure out who was involved in that decision, what were the factors that played into it. That becomes incredibly important. And it's very visible because it shows that you're interested, it shows your curiosity, it shows that you want to grow. Seek the feedback, have conversations with people. What do I struggle with? What are the challenges that I'm working through right now? I have a whole bunch of those. Any day that I come into work, I've got 5 mistakes before lunch that I'm thinking about. Oh man, I got a long way to go still. Get that perspective. That is important. Ask for opportunities. We talked about that. The responsibility, just take on responsibility. You need to ask for those though. Start volunteering for things. And you don't have to do it necessarily as your day job. We're paid to do one thing, but here's a whole bunch of other things that you can do to contribute to that. One of those is the ERGs. If your organization has ERGs, volunteer to lead an ERG. You're going to meet a whole bunch of people. You're going to get an opportunity to lead some things, organize some things. Great way to build a relationship and show that you want to contribute to the organization. Volunteer with a nonprofit. Look up Toastmasters if you're not familiar with them. If you're afraid of public speaking, if you're afraid of communicating with people, that would be a good place to go. I didn't mention it on here, but improv classes are very popular too. Once you start getting into director and C-level folks, a lot of them have gone through some level of improv class, I have noticed. And as a general rule of thumb, 150% is one that gets thrown around quite a bit in the materials that I looked at leading up to this of what to put together. And the idea was you should be able to do 100% of your job effectively and 50% of whatever role you're trying to move into. Now, it doesn't mean 100% of the time, but if you're trying to take a role, if you want to move into your manager's role, your manager should be able to come to you with half of the things that they do on a daily basis and say, hey, can you help out with this real quick? Doesn't mean you need to do it all the time, but you need to be able to prove that you can do half of their job. That is a good marker that you're ready. Okay, we're going to go through the last few fairly quickly. I know we're running low on time. So tips and tricks, find your resources. Management and leadership skills are just like anything else. I had a conversation with somebody a couple weeks ago. They said, hey, I just had this really bad interaction with somebody else. I'm really curious. Can you come look at this email and tell me what went wrong? I don't understand what happened. I read the email and I said, yeah, well, let's talk about the way that this person understood that. Let's talk about the way that you framed it, the way that you phrased it. Now let's talk about their perspective and what they care about. And the reaction that I was given was, oh my gosh, thank you, that was so helpful. I just don't know how to do that. And it's really great that we're lucky to have people that know how to communicate like you do, that can talk through situations like that. 3 years ago, I never would have been able to figure that out. That is just another skill. Spend some time, read some books, watch some videos, find your resources. You can learn those skills just like anything else. Practice small. This is the important part. We're talking about delayed feedback. Sometimes it takes that 3, 5, 8 years before you find out if your decisions were right or not. The smaller, lesser significant situations you can put yourself in more consistently to practice those skills is going to help a lot. As you move on, that will become less common. So you will need to seek out small opportunities to practice any of that. Coaching with a peer. Hey, can I give you some feedback real quick? Take every opportunity you can to have those conversations. Find a mentor or a coach, particularly one that can keep you honest. You need to have a relationship in that capacity with someone who can tell you when you've made a mistake, not just somebody that thinks that you're great and isn't going to tell you the truth, isn't going to help you along in that path. This person may or may not be someone that you like at work. I want to be really clear with that. Finding someone that you're sort of frenemies with or disagree with a lot is often one of the best people that you can find to be that mentor or coach, because they're not going to hold back very often in giving you that feedback. Here's what I didn't like. Here's what rubbed me wrong. That is very valuable. The other person that you're going to want to look for is an advocate. This sometimes can be the same person. It's not always the same person. That advocate is the person who's going to go through and champion for you. And you can have an explicit relationship with them to say, hey, I am working on this. I'm interested. This is someone that you want to have a good relationship with. Will you support me? As you go into those conversations, as those conversations are coming up at your level about what next steps look like, what reorgs look like, who should move into what spots in the organization, will you support me as I continue to work through this? I'm working with a coach. Here's who I'm working with. But will you continue to put my name out there in those discussions? And then the other part, don't boast. This is a little tricky. If you have to tell me how good your work is, I probably don't believe you. Show me the work. Let's see it. I will go off of the work that you've done. But if you have to tell me to try and convince me that you did a great job, I am immediately going to get very suspicious of what you're trying to compensate for. So be mindful of that. Okay, be sure that you want to do it. We'll wrap things up, and I've got a couple of resources here at the end. Start small, test the waters. One of the nice things about this is that as you're taking on additional responsibility, as you are starting to learn some of those skills, as you're having conversations with people, one of the biggest fears that I've had with folks over the years when they're like, oh gosh, I just don't know. I don't know if I want to give up my engineering career to do management. Like, it seems like I could, I think I'd be pretty good at it, but I really enjoy this. And what if I am bad at it and it's really embarrassing to go back? The great thing is if you do all of these steps, at no point for what we've talked about today are you in a management role already. You can back out of that. You can take on whatever responsibility you want. You can test it out. You can decide if this is a good idea. Does it feel right? Does it fit right? Is this the right or wrong organization to do this with? You are not hard committed, and you can easily back out without having to worry about what are people going to think about if I move into a management role and then move back to engineering because it sucks. Reminder, understand the limitations of your manager, work with them, but understand that they can't control that for you. And start building relationships. That would be the other big thing that I would say is really just going to make such a big difference for you. Make your intentions clear, but start taking on responsibility and build relationships across the organization. Okay, a couple of resources. Some analog ones that are really important. This is the most recommended book that I've ever had to anyone. I do this consistently. Crucial Conversations is incredible. If you want to know how to give feedback to people, if you want to know how to start moving forward in conversations, if you want to know how to have a conversation with your boss about something that's really sensitive, I'm afraid to bring it up, Crucial Conversations is the one that you want. The great thing, too, at the end of it, there's an appendix. So once you've read through it and you actually understand the context, in the appendix, there's like a little cheat sheet that says, like, here's a reminder of all the steps. I use that to this day very often, a couple times a month, where I'm like, I'm going to have a sensitive conversation with somebody. We got to go sit down and work through this. I will pull up the guide sheet in the appendix and take a quick look at that again and be like, okay, what do I need to prepare for this conversation to make sure it goes well? When I use it and when I don't use it, night and day. The next two books, The Manager's Path and Scaling People, those are very much tactical books on management. If you're getting into the role or you want to know what it looks like to actually do it on a daily basis of like, what is the day-to-day of working on a reorg or working on budget management or coming up with vision and mission, those books have really great, here's how we've approached it from large organizations, from small organizations. Here's a template that we put together to help walk you through some of those. Excellent, excellent resources. Elegant Puzzle, Scaling People and Elegant Puzzle fit into that. The Manager's Path is very specifically a book on transitioning out of an engineering role into a management role, particularly within the same organization too, where you're potentially managing formally your peers. Highly recommend those. And the digital resources. Managers Tools podcast is an interesting one. They're very opinionated. I disagree with them fairly often, but the great thing is they give you a good guideline. They give you an opportunity to learn some things of how do I want to approach this. And then you can take that later and be like, you know what, that actually doesn't work for me. That doesn't work for my style, even though they were very adamant that this is the only way to do it. I've taken a lot of their things as a starting approach early in my career, and then thrown some of it out later when I realized that it didn't fit my style. The RANS Leadership Slack, you can Google that one. That's a great resource. Lots and lots of people, 35,000 people, I think, in the RANS Slack, all focused on leadership topics. Irrational Exuberance, that's Will's book from the previous slide. And the last few are contact information for me. So just leading up to this conference, I started up a new website. We'll use this as the tester to see if anybody's actually interested. You can subscribe there if you want. Regularrevision.com. I think I put 2 articles up just so that it's not a blank page. I will start posting there as the next couple of weeks. So if you want to follow along there, you can find me on LinkedIn, and there's an email that you can contact me at. And that is the end of my prepared content. So thank you. I appreciate everybody sitting through that. I know we started a minute or two late, and I probably ran 2 or 3 minutes late, but what questions can I take?
Do you ever regret leaving engineering and going into management?
Yes, there are moments. But they have gotten less and less common as time has gone on, and a lot of it was because of build habits. I can give you some very specific examples of, I used to work, you'd work all day, and then run into 2 or 3 things during the day that were interesting that you wanted to maybe expand to, but didn't have time during the day. So I'd go home and sit with the home lab for 3 or 4 hours every night. And then transitioning into management, there was like a good 12 to 18 months where I would come home and be like, what do I do now? This is weird. So some of those have been really difficult, and it was just getting through the discomfort of that. And then there's been a couple of moments because of the hard cutoff where I'm like, I know how to solve that problem, and it can be difficult to coach people through, right? If you can tell somebody the answer, but that work telling people the answer every time and coaching people through how to figure out the answer so that you don't have to tell them every time can be very difficult, it's surprising the amount of times where you're like, I don't know another way to explain this to get this through. Maybe I should just go back to doing it myself. But it's fairly uncommon. I'm really happy with the decision, even though the first few years were a tricky transition. The impact is so much bigger.
The hesitation on my part has always been the work-life balance. I've seen other managers and go, oh my God, I mean, they're putting in crazy hours where I can pretty much manage that. So I was wondering your thoughts on work-life balance, how you've navigated that, and did you see, oh God, my work-life balance from engineering to manager has gotten worse? What are technique? Okay, now I have to navigate. How do I navigate? And some of the challenges.
Yeah. No, it's a great question. Honestly, time management is one of the biggest struggles still for me to this day. And the reality is that, yes, the first 8 to 10 months or so of my transition was a worse work-life balance. But I also knew that I was going to do that to myself because of the situation that was around it. I knew, like, hey, if I step into this, the next 8 to 10 months is going to be difficult because I have to rebuild an entire team. I have to come up with process, procedure, policy, structure, all of those pieces. And I can't do it during the day because I still have to get the work done. And so I accepted that part of it. But what became important was that I started pushing back against my new peers who were doing that and expected the same from me. And it was difficult and it required a lot of trust. But being good at what you did and say, hey, I am delivering at work at 100% because I am not focused on work when I'm not here is the trade-off. So You can get 60% of me during the day if you want 40% of me at night, but I would rather just put in 100% during the 8 hours that I'm here, and let's work together to agree that that's okay, and I will prove to you that I can execute on that promise. That was an important part. Yeah, there's still some pieces of work-life balance, but I will say I recently transitioned out of being in the call tree for the on-call parts now too, and now work-life balance tends to be better from that part of like, I don't get woken up at 3 o'clock in the morning anymore of like, hey, somebody forgot to pick up the on-call. But I do get the 7 o'clock and the 6 a.m. calls of, hey, we ran into this issue and I need you to run it down real quick. Those are easier to manage and much more in line with what my engineering responsibilities were as well. And so, yeah, it's very tough. There's a whole class that you could teach in college on management, time management.
Thank you.
Yeah.
Are there any other questions? All right, thank you.
Great, thank you.
Good afternoon, everyone. Welcome back. Quick reminders. One, if you are an Ohio resident, please check out the potential license plate option if you wish to upgrade your license plate to an amazing looking Ohio Linux Fest license plate. Also, the raffle prizes are right outside the door as well, so you can take a look at those for the raffles that's been shown up on the screen in between sessions. I would love to welcome Anthony here. He is a volunteer for the Rocky Linux community, passionate around Linux system administration and Kubernetes, along with security around them. And I am happy that we get to assist him through his ambition, providing him this opportunity towards kind of bridging that gap between VMs and containers. So take it away, Anthony. Thank you.
All right, appreciate that. Thank you so much. How's it going, everyone? Let's start off with some context. Who am I? My name is Anthony Navarro. I am an actual Linux systems administrator. And a couple of things about myself personally. I mean, I'm here with my beautiful wife, who is my teddy bear debugger. And I have my beautiful 1-year-old daughter, who is my super engineer, as I like to call her. Between myself and my coworker, I like to call her the super engineer because she is much more advanced than I am. She literally speaks in code, if not ba, 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 as she goes and smacks my keyboard, as you can see in the photo there. And, you know, I'm very proud of my family because of a lot of reasons. A lot of personal, and also it was kind of a struggle for me when I first graduated college. No jobs, bills are relentless, had to learn a whole new skill set. I had to go into construction. Then it was a struggle to get back from that. And when you also have autism and ADHD, that is also a barrier to entry. And so I had to really, you know, tell myself it's going to be okay. Let's just keep going. And my passion for Linux got me here. And, you know, and it's thanks to that and my family, I just wouldn't be here without them. So let's talk about the agenda first. You know, some of you here are either, maybe you're new to Linux, or maybe you're new to Kubernetes, or maybe you're quite advanced. So I'm going to do my best to be as modular and as open as I can with all of you, because even though I use Kubernetes every day, that might not be the case for you. So I'm going to help you try to get up to speed to where I'm at as best I can, and then it will help you understand more of the context of this. And so if I come up to you randomly and I ask you what's VIC, you'll know what VIC is. It is virtualization in Kubernetes. So we're going to start with the virtualization aspect. So the question that came to my mind, especially when I first got introduced to, you know, to KubeVirt and what is this project and what is this all about, is why would I want VMs when we are in a world and an age of containers? These were a few points that I came up with. Maybe you have a unique or a different reason for why you would even conceptualize this. Why would you dream this up in the first place? And some of them make sense. For example, you have an application. Maybe it's a really old Java application, a WAR file, can't really get it running. Maybe you're running Tomcat. Maybe, and it's very peculiar about resources. Maybe you have a licensing cost problem. Maybe your organization has a few Linux or even Windows VMs in a vSphere situation, and you're trying to look for options. You know, you just invested so much money into hardware, and you have a really nice, you know, kubeadm setup, or you have a really good Kubernetes setup, and you're looking for somewhere else to put those VMs, if that's even possible. Maybe you're looking at just leveraging those K8 features, right? Because Kubernetes is a really good orchestrator. It does a really good job at doing that. So why not leverage what's already there? You just need something that can kind of fill in the gap. And that's where KubeVirt comes in. So what exactly is KubeVirt again? Refresh my memory. Well, one sentence answer, it adds a functionality that Kubernetes requires to manage or to perform management of virtual machines. This picture, as you can see here, describes the stack in a sense. You have the physical, or I guess virtual, depending on your situation, because I know nested VMs are a thing. But in this example, we have physical layers, we have KVM, that's under the hood, and we got the operating system, the container runtime, and of course, from there, Kubernetes takes over with its scheduler and with its orchestration and API server, and as a result, you have KubeVirt. And this is very helpful. And it's also very easy to install. It's just a matter of looking at the kubevirt.io website. You click on the installation guide. You enter a couple of, if you're familiar with the kubectl or kubectl command, you just run apply-f to a few YAML files. You already have it installed. You're good to go. It's the custom resource definition that you have to install. You also have to install the project's own way of making sure that your hardware can accept virtualization. So, of course, from a hardware perspective, make sure in your BIOS settings, you can even accept virtualization, of course, right? And once you have all these things installed, then it's just a matter of figuring out from here, well, where do I go from here then? I've run these kubectl apply commands, and I now have what looks like KubeVirt running, and in my cluster, I can see the KubeVirt API is there, and I can also see the Virt controller there, and I can see something called a Virt handler, and it literally says that, word for word. And so then you're doing a kubectl get pods, and you look at their list of what's actually running in your cluster, and you see these, and you're wondering, okay, so it's installed, I guess, so then what do I do now? And so that's what this overview picture is to show you, what's actually happening behind the scenes. Essentially, for those who are familiar with kubectl, you're always talking with the actual Kubernetes API server when you run those commands. But what KubeVirt does when you install it is it adds an additional API. It adds an additional controller that works together with and integrates, in a sense, with the functionalities of the API server that already exists. It also adds, kind of like a translator, I guess is a nice way to put it, but it also adds that Virt handler. So even though on the actual Linux backend, like in the actual node, you're actually running things like QEMU, libvirtd, you're running all these things, it's kind of orchestrated it away for you. It's kind of automated in a sense where you're giving now, instead of having to manually run this and manually create these VMs with virtsh or with all these additional command line, you're letting Kubernetes take over that part for you. And I'll talk to you a little more about that command line as well, because there is actually a tool that helps you even automate this further. And another perspective that I'll give you as well, because there's multiple ways to explain the same thing, so I'm going to make sure I cover that for you as well. And essentially, on your master node, which is where the API server sits, and where your etcd, where everything that Kubernetes needs to run sits on, the installation of KubeVirt adds a controller and an additional API there specific to only the virtual machine part. Then you have multiple agents, just like Kubelet. If you're familiar with Kubelet, you also have an additional agent there that only looks out for requests coming in for virtual machines. And so then by having this functionality and by being able to add this now to your YAML files that can actually specifically target and be requests that can be accepted by this new API, then the world's your oyster. You can go ahead and you can put containers together in one pod with a VM. Maybe you only need the VM. Maybe you need the VM with multiple containers in it. At that point, it's fair game. You can go ahead and customize it as you wish for your needs at that point. And so that kind of is my way of trying to bring you up to speed. I hope that helped, because now we're going to go more in depth to how do I get started then? Now that I have KubeVirt installed, now that I kind of have an idea how it's running and how it's installed and how it's even doing any of this stuff, how do I get it to run? How do I get started? So first, we're going to talk about what the YAML files look like, what to expect there. Then we're going to talk about that additional tool that I was telling you about called virtctl or virt control. And then we're going to talk about VM techniques. So use cases, like what kind of use case could I potentially see this working with? And so we're going to talk about it as well. And then, of course, why do I personally use it? And then question and answers. So the first one we're going to talk about is an interesting hybrid, container disks. Container disks have their advantages. Super speedy. They just start up just like any other container. And you could even customize that container disk as you please with whatever software you want, the same as you would any other container, except you get that additional customization with virtto, and you would also gain some additional customization where you can actually use systemd. You can actually use system control. You can actually use cloud init to set it up as you please, and you don't have to worry about almost potentially breaking your node because it is its own isolated environment like any other virtual machine. And as you can see as well from the YAML file, you can see where I specify somewhere at the top, you can see API version is kubevirt version 1. That is where I'm specifying the actual virt API that is installed on the cluster. And if you continue going down, you can see the usual that you would expect from containers is, of course, you have your namespace, you have the name, what is it called. Then you also have your container disk. Is it a cloud init container? Is it not container disk? How much memory am I giving it? How much CPU am I going to give you? How long am I expecting you to start up? So please start up within 180 seconds or fail. That's what the termination grace period seconds is for. And of course, it was my own custom Rocky 9. So of course, that you can see a random name there / Rocky and the tag. It can be whatever you want. It can be your own disk. And then of course, I added the cloud init. So for any of you who would like to completely customize it down to what usernames are allowed to be on it, so you can SSH into it. Do you want it to have a password? Do you want that password to expire or not? Do you want it to be accessible? You can put that all in that part of the YAML file. So that's container disk. Now, the disadvantage to container disk is obvious. If you were to run the reboot command, bye-bye. Anything that you installed on it previously is gone. So let's talk about the persistent version of that. So VMs with PVC, or persistent volume claims. So this one, you'll notice that the manifest still looks quite familiar for those who are in the Kubernetes space. It still looks like any other container YAML file that you would see. In this case, you're dealing with a PVC. So I kind of split it up for you. So the top is just the virtual machine part, meaning I'm only specifying where the disk is. I'm specifying your resources. I want virtto because it's what I'm familiar with. And I want to specify and call it root disk because this is just a test, so it can be whatever you want it to be. And of course, the domain, I want it to just be called Rocky 9 so that when I want to look up my virtual machines, I want to be able to look at that namespace and look for that specific VM called Rocky 9. The persistent volume claim part that comes in, though, however, that's where some more customization comes in. In this example, I have in the cluster, now obviously for production, you shouldn't have an NFS server within your cluster, but this was a test. It's better to have it outside the cluster. However, in this example, I have an NFS server that runs inside the cluster, so I just specify that I've configured it so that you just put in the name of that storage class, NFS, and it'll allocate that space that I need. Go ahead. And it is called Rocky 9 PVC. I specify how much storage I want, and that's that. Now, that's what it would look like for a VM with PVC. How about data volumes? What in the heck is that? Because that is another option that the project specifically says you can do with kubevirt. Well, how this works is it's essentially the same as PVC, except you don't have to worry too much about customizing your disk image, which I'll come back to that after. But in this example for data volume, it is where you already have a QCOWS2 image. So it can be, maybe you have vSphere, VMDK, and you've converted it to QCOWS2. Maybe you have your own KVM set up, and you have the image file still, and you've placed it on a server somewhere that can be accessed by HTTPS. And so in the YAML file, I've specified that, yes, create this PVC on my NFS server, and I want you to pull the image necessary to boot from this specific location. So in this example, I'm using the official Rocky Linux QCOWS2 image that they publicly have online. Obviously, for production, don't do this. But in this example, this is just to grab that QCOWS2 image. It automatically provisions your PVC. It'll essentially put that image into the PVC. And so then at that point, when the virtual machine starts up, it's essentially booting from the PVC once it is complete. And it goes through a whole cycle where it will tell you on the screen, once you apply this YAML, it'll tell you that it's downloading from source and that it does a little loading bar, tells you when it's complete. And then next thing you know, you'll see pods spinning up that says Vert Launcher, whatever the flag is. And then from there, you can do what you got to do. You can log into your VM and do what you got to do. So Vert control or Vert CTL. So give me a little, why would I care about this? The project specifies that Vert CTL allows you to do a little more customization. They use something called the VDI, which is the data containerization importer. And what that does is it uses a pod, it spins up a container that allows you to import or to move your image, your ISO or your QCOWS2 to your PVC that you're allocating for these VMs. So this is an example of a command that you would run to make that happen. So in this example, I'm saying, all right, Vert control, I want you to create a PVC for me called Rocky-PVC. I want the size to be 100 gigs. I want it to be insecure. Obviously, you shouldn't do that, but this is only a test. It usually is preferred to do it in HTTPS or secure, but then to do that, you have to go through some extra steps like setting up an SSL. I just kind of wanted to show you the functionality. But if you say insecure, it will just grab it and just move it using HTTP and gets the job done. Then you say the image path. So because I did SFTP and I moved the image onto the master node already, I just had to grab it from the master node's home from my user, and the image was called Rocky9 in this example in this test environment. And I want to specifically specify which, once you've created my PVC, once you've added my image to that PVC, I want it to be in the Rocky9 namespace. And I don't need you to create the namespace, which is why I put --no-create. And then your upload proxy URL will be HTTPS and whatever address your nodes are on port 31001. And this is something that you get to configure custom when you install the CDI that you need, also from the kubevert.io website. And you can also set it up in any way you like to get this job done. So then at that point, after I've installed vertctl and after I've run this command that you can see here, I would then just have to run vertctl-n to specify the namespace, of course, that I just created. And I can then SSH into this YAML file I showed you earlier where I'm specifying user Rocky password Rocky, and then I'm got the shell to do what I got to do on that virtual machine. And of course, if I ever needed to, let's just say I got rid of that container, I got rid of that VM, I got rid of that stuff, and I spin up a new one with the same name, and it's not working properly, it's probably because you forgot to clean out the known hosts, because it does create its own SSH known hosts file in the same location that you're familiar with, except it's called the KubeVirt known hosts. So, VM creation techniques. Why? Creating this VM is extremely helpful in situations where you have the resource, you have the hardware, you have the kubeadm install or the environment that you need, but you need an alternative for running virtual machines alongside your containers. Or you have a very specific use case where you have a bunch of VMDKs, a bunch of VDIs at your disposal, and you want to find another place to test them, and you just happen to have access to a Kubernetes cluster. Or you have an application that just simply is just not containerizable, or you're in between migrations. So you need a solution that works right now for something that's still in the works. Then having KubeVirt is a great tool to have in your back pocket. A little something to, in case you need it. Of course, using QEMU image convert will also help you accomplish this stuff. And I have a couple of links here. I'll make sure that the slides are available to you, but otherwise, you can always visit kubevirt.io. They also that community also does meetings every week, so if you have additional questions or you want to contribute in any way, you're totally welcome to do that as well. So why do I use KubeVirt exactly? Like what got me into it? What's the point? Why, Anthony? Why would you do this? Well, my own specific peculiar use case for KubeVirt may not be the same as yours, but for me, I just love the fact that I already have a Kubernetes cluster already, and I love the fact that I can just spin up VMs on a whim, and I can just do it very fast, and I can implement replica sets. I can have 20 of them if I want, one moment, 0 of them if I want, and it's been a wonderful testing experience. It also allows me to be able to provide better documentation for my organization as well. And it allows me to also test out things before even thinking about going to staging and then ultimately to production. I can spin up a Rocky Linux VM. I can install whatever the heck I want in the example of container disk and do all the stuff that I want. And if something breaks or if an update broke something, then I'd be able to accurately report that, yes, this update does this and it will break it. If I wanted to set up my own customized testing environment, I want to set up my own Jenkins pipeline, I want to integrate that with Git, I can do that. I can spin it up just like that, set up the VM, and it's the same as as one would traditionally operate using the secure shell into a VM. So it gives me helps me leverage the power of Kubernetes and how it is so good at doing the orchestration, while I also get that additional isolation, that access to systemd and all of that without really having to break the bank. And so it's been wonderful for home labs. So for those who have home labs, this is a great idea. And the deployment is so much easier because you just need to make sure your YAML files work with your specific need, or they're custom to your needs. And there's a lot of different use cases that I've seen on the KubeVirt website. And of course, there is potential for unified DevOps workflows. Essentially, you can do whatever you want. And in my specific environment, I have my Jenkins pipeline set up. That Jenkins VM has Ansible installed, and it goes and runs patches. It does a bunch of automation. I only have to click let my PR get approved, and next thing you know, I have another virtual machine ready to go, just like that. And those are just a little scratching the surface of what you can do with KubeVirt. So I ask, is there any questions that I can answer?
Are there any questions? I don't see any, and there weren't any on Slack. All right, so thank you.
All right, that's awesome. Well, thank you so much. If you have anything else, you can always come catch me at the Rocky Linux booth anytime. Thank you so much, everyone. Appreciate your time.
We do have one quick announcement. If you are missing a parking ticket from the Chestnut Garage and arrived at around 3:41 this afternoon, it's at the registration table. And another announcement, if you haven't noticed on the screen, please check out the raffle at go.rallyup.com, OLF hyphen 2024. There's quite a few nice items up there.
Good afternoon, everyone. Quick reminders. One, we've got the raffle. You can check out all the raffle prizes outside. And two, if you are an Ohio resident, please check out the opportunity to upgrade your license plate to an Ohio Linux Fest license plate. I'd like to welcome Liang, thankfully supporting us again. He is passionate around open source and Linux, as well as the GPU cloud architectures and AI infrastructure. So please give a round of applause for Liang.
Okay, yeah. Hello, everyone. My name is Liang Yan. I'm currently a software engineer from CoreWeave. This is a GPU cloud provider, startup model. Currently, we mostly provide GPU cloud to business customer there. We don't provide it to people development, but more like AI startup or other kind of AI companies there. So today I'm going to give you a topic about the how to optimize AI cloud infrastructure, but not like from the AI model, but from a hardware perspective. So a little bit about myself here. Like I said, I live in Louisville, Kentucky. 3 hours driving distance. So it's drivable to here. So that's why I've been keep here. This is my 7th time to the OLF. Always enjoyed being here. So I'm currently a performance engineer, focused on the AI infrastructure and system machine learning. So I've been working on all Linux stuff, Linux kernel virtualization for over 10 years. I'm definitely open source enthusiast. Also quite enjoy ARM64 gig. All kinds of ARM64 board there. So yeah, let's back to the topic here. So I think we have been heard now AI is everywhere. We all hear people talking, hey, this is a model, that model. I have billions kind of parameter, all this stuff. But I'm going to focus on the AI infrastructure because when we see, we kind of see this kind of news everywhere. This company spend billions of dollars to their data center. That company, like XAI, bought hundreds of thousands of GPUs there, which also cost $1 billion there. So it seems $1 billion is kind of a startup for the AI infrastructure, AI cloud. So yeah, so I think first I'll introduce a little bit about what would be AI infrastructure, what it looks like, and why we need them. And then step further, we'll see like what makes AI infrastructure special, and when we want to optimize it, what should we focus on? Last part is from the machine learning perspective, mostly from the system machine learning perspective. We'll see how we could take full advantage of your AI infrastructure because we spend kind of $1 billion there. We definitely don't want to waste the hardware there. And we'll just see how that could work. We'll also share some observation and some tips lessons we learned during the process. So I think let's start from the AI cloud and AI infrastructure side. So now it's everywhere, but people may ask like, do they come from nowhere? What it would like before this AI generation? I would say actually it's not. Like it's actually been there for quite a while. Like before the now it's ChatGPT. Before ChatGPT, there's actually a long history back to 1940, 1950. It's all about machine learning. And back then, of course, there's no GPU. It's mostly CPU, and they call it HPC, high performance compute there. And if you see but they mostly from the big company. Actually, even company don't have this capital to do these things. It's mostly from like national lab or kind of a national research center, or even kind of a medical or kind of this giant company. They're working on the HPC, and they make it work. And then these days, suddenly comes to a cloud, and cloud is convenient. Now cloud is easy and cheap there, so it's everywhere now. So when it comes to the AI, they kind of want an AI cloud there. So, but there is some basic difference. For HPC, like the high performance compute there, it's actually, it knows the task already. So the system there, they already know what kind of, they know their system very well. They know the task very well. They just to try and make it efficient in this task. However, cloud is totally a different concept. It's like it's somewhere else. Like if you allocate, I'll provide you, and it's unlimited. So this is a totally different direction before the HPC and cloud. But the cloud, because using all the virtualization or containerization, it makes it quite cheap and easy to management. They're just about convenient, make it quite popular. So people thinking like now today, so we need this high compute, and we already have the compute. So why don't we have this AI cloud? And based on that, it comes to AI cloud, and then also comes with the AI infrastructure. But what does AI cloud really looks like? So if thinking the traditional HPC, it's mostly, you could see, it's a bunch of servers there, and they run the like Slurm today. It's kind of a scheduler tools. Because they mostly care about how make a task run efficient, and that's all. So that's essential for AI, for machine learning. But that's not all. When you're looking at the cloud, it actually has more features there. It's like you could see it has all this infrastructure layer from like there's data from the storage, and there is resource, GPU, CPU, and all these hardware they could deployment, and after that you could put all the resource there, and then also it comes with the storage network. It also has like a DevOps kind of a function there. It could be monitor, and it could give you a lot of information. Also, there's some difference between the traditional cloud. It's like when we do the machine learning, we know there's a bunch of data there. So you see the left side, it's actually quite a bit about on the data set. And also, if you look at the center side, because they needed to do all kinds of the HPC kind of computer, high performance computer, high density computer there. So they actually needed some kind of a framework to do that, because they needed to, all these kind of AI machine learning, they high related to mathematics there. And if we programming there, we kind of need like, we definitely don't want to do any kind of a mathematical equation there. So it comes all this kind of a framework, distributed training. There's also PyTorch, Fast AI there. And this is specifically for the AI. But now we kind of merge them together. So we come to this AI compute. From hardware side, yes, we definitely want a special AI cloud outside. It could have everything there. It could easily maintain, manage the hardware. You could get the data, training, and then share the API to your customer, and all in one place, in one data center. But how does the AI model today, like how does the AI model also kind of need an AI infrastructure based on that? Do they need to think about AI infrastructure? The question is actually yes. You're looking here. This is a AI model tree here. You can see there's some pink. This is a tree here. There's some branches here. You can see there's some pink tree, and then the green, and the gray kind of blue tree there. So this is actually how AI model developed these days. It uses some, because the large language model here, it's actually have different mode to do that. Like the left side, if you see the pink, there's a encode only mode. There's also decode only mode. And there's also the encode and decode mode. We can clearly see that the blue tree is quite survived there. That's actually because it's easy to deploy it in it's actually from the infrastructure. It's easy to deployment there. It could easily to scale to a whole infrastructure. That could make it, that's becomes more and more popular there. So it comes to a lot of other models there based on this decode only pattern. So yeah, this is like before 2020, it's more like traditional machine learning or the very simple neural network learning there. The data set is relatively small. It's like it's only like 10 billion parameters there. The model size is also small. It's 1 gigabyte there. And the professor in the school could do that, could develop that. They could only spend like 100K money there, buy a few GPU node. They could totally develop that. And their focus is how to get a better algorithm. But after that, OpenAI, the OpenAI scaling law there, they found that if you get more data set there, and you put more parameters to your model, you could get a better performance, a better model there. So suddenly all these kind of AI startup, AI corp, they are trying to expand. So now the data set is suddenly comes to the terabyte size, and the model is also comes to like 100 billion size. At this moment, they need like at least $100 million to go to a GPU cluster, at least multiple $1 million there. And now, because of all the data set, all the cluster get bigger, now direction becomes more focused on to process your data and how to do like the feature engineering and also like how to manage your data center. But that's only the beginning. After that, I think it's just from last year, late last year, early this year, and it gets even bigger. Like if you notice that like for Llama 3, Facebook, they have the Llama 3, and OpenAI, they have this GPT-3. But if you see all the news there, they said, hey, I only run this kind of training. It costs one time. It cost me like dozens of $1 million for one training. That's unbelievable. That's incredible there. Like that quite limited the people to do this kind of work. Academic, the university definitely couldn't afford it. Small company, they couldn't afford it either. So now it only limited to the giant AI company there, and like the XAI, Meta, Google, all these kind of company. And also, it also changed the AI development there. That's why they come to the base model, and then the AI giant provide a base model, and then a medium or AI startup focus on the pre-train, and then get to the real domain model there, and then provide it to the customer. So yeah, from here we could see these days, it just getting insane. Like one H100 GPU there, they sold it like $30,000 for one GPU node. But the real material, bill of the material is only like $100 or $200. There's like 10 times profit for this kind of hardware. But does it really need? We don't know. But it becomes like it gives us idea. Like when we talk about AI, it means expensive, and it also means like we need a bigger infrastructure, AI infrastructure there, and we need to spend tons of money there. And it also put the AI infrastructure to a very important place. Like, hey, we spend so much money there. How could you make sure we take full use of that? So to make sure this, we needed to kind of manage it well, and we needed to deploy all our stuff there quickly, and we also want to run the model efficiently, and then we could also provide to a production to get some profit revenue there quickly. So this is the I think this is the hope, but the reality is quite different. And even we spent like for the GPU there, it's so expensive. But expensive doesn't mean the quality. Actually, we saw when it comes to the AI infrastructure, we actually see more failures for this kind of a GPU server rather than the traditional CPU server there. So now we kind of know that we kind of want AI infrastructure. We want to add a specific infrastructure to do AI work. We need that, and it also already out there, like because like if they have a good infrastructure, if your model could fit the infrastructure well, your model could get better. And we saw that evolution tree here. Like it's already getting into this mode, the decoder only mode, because they could fit infrastructure well. So now we needed to go to see like what's the difference, what's the special for AI infrastructure, and how could we really make it worth it. So now so like I said, AI infrastructure is not comes from nowhere. We already know there's the HPC, the word, the traditional HPC word, and it's already been there for decades there, but they are using CPU. So now we actually, for this AI infrastructure, there's a big difference is that we have a tons of GPU inside. And we also need to focus on the cluster. So we needed to make sure the GPU could communicate with other GPUs. The GPUs inside the same node or the GPUs across the node would be more efficient. So in that way, we needed to make sure all the machine learning could training efficient, that all the data from the machine learning could communication with each node and each GPU more efficient. That's actually the strength of HPC before. We'll get there because a lot of this stuff is still from HPC, but just combined with, actually that's the difficult part, because most of the challenge is actually we try to combine HPC into cloud. For here is like we know the GPU add into the CPU, and if they want to communicate with each other in a cluster, they need some good network there. So there's actually two HPC network. There's two kinds of network there. One is called the InfiniBand. That's a totally different network infrastructure. The other one is actually Rocky. It's based on the Ethernet, and it's actually based on the UDP protocol. So you could still take the current network infrastructure and make it serve for your AI GPU. Of course, so like each node, they needed to connect to different switch. So this is the first thing we look to make sure how they could connect with each other. So we zoom in a little bit for this kind of AI infrastructure here. So this is one H100 server here. So if you see that, it's a giant monster. It has 8 GPU in a board there. And then that board connected to the server directly. So basically in this server, there's the normal traditional CPU, memory, storage, and then it with an extension board to connect 8 GPU. And from here, we see like because we are trying to optimize the infrastructure, so we definitely want to know the limitation of all this kind of stuff. So here is some kind of a memory bandwidth. Look for this one here. Now you can see why they want a GPU, why GPU is better for the AI. You see the speed here, like even for the bandwidth here, if we are using the traditional CPU, we are going to use the LPDDR5. This is the memory. And we are using the UPI. This is the CPU connected to CPU bus system. And there's also PCIe bus there, PCIe 5. But if you check the speed, it's only like 50, 40, 58 there. But if you check to the GPU, and even for the GPU connection, AV switch, NVLink. So yeah, a little bit extra information for here is that NVIDIA actually developed, we see there's eight GPUs there. This 8 GPU is actually connected with each other using a different bus system. They call it NVLink. But still you could see, like if they write the copy data inside the GPU, it's terabyte per second. Even if they connect the GPU to GPU, it's still 408 megabytes. If you see, this would be like almost 10 times. The GPU system is 10 times faster than the traditional CPU performance there. So that's why they want the AI infrastructure. And even for the GPU, we zoom in a little bit, just go into the GPU itself. When we see the traditional CPU side, we know that there's a cache system, register, cache, memory, and all the storage. We know there's a hierarchy there. For the GPU, it actually has similar here. It has the global memory there. We already see it's kind of 2 terabyte. For this one, it has 3 terabyte per second. And it also has a cache system, the L2, and stick memory is also kind of there's also register file there. So you can see the speed is also like, hey, we already know that the GPU memory is fast, but the static memory, the cache inside the GPU, is even faster than the memory. It's like 4 times, the cache is 5 times above than the memory, and then the register is still like 3 times than the register, the cache there. So all this information, it causes to the memory wall there. Like when we do, if we want to really take full use of the GPU there, if we really want to make the all investment, AI infrastructure investment, the $1 billion they're worth, somehow it comes to this detail to make sure everything runs on the fastest path there. And this is the GPU connection. Like we see the board there. They have the NVLink, a specific board there. However, the speed is faster than the PCIe 5, but it's still not as fast as the GPU memory. So it gives us the idea, like if we could make all the machine learning running in one GPU, that's best. But if we couldn't, we want to limit it to the GPU to GPU. And even if we couldn't make that, we try to extend it to some system memory there. But with that, we needed to kind of connect to, so like here. Like if you see the other side, we needed to go through the PCIe side. So PCIe would be still a bottleneck here. The PCIe is 58. But the memory, is better than the 40 gigabyte that for the CPU side. So in this way, we still want to stick to the fast path here. And that's when it comes to the NVLink side. We could see it goes to the NVLink side. If we see there's a different generation, it has a different speed there. So because we are focused on H100, there's NVLink 4 and NVLink Sharp there. For Sharp there, that's actually a difference between the the network. We are using, if you are using InfiniBand or if you are using the Rocky network side. And they also have some slight difference. Yes, goes a little bit slower is actually the PCIe bus there. So we still want to make sure it goes to the, so now it's actually, the speed is actually from 31 terabyte per second goes to the 3 terabyte per second, and it goes to like 500 gigabyte per second, goes to the 300 gigabyte per second there. But if that's still not enough, we still need to extend. So that goes to the PCIe. So it's like the speed here. So we want to go to the, now we needed to go to the PCIe. It's still 58. It's still better than the 40 and 51 there. So in that way, we kind of need some kind of system configuration. We want to use the RDMA, remote DMA. We want to use some zero-pace system path there. We want to get the best performance. So here is an example. Like if you have the wrong configuration, it could go to really bad. It goes to the 85. It's only like 40% of the performance there. So all this information we should be keep in mind. We want to do kind of optimization for the AI infrastructure, for the AI mode there. Yeah. So here we know that all these companies, they spend billions of dollars there, and they set up all the infrastructure. And we actually want to, during this infrastructure, they add a bunch of GPUs there, and a bunch of new network card there, the InfiniBand network card that. And we know that different devices, they have different hierarchy there. So to get the best performance, to get the best optimization, we kind of want to keep the rank there. So we want to, if possible, we want to run in one GPU. Even in the one GPU, we want them run into the register or cache there. And if not, we go to the GPU cross the NVLink. If not, we use the GPU cross node. And if not, we go to the GPU goes to the CPU and goes to the storage side. Actually, all this information already being used on the machine learning platform. That goes to the optimization part. So like I said, I've been working on this specific optimization for the machine learning platform. We actually choose a benchmark called MMPerf here. It's kind of the most popular benchmark today. It's kind of the industry standard. A bunch of the company outside, like NVIDIA, AMD, Intel, Google, Microsoft, Amazon, they all kind of submit results for this kind of benchmark. It's interesting, like there's inference side, there's an inference test, there's a training set there. So there's different model. We can see there's like a language processing model, there's image classification, object detection, recommendation, and even goes to the large language model, which is the most popular one from the ChatGPT. I think that's people start getting knowing it. But also there's some new one called the mixture of expert, like they put a multiple node in one model, so to try to see. So by looking at that, it kind of to see the trends, like how the machine learning get involved. This is 4.1, but before that, it's all about, like if you see the before that, it's actually all about the neural network, the CNN. But these days they started to add the new one, like the Llama, the mixture, and the GPT-2. They actually also kind of depreciated some RNN and ResNet, that model there. So you could see that these days people are liking the big model. They want to, and to support this big model, they need the AI infrastructure. And once the AI infrastructure, their hardware gets to the limitation, they needed to go back to kind of optimize the AI infrastructure. So And when we do, because this is from the hardware side, we actually use some metric here to measure like how should we do that, and how should we measure like what we did there really helps there. So the left side is the training for the training purpose. The right side is for the inference side. So for the training side, we actually measure the GPU utility. We see like during all the process how many GPU being used. And we also check the SM utility. This is from the CUDA layer. And there's also some tensor core utility. These three is mostly from a hardware perspective. But we actually see that it's not that efficient. It's not when we try to optimize our machine learning. And actually for like the model flops utilization is like during the whole training process, how efficient your model being used there, this is actually more helpful. And also there's hardware flops utilization. This is helpful, but this is a little bit tricky than the MFU there. And of course, there's time to train, like how many times we used to finish our model training there. Like I said, the current large language model, which need to spend like dozens of $1 million for one training there, they actually use like hundreds or thousands of GPU in the whole cluster. They need to train them like months, 3 months, 100 days there to finish the one training. So that makes it super expensive. And after that, it goes to the inference side. So inference side, the most straightforward case is our user case. Like when I open the ChatGPT, we type the code, we ask questions, and they send it to their server, their model, and then they give us the answers there. This is a typical inference process there. So at this time, we need to measure like, we definitely want it fast response, right? We don't want to like ask one question, we wait for half hours there just for waiting. That would be totally bad. That's actually the #1 metric we used when we measure our platform. And the other one is like time per output token. So it's like how big they could process. That's the like if you paste too much information to your ChatGPT, you actually could see the response that hey, I can't understand or I can't process that. You need to make it simpler. So this is the second metric. Others from hardware, we see the latency, the throughput, and the model, and also we needed to see like a model memory there, peak memory, how much memory they use in during the whole one inquiry there. So like I said, like we discussed that all this information, all this optimization, it's relatively easier when it's only on one mode. But the whole infrastructure, the whole HPC things there is actually about cluster. It's actually about how running for the multiple nodes there, like hundreds, thousands of nodes there running together as one. So to do that, normally people need to do some kind of a splitting and parallelism here we call it. So for example, if the data set is too big, we just split the data set to different nodes. If the model is too big, we can like split the different layer, this layer to this GPU server, that layer to that one. And also maybe to make it more efficient, make the node waiting, because once we split different node, sometimes it may cause the stall. Like one, if they have the dependent, one node might need to the other node. So in that case, we introduce the pipeline. So we make it working one by one, so make it more efficient. Also, that need a lot of, like how to split them, how to make them efficient, that becomes a challenge. Luckily, there's some research already there for automatic parallelism there to do, like the mass TensorFlow, FlexFlow, OneFlow kind of thing. So this is all make it difficult. And we, like I said, we mostly focus on the platform side. So Actually, luckily, there's already kind of a platform already doing this kind of work. So a very famous one is the Megatron LM. This is provided by NVIDIA. And it could already do all this kind of information for you. You have your data set ready. You have your model there. You can deploy it. You can set up a Megatron LM. And they could do all this kind of parallelism splitting for you. And also there's a deep speed there. It's from the Microsoft. And they actually also do some data parallelism for there. And Megatron Core, they kind of combine both Megatron LM and the deep speed there. And also, there's AI startup there today also doing this kind of stuff. The Hugging Face, which is quite a familiar one, a famous one. They have their accelerator could do it for you if you have done any kind of training process. Closer AI is also quite a famous one. So all I test is that, for example, when we do that, our test, we usually start up a cluster there, which have like 10, 12 nodes there. Yeah, because it's very expensive, we can't get a very big one. So we only focus like 12 nodes there, which has like 100 GPU servers there to do all this stuff. And we just set up a platform here, Megatron. We use Megatron LM, like Megatron LM or deep speed there. And then we just running that. While running that, we actually focused on, we're actually using all kind of observability, like the Prometheus, Grafana, and we track how the metric, we actually track the metric there to see how they really function, how they really working there. And if we see issues there, we fix them. And for inference side, there's also kind of a platform also side. The first one is the 1030 LLM. It's also provided by NVIDIA. They also do all kinds of the optimization. But yeah, it's difficult to deploy and not good for the distributed situation. Like we can't do a very big model size there. So and the GPU utilization is low. When we deal with a small batch size sequence, it's like if we ask small questions there, we can see the GPU utilization is quite small. The other one is the VLM, and it has done a lot of optimization for this one. We also noticed that there's a deep speed. They also provide a very good framework for the inference. This is a little bit new for us. We're still working on that. So yes, so like I said, when we track, when we're doing this all kind of optimization, we actually track how the things, we track different metrics there to see how it works. So during our Megatron, during our test, when we're using the stable diffusion, we actually see that different batch size cause really different GPU utility there. That gives an idea that GPU utility is actually not a quite good metric there when we do optimization. Because there's some trick there. Like if you enable ASIC and GPU CUDA graph from the CUDA layer, you could see the GPU utility always 100%. But that's totally meaningless at that point. So we decide, after that, we decide to move to check the MFU, the model function utility there. So, and like I said, we test on, we have this different model here, the Llama 2. We also had the GPT-2. We also ran the Mistral 7x8B. This is the latest model, mixture of expert there. And also there's a new one from the MLPerf. It's actually the graphic neural network. That's really new. So we're using the Megatron LM. We could see we could get like 50% for the Llama 2. We could get 45 for GPT-2. Actually, for Mistral, we actually get the better performance from a different platform. Like we actually from the Closer AI there. It gives us like 54% of the MFU. by the way, it's actually like if you could maintain your MFU utility at like 0.5% there, it's already very good. So that could give you an idea how important when we do the AI infrastructure optimization. Even for this, there's so much work to do there. And for the inference side, we actually also tried a different optimization there. For example, we actually, to optimize the input, the prompt, I think ChatGPT, they call it prompt. And if we could compression the prompt that, so we can actually ask more prompt in one query there. So that could make it faster. And also there's the RAG called the retrieve argument. Retrieve argument, what does the G mean? So that's basically like they will build the vector database for all the prompts that, like before you really do the query there, you actually go through a vector database there. They will translate your query prompt to a better one, which would fit to the model better. So they could give you a better results there. And also there's a model optimization. We could do, like said, if we could put everything in one GPU, if we could put all the stuff in the fast place, like the register and the cache and the GPU memory. So to do that, we actually do like a quantization. We try to compress the model. We even using some specification to use some mathematical method to make the model more smaller. And also we do some like the knowledge distillation there and to do some droplet. Also from the architecture layer, from the model side, we tried a different attention method to try to, all the way we are doing here is like I said, we're trying to put everything to the fast memory side to make it movement fast to compute it faster. And yeah, during all these kind of steps, I would say it's, even we said that even this AI infrastructure, we spend millions, tons of money there, $1 billion there. It's actually more difficult, more painful than you think by comparing with many traditional data center there. And and we actually, during all this process, we see like now these days, like all the difficult part is to process the multi-node, multi-GPU keys. And quite interesting, a few years ago, I did a topic on the NVIDIA GTC. At that moment, they are still talking about the GPU virtualization. How do they put everything in one GPU? But now, even not to mention one GPU, if you even have the hundreds or thousands of GPUs, it's not big enough. But in that case, like if in a very smaller case, we actually see virtualization or GPU share is not that bad than bare metal. And then we see the model. Different model has different, so all this machine learning, they quite depend on the model, and the model, they have a very obvious pattern there. So which makes them, some model, the way you're dealing with one model may not be fit for the other model. And the RNN model there, it's really bad. We see it's quite sensitive with all your hardware, the disk I/O hardware there, which means like when we copy the data set from the CPU side, go to the GPU side, it's really slow. We can see the bottleneck there, very obvious. And then the GPU memory size, like I said there, is quite sensitive to the batch size. GPU size, it's much smaller. It's like the H100, it has like 80 gigabytes per second, but comparing the system memory, which has a terabyte already. And so we need to think about how to fit our model in like 80 gigabyte. Even for 8 GPU there, it's still 600 gigabyte memory there. So, and it's easily out of memory. So at that moment, you needed to change your batch size there. And we also tried like a mixed precision training. This is like if we a data set, if the data format is 32 float, but if we could change it to 16, we could definitely make the size like 100% smaller. We kind of double size we like half size the data set. In other way, we kind of double size the memory size. However, it's not always true. It only help for some kind of the memory size there. Also, the 5 there, when we do the parallelism there, like even we, yeah, this is very compared to the 3. Like even we do all kinds of the parallelism there, the split cross to the multi-node, we still don't have enough GPU. So at that moment, we need to add more nodes there, add more nodes there to make it work through. Or like we need to smaller the batch size, which will increase the training time. Like if we make the batch size smaller, like 50% smaller, we need the training time, we need to double the training time size there. That's unacceptable. That's because it's so expensive there. And also, we discussed all this kind of AI infrastructure, the hardware topo, all this kind of hierarchy there. So if we send the wrong information to the platform, it will cause the performance drop significantly. We could see like it even crossed the system. For example, when we set up, like when we're doing the GPU connect to GPU, it uses the NVLink there. So it actually needed to know all the hardware information. If we feed it a wrong information, we could see the performance immediately drop to 50%. And sometimes it even just cross the whole system. So in that moment, it gives the idea like it comes to give us the none. Like if we get a cluster there before running anything, we just run the communication test first. We run the MPI actually, Open MPI. This is from the HPC world, and then we run the NICO test. It's from NVLink. We make sure no matter how GPU or CPU good, we need to make sure the side, the network side, has already in the best state there, and this is really helpful. Yeah, the other side, we needed to monitor every time, like because it happened, it's so fragile there during all the time. We needed to do all the checkpoints. Like we needed to, every couple hours, we needed to save all the information to the disk in case it's broken, and it's easily broken. After that, we needed to restore from the last checkpoint and get back to it. So at that moment, we needed to monitor all this information. The metric, that's the metric we used before. We needed to make sure, yeah. We needed to see there's no big, if it's all one line there, that's good. But if we see there's some wave there, that's bad. That means something wrong. And sometimes we needed to stop the training manually. And we fix the issue and then get back to the training in case we waste more time there. So yeah, that's quite interesting. Like I said, even if we do one training, like the report, if they see the report from the Meta, Facebook about their training to Llama there, even the training, they spend like tens of millions of dollars there for the one training. They used 100 days there, over 100 days there for the training. Actually, the effective training time is only 20 or 30 days there. So if you see the efficiency, it's super slow. This is another kind of point goes to the AI infrastructure. We need to make sure they are very reliable. So yeah. And the other side, like the PCIe bandwidth, because when we run the heavy working load, we actually see the PCIe easily downgrade. So we know we so far it's PCIe 5, it's 126, 128, and there's 64 for the PCIe 4. Sometimes it will just drop to the lower bandwidth there. That's also very bad. So, Anyway, yeah. So I think it would only become more and more important for the whole AI infrastructure stuff. And people would more care about the scaling law, which is introduced by OpenAI from the 2020. And I think like people would be more careful about their training process to make sure to make them predictable, make it more efficient. And also heterogeneous memory, like because the GPU memory is really not enough. So we needed to include more kind of memory device there. In that way, we needed to think about all the architecture information we don't think before. Like NVLink C2C, it actually mitigated the memory between CPU system memory to the GPU memory. They improved the performance by like 5 times there. And also the CXL, which is also popular, they also try to make make it all like they are trying to build a system memory more pool there for all the training process. Unfortunately, CXL is too slow. They're mostly using for the inference side. NVLink C2C is actually for the training. And the last part, people are thinking to build one big computer now. I think it's kind of get back. Few years ago, Hewlett Packard, while I was working at Hewlett Packard, they come to the idea called the machine. So it's like they're using one giant centric machine to do all the stuff there. But there's really no customer care about it. There's no such workload there. However, things changed these days. There's the super pod, super rack, and supercomputer, depending on what you call it. NVIDIA comes to this all kind of super pod stuff. They try to put multiple nodes, like 256 GPUs in one node there. The current, the GB200, the Grace Hopper Blackwell 200 there, they all towards this way. Like if you could put everything in one computer, in one GPU, then you don't have too much thing to think about to optimize there. You don't need to think about the distributed machine learning there, or the distributed system there. So yeah, everyone's happy. But I think there will be a long way to do that. So yeah, I think that's all from my side. A bunch of stuff here. Hope you enjoyed. Hope you find anything interesting. Let me know if you have any questions, or feel free to reach me offline. Thank you.
Are there any questions? Okay, thank you.
this because of certain issues with raffles and things like that. So this first slide is just to tell you that the title of my talk is MOSFA, Make Open Source Fun Again. And thanks for all the penguins. But before we actually get started on that, I'm going to talk a little bit about the raffle. I have contributed a couple things to the raffle, which I think are up here at this point. One is a copy of the infamous fake license plates that Digital used to give out. This one says, Linux, live free or die, and that Linux is a trademark of Linus Torvalds, which it is. But the second license plate up here is a real New Hampshire license plate that used to come off my Jeep Wrangler. It was on there for 10 years. And it was the Unix license plate that started the whole realm of license plates that Digital gave out to customers over the years. So you have a unique item there if you get that. And it's slightly, sorry if it's slightly beaten up, but it was on the front of my Jeep for 10 years. The third thing I have is a pair of flashing BSD horns. And you can see it being worn there by Sebastian. That is being taken in the Munich Hall in Hanover, Germany at the CeBIT show, which for many years was the world's largest computer show. And for some reason, I never figured out they were selling BSD flashing horns there. So every year when I went there, I would buy a set of BSD flashing horns for everybody in the LPI booth. And Sebastian was very drunk and showing it off. So these are things I have that I contributed for the auction. And before I start, I'm going to allow Benjamin Kirkbride to come up and talk about his project, votecountcollective.com. And he's got about 5 minutes to talk about that. So I think we're ahead of time. That should work out great. Then after that, we can start the camera. Go ahead.
Test. First of all, thank you, Mad Dog, for graciously offering me some of your time. I won't bore you. I would be disappointed if I was sitting there watching me talk instead of watching Mad Dog talk, so I'll try to get out of here as fast as I can. My name is Benjamin Kirkbride. I'm an engineering manager at a mid-sized telecommunications company, but I am not here in that capacity. I am here to talk about an initiative that I started about 72 hours ago called the Vote Count Collective. It is a initiative that seeks to gather precinct-level vote tallies for U.S. federal elections into a standard format that is openly accessible to everyone to do with as they please, run analytics or whatever. But the purpose of the organization itself, the initiative, is to gather that data. Now, you might be wondering, what does that even mean? Can't you already get that data? And the answer is basically kind of yes, but mostly no. The problem, depending on how you want to look at it, is that all elections in the US are run locally at the county level, and most states, or many states, I'm not sure if it's most, but many states do not aggregate that data at all. And there's no federal aggregation of that data either. And so if you want to know how Chicopee County, Michigan voted, you have to go to the Secretary of State of Michigan website, look up all the individual websites for the Board of Elections, find the Chicopee County one, which there are dozens, or in some cases hundreds of counties per state, navigate to their website. It was probably last updated in the 80s. Find the PDF that was scanned and transcribe it, or the XLSS 2003 Excel file, or it's just a nightmare. And so it's difficult to analyze the data in a holistic fashion. And so this is a call for people who want to get involved. If you have experience with database administration, data engineering, political science, analytics, statistics, right? Any of that. Or if you would like to have experience with those things, if you would like to learn about how to do scraping and ETL and BI, that also would be a great opportunity for that. We use open source tooling, of course. How could we not? And so, things like SQLite and Postgres and Linux and, all of it. We have cards on the tables out there. Vote Count Collective, you can go online. There's a form to fill out if you want to get involved. That's it. Thank you, everyone.
Thank you. Okay, Bethlyn, do you want to say something?
Thank you so much. And thank you to Mad Dog for being here. If it wasn't for Mad Dog coming and being involved in our second annual event, we would not be here 21 years later. Mad Dog believed in me and believed in us and believed in the spirit of free software and free software community to gather once a year in Columbus, Ohio to celebrate our community. And the way that he taught us how to do that is to not be afraid to ask for money. Several years later, we have achieved the 501c3 status to become a 501c3 corporation. What does that mean? Nonprofit in the eyes of the Internal Revenue Service and a registered charity in the eyes of the Secretary of State of Ohio. Therefore, we are allowed to conduct a raffle at the conclusion of our event. This really helps us a big deal to be able to continue to do what we are doing right now, which is not only getting together in person, but being able to spread the good news of free software to everywhere in the world. Thank you for being involved. I don't know if you got a chance to be involved in the raffle at all, and it was due to Mad Dog's idea to go ahead and have a good raffle prize to be able to also pass the hat. In 2021, we took this raffle virtual as well so that people who participate on our conference online can also experience this part of being a part of our community too. We have many fabulous prizes that Mad Dog has already presented to us with the license plate. If you live in the state of Ohio, you may want to consider signing a petition to get a very own Ohio Linux driver's license plate for your vehicle that would just not only be able to spread the word that Linux is a thing, but to spread the word that yes, Ohio Linux is a thing. And as the president of the Ohio Linux Fest Corporation, that is some sort of dream come true if we can accomplish that. I do acknowledge that there's only about 30 minutes or less to contribute to this raffle. And most of it is Amber Grainer's fault for helping us get a lot of these prizes together, and she's down some friends of hers through the Kubeflow community. So if it weren't for her, this raffle wouldn't be possible. Thank you, Amber. So it's all her fault that we have a 3D printer to give away tonight. We've got a digital microscope to give away tonight. We've got a pie, and a pie to give away. We've got a video game palm top gaming system where you can write free software games for it. And if you don't want to write free software, don't worry. They have a community of free games for developers who already shipped this thing with free software. It's pretty rare to have in the United States. We've got a hacking kit for all sorts of tools for if you're going to go out into the woods, perhaps, to go hack. We got you covered because there's a solar panel and a compass. What are you waiting for? And of course, it wouldn't be an annual raffle without my special prize from the Pittsburgh Aviary, and I'm sorry, the National Aviary now. We have Tribby, who walked upon this canvas, who is an African flat-footed penguin that lives happily there at the National Aviary to go ahead and sweeten the deal. We've got a coffee mug, because who in this room does not enjoy a hot beverage from time to time? And in the overall enjoyment that you're not only helping one great cause of Ohio Linux Fest, but you're helping another great cause of the preservation and research of animals like penguins and other birds. So thank you. We also have another annual treat that I put together, which is basically a swag grab bag with all sorts of mystery prizes in between. What the basic prize is a travel mug from our high crime investigation association that couldn't be here to the conclusion tonight, but at least they had chipped in the prize in quantity of 4, so the odds are pretty high that you could win a mug. And also other mystery prizes from the expo. Now, Mad Dog, do you know why I'm giving you a pirate flag?
Well, it's maybe to try and stop software piracy by allowing people to use free software.
Indeed. There has been many a lug that I've gone to with InstallFest where we opened up the network and people thought that was an opportunity to exploit the bandwidth and use pirated software or attain a pirated software. But why would somebody want to do that? It's so boring to use non-free software, and I wouldn't be up here if I didn't believe that it wasn't the best software ever. But no, that's not it.
Okay. Then I am hopeless.
Okay. Well, you know that I gave Miss Amber Grainer a pirate flag, and you get the same kind of pirate flag. You don't have to share the pirate flag with her.
Okay.
But I thought that you might be envious of her pirate flag.
I was.
And it's because that you've been such a great mentor to me and has always stood up here and talked to us about the fun of computing, the fun of free software, to continue to believe in me and to continue to drive me and all the rest out there and all the rest out in the internet and all your friends in Brazil to seize the day.
Seize the day.
Seize the day. Carpe diem.
Carpe diem.
Mad Dog, make open source fun again.
Thank you. Thank you, Bethlehem. So I'm going to make this relatively quick. I'm going to go relatively fast, so hold on to your shoes. For those of you who don't know me, I started programming in 1969. I programmed on a wide variety of different systems, both closed source and open source. In 1986, I met Richard Stallman, started to do work with the Free Software Foundation. If you get me drunk enough at night, I'll tell you lots of stories about that. In May of 1994, I was working for Digital Equipment Corporation, met Linus Torvalds, saw Linux for the first time, and said, I think this is a great operating system to do research on large-scale addressing systems. And I've been doing free software ever since. Most recently, I stepped down after 9 years of being the board chair of the Linux Professional Institute. I'm now board chair emeritus, they call me. And I've been asked to be an ambassador for trans tech workers because trans people have a hard time, a lot of times, getting jobs. And as the little cartoon in the lower right-hand corner says, when you're on the internet, nobody knows you're a dog. So I've been both a vendor and a customer. I've been waiting for that patch to come. I've been the person trying to produce that patch for the customer. And so I like to think that the most important thing I have is I am pragmatic. My job is to get the job done. That's what I do. So I'm going to take you back in time to the beginning of when I started programming in 1969. Software was written for your developer's own needs. If you were a physicist, you did software. If you were a chemist, you did software. Electrical engineering, you did software. You did not write software for other people. In fact, I had a professor at my university when I was taking a data processing course, said to me, John, you will never be able to earn a living as a professional programmer. I'm still waiting to see if he was right. But you have to ask yourself, what is a professional programmer? People say that Linux isn't professional. It's written by amateurs. Well, you know, what is an amateur? You can have an amateur baseball player, and they can be very good, an amateur soccer player, football player, as they call them in Brazil. And they can be very, very good. It's just that they're not paid to do it, right? It's not how they earn their living. But it doesn't mean that they can't be good. For God's sakes, take a look at some of our professional baseball players and look at them and call them an athlete. I'm sorry. But back in those days, selling software was hard because you didn't have one system like a Intel computer system with millions of computers. Most computers were different. They only had 5 or 10 or 100 or 1,000 of them produced. And so oftentimes you gave away your software because you were not in the business of selling software. You were in the business of whatever you were, a physicist or a chemist. And often when you gave away your software, other people in your field would say, gee, thank you for giving me that. Oh, by the way, I have some things that I'd like to program into it. I'm willing to help you do that programming. And magically, you doubled your programming staff. You met one more, you tripled your programming staff. And you go to these conferences like DECUS or USTIX or something like that, and people say, you're the one who wrote that software to really help me. Let me buy you a beer. Or let me take you to dinner. Or let me give you a job. And all of these reasons are why we write free software today. So then we get to the early 1970s. And that's where commercial, binary-only software started to really rear its ugly head. The Intel architecture prevailed. Operating systems like CP/M came out on floppy disks, 8-inch floppy disks. And MS-DOS managed to rear its ugly head. But before that time, software was protected. The intellectual property, and Richard hates that term, intellectual property was protected by trade secrets or contract law. I remember paying $100,000 for a COBOL compiler that was optimized back in 1975. $100,000. And we negotiated for months on the contract about how many computers we could put it on, how many people could use it at one time, and where the source code would be put, because if that company went out of business, we wanted to be able to get our $100,000 worth. And so the software was put into escrow from a set of lawyers in a safe. That's where it was put. But then around the 1980s, mid-1980s, software patents and copyright was applied to software. One of the first groups or companies or industries that got it was games, because you would produce a game, there'd be a board, you'd have your resistors, your capacitors, and things like that on it. Easy for your competitor to duplicate, but there was this one thing called a ROM that held the ones and zeros that was actually the game itself. And so companies came along and said, we need copyright protection on that ROM, the ones and zeros in that ROM, so that we can make money after we've produced this game. So Congress took a long time on that. They finally said, okay, we'll give you copyright on the ROM. And then people said, well, we want the copyright on the source code for the ROM. And so the United States government said, okay, when you write software, you get an automatic copyright. And so all of a sudden, out at the University of California, Berkeley, that was used to giving away their software and tapes, they said, uh-oh, it's now copyrighted. Now we need to have a license so that people know that they can use this software for any purpose, but don't blame us if it burns up your system or it burns up your house, okay? And so licenses like the BSD license and the MIT license came along, and the end user license, and people started to go forward. However, of course, at MIT was this particular person by the name of Richard Stallman, who created a project called GNU, for GNU is not Unix. And later on, he developed a society, the Free Software Foundation, to go ahead and bring this idea forward. And I will take you back again for a moment to those days. Because when you were a programmer, when you were a developer, and you were developing a program that was going to run on VMS and MVS and MFT and all these operating systems from different companies, they all had different text editors. And if you're moving from place to place and trying to create your program and port your program, you had to learn the different text editors. And Richard said, no, we'll take Emacs and we'll put it across all these different systems. And you can use the same commands and the same finger pushes and stuff like that to do your editing on all these systems. And all the programmers then went, of course. It wasn't making an operating system portable, it was making programmers portable. And then after that, they said, hey, we're going to have the GNU compiler suite. It wasn't anywhere near as optimized as the VMS compiler suite. You know, you compile your code, it would run 30% slower using GNU. But people didn't care. Because the thing is, you could have the same syntax and semantics across all these different hardware systems, which cut down on the if-defs in your code, made it easier to test. And after all, if you needed to run faster, you just buy a bigger CPU. And so people began to understand this concept of portable code and portable systems and coding across all these different hardware architectures. And it was open, it was free. You could look at the code, you could see how it did. So again, we weren't creating portable code, we were creating portable coders. And then people said, well, you know, we can make money by selling service on this. And a small group of programmers out in Silicon Valley, in Palo Alto, formed a company called Cygnus. And they sold support for the GNU compiler suite. And one of the first companies to buy that support was called Boeing. That's before their doors started falling off. Then in the early 1990s, by the time that a lot of software was in the GNU project and everything, the one part that was missing was the kernel. And so this young man from Helsinki, Finland said, I'm going to start a kernel project just for fun. Not because I expected to sell it. It's not going to be big and important like Minix. Sorry. But it's just a fun project, and people started joining in with them, right? And then around the years of 1993 and 1994, the kernel project had good enough that people started putting it into distributions, like Soft Landing Systems and Yggdrasil and Slackware and Debian and others. And magazines started coming out, the Linux Journal, talking about this wonderful operating system that some people called just Linux, but it was really GNU Linux. And there were local GNU Linux users groups and small expos starting up and things like that. But still, it was looked at as being a nerd operating system. You know, something that wasn't serious, not for serious work. And that's where Linux International came in, a small group of people who said, we think that this is an operating system that has business implications, commercial implications. It means that it's going to make things better and cheaper for everyone. And so we started the Linux Mark Institute because there was this person in Boston by the name of Delacroce who trademarked the term Linux and was holding that term as ransom. So we hired some lawyers, and to make a long story short, we wrested it away from him and created the Linux Mark Institute to be able to allow anybody to use the term Linux for any legitimate purpose. We also started the Linux Standard Base project to allow people to be able to more easily port their applications across distributions. So if you developed an application on one distribution, you should be able to run it on the other distributions if they followed the standard. And then we started, got Linux certification, because we realized that people who are business people who could barely even say the word Linux needed to be able to have people to be systems administrators for them and to maintain their Linux systems. And there were actually two certification efforts that started up that were multi-distribution. One was called SARE. It was developed out of the University of Missouri. That was one that they did both the training and the certification. And another one which I really helped along, LPI, out of Toronto, Canada, that we concentrated on certification so that you could learn the information any way you wanted to, a lot cheaper. And maybe you already knew the information and all you really needed to do was have the certification. And so 25 years to the day, we have LPI starting, and I'm proud to have helped them spread this to 180 different countries around the world with over 300,000 certified professionals. Thank you. About the same time, Open Source Development Lab started up. This was an effort to give hardware to the developers because, after all, if you're programming out of your apartment, it's hard to have an IBM 360 mainframe sitting there soaking up your electricity. So the Open Source Development Labs made all of this hardware available to Linux developers so that they could port it to different systems. But this required a lot of money that came from large corporations, and these large corporations wanted to have a place on the board of directors of OSDL. And they brought in more so-called professional programmers, people who weren't necessarily enamored with free software, but this was a job for them. And over time, there were fewer community members that were actually donating or contributing to OSDL. And there was more stress on what the people called permissive licenses. Permissive licenses were like MIT, BSD, things that did not force the creators of the binaries to make sure that the end users had access to the source code. On the other hand, the so-called restrictive licenses were ones from the GPL, which did force the developers to make sure that all of the source code was available to the end users. Eventually, OSDL kind of went bankrupt and morphed into the Linux Foundation. And initially, the Linux Foundation had one board seat that was reserved for community members, but over time, that board seat disappeared. And so now it's all commercial systems or commercial companies that are on the board of directors. And so the question I've got is it still fun? I remember when I wrote my first program, I wrote it several times to get it to work, but when it finally worked, nobody had to tell me I did a good job. It worked. I could see it. Nobody had to pat me on the back. And that's the way it's been all the time, all my life with writing software. You write it, there may be a bug in there someplace, but it's pretty good, okay? And there's been a huge influx of what we call newbies into the free software situation. But a lot of them are just users. Oh, I'm just a user, okay? Oh, I'm just a documentation person. Well, I just do testing. No, you're a user. You're a documentation person. Please do not ever apply the word just to a human being. It's disgusting. You are a human being. You are a developer. You are a documentation person. You are a user. They do ask rather simple questions and time again of how do I do this? And if they just worked a little bit down the comment page, they would see probably an answer to that. And it gets frustrating for some of the older people, and some of us old farts lose patience from time to time. But we shouldn't, because we've always been there. The number of lugs decreased. That's a shame. Local user group where people can get together and talk and exchange ideas and drink beers and stuff like that. The number of conferences decreased. We need to protect them. We need to be coming back to conferences like OLF to share ideas and to bring new people in and make them feel welcome. And so I'm going to talk for the rest of the talk with some ideas about how to do this. And the very first thing is we need to have more penguins. Absolutely more penguins. We need to have penguins all over the place. You need to have penguins at your desk. You need to have penguins in your house. You need to have shirts with penguins on it and stuff like that. Penguins are great. Tux was a fantastic mascot. Before Tux, we had ideas of using sharks and eagles and tigers and things and bears with claws and teeth to rip Microsoft apart. And Lena said, no, I think we should have a penguin. It should be a fat, friendly-looking penguin. It looks like he's just had a nice fish dinner. And people went out and started drawing lots of penguins, and Larry Ewing of Texas A&M University said, I have this one named Tux. Well, it actually didn't have Tux at the time. I have this penguin, and you can use it for any purpose whatsoever, as long as if you're asked about it, you say, Larry Ewing did it, and I used GIMP. But the catch there is you have to be asked. And if you're not asked, you don't have to say anything. So Tux has been found on air conditioning units. It's been found on the Australian lottery. It's been found on lots of other things, which is perfectly legal because nobody asks, where did it come from? So here's some other ideas for fun stuff. How many people know about Software Freedom Day? Good. More of you should. Okay, Software Freedom Day was started by a friend of mine named Matt Quist. We were in front of a Walmart store with a table and balloons and Ubuntu discs to give away and flyers telling people about free software or what it meant. And we just, that was it. That was the original Software Freedom Day. And then over time, more and more people in more and more cities around the world started celebrating Software Freedom Day. It's always held on the third Saturday of the year, and this year is September the 20th of 2025. If you go to that URL, you can register. You can have your own Software Freedom Day. You can tell other people what it's about. You can help them get Linux installed on their system. You can be outgoing and inviting, and believe me, this is fun. It is fun to do this. It is fun to bring these people in. Here's another idea. LPI is pushing something called Linux clubs. It's very difficult to get Linux into the curriculum of your high school because they've set this up, they've been certified, they're using Windows, da-da-da-da-da. But you can have something after school or on the weekend. And all you need is a place to do it and a mentor. A person to raise their hand to say, yeah, I'll work with the kids. I'll work with the people that want to have this Linux club. And you only, maybe once a month is all you have to do it. One short, couple hour session. And it's a lot of fun. And the Linux clubs, we have ideas for refurbishing laptops. People go out, get laptops donated from businesses that they're upgrading. And there's going to be a lot of them upgraded this year. And you can put Linux on it and give them to people who otherwise wouldn't have a computer system. I took one. It was really slow running Windows. I took out the hard drives and put in some solid state drives, put in a little bit more memory, and it just came alive. It was, better than it originally was with Windows as far as responsiveness. Along those same lines, at the LPI site, we have a program called Upgrade to Linux. Instead of upgrading to Windows 11, you upgrade to Linux. And it's probably the last time you'll have to go through an upgrade like that, because you'll just keep going and going and going and going. No license fees to pay, tailoring it to work the way you want it to. And these are all great newbie things. Be a mentor to somebody. You don't have to try and save the world. People say to me, Mad Dog, you've done so much, you've done so much. I'm only a person who happened to be in a certain place at a certain time, and I did the right thing. And all the people I've helped, I was at CBIT, I mentioned that before. I had somebody come up to me and say, Mad Dog, I listened to you 5 years ago, and now I'm the head of my IT group at work. Another person came along at the same show. Mad Dog, I listened to you 10 years ago, and I'm the chief technical officer of my company. Another person came along and said, Mad Dog, I listened to you 20 years ago, and now I own my own company and I employ 60 people. This is what keeps me going. And you can have exactly that same feeling. And all you have to do is take that little step forward to mentor somebody. Meet with them a week, one day a week or one day a month. Get them going. Better yet, do 2 people, because then those people will work off of each other. And then you invite them to OLF next year. How many of you ever heard the story of the Chinese checkerboard? And it was invented, and the Chinese emperor liked it so much, he said to the inventor, what do you want as your prize for doing this? I want a grain of rice in the first square, 2 grains of rice in the second, 4 grains of rice in the third, and so forth and so on. And the emperor said, let your wish happen. By the time he got to the 64th square, there wasn't enough rice in all of China to do it. So, if you bought 2 Windows users here next year, and they bought 2 more Windows users the next year, by the time we've done this, another 10 years, you'll have this whole room, this whole hotel filled with Linux users. And finally, the best way to learn something is to teach other people. I had compiler theory in undergraduate, almost flunked it. Had it again in my master's degree, almost flunked it. And then I had to teach it to people who had never used a computer before. And that was the time that I learned it really well. I taught compiler theory 4 times at the university level. I haven't done it for the last 20 years, but I could go to a blackboard now and I could do it right off the bat without even thinking. Because when you're learning it as a student, you say, oh, the professor will never ask me that. I can just bleep over that chapter. But you can't do that when you're teaching it. You can't bleep, okay? And so that's the way you really learn it. And so now, I'm going to give a little word from LPI that we have a brand new certificate, Open Source Essentials. This isn't for programmers, it's not for systems administrators, it's for managers. And how many of you, as developers or systems administrators, have run into frustration because your managers don't really understand about open source, don't understand about licensing, don't understand about how you engage people to do this? Have them take a look at this. They don't have to take the test, they don't have to buy the test. They can just look at the objectives, and when they say to themselves, I don't know what that person's talking about, what that objective's about, that's what they need to study. There's the URL. And now, a word from our real sponsor, Bernie Sanders. I'm a Bernie boy, I admit it. Bernie Sanders through and through. And one of the things that Bernie Sanders said is, free college for all. Unfortunately, he always left off the last part, for qualified students. Because once upon a time, there was free college in the United States. State colleges were free for people who lived in the state. If you came from out of state, you paid a fee. If you came from out of the country, you paid a fee. But if you were in state, the taxes that you paid, your parents paid for your college education. In Latin America and much of Europe, it is still true. There's tuition-free colleges. But for qualified students, you have to have done well in high school, you have to have passed the entrance exams, and it's limited, but a number of open places. So it's not an unlimited sink of money. But the thing is, even with that free tuition, 40% of the people who qualify can't take advantage of it because their parents are too poor to pay for the apartment, the food, the computers, the internet, the books, and everything else. And so they have to turn it down. And what is happening now is that you're not getting the smartest students, you're getting the richest. And there's something wrong with that. So here's the solution. We've been talking a lot about free software and open hardware, but you want to know? Nobody buys hardware and nobody buys software, ever. What they do is they buy a solution to a problem. And even if your problem is playing a game, that's the problem you're trying to solve. That's what you're buying the hardware and software for. That's what you're doing. That's what you're doing. And so if you take a look at SourceForge and GitLab and GitHub, you'll find out that there's hundreds of thousands of pieces of software that you could put together on top of relatively open hardware, whether it be a Raspberry Pi or be, all these other little single board computers. Even NVIDIA is opening up their software, okay? Linux bootloaders are taking the place of proprietary bootloaders. Data from Creative Commons, movies, music, things like that is available to you to create products out of. And there are open business plans that you can study to create your own business. So small to medium business, many people don't realize this, produces typically about 50% of any economy. Doesn't make any difference whether it's the United States or Great Britain or Russia. It's small to medium business that does that. And by measuring patents, it's 90% of the intellectual property creation. It's small business that does the creation of the intellectual property. Large corporations tend to buy it, or buy the company, or buy the IP. Therefore, it's not trickle down that brings wealth to a country. It's bottom up. That's what happens. And a rising tide floats all boats. And what we should be looking for are tax breaks for small companies. We should be looking for child care so people can start up these small companies. We should be looking for down payment for homes so people have a place to stay. That's what we should be looking for. And so with that, about 12 years ago, I started on a project to create products that students could sell and make money for support to pay enough money to go to college. And I started with a piece of software called Odoo. Now you go into McDonald's and you'll see a point of sale and ERP system. It prints out your receipt. It opens a cash drawer. You have the LCD screen. You type all the stuff you want on it. That is a point of sale. And the back end that takes care of inventory and everything else is the ERP system. You could buy these from Oracle. You could buy these from Hewlett-Packard. And they're typically $30,000 to start. And then every little change you make is another payment you have to make to these companies that goes to their stockholders and disappears. But you could also use Odoo, which has been compared to SAP and Oracle, and quite favorably, and it's open source. and you can pull it down off the net and install it on a Raspberry Pi or some other little single board computer or your laptop, and you can learn how to run an ERP system. And then you can sell it to people who have a small market, who have a bar, restaurant, things like that. It's very comprehensive. And so I've gotten together with some people to actually put one of these systems together. You know, here it is, 64-bit system, whether it be running Debian, because all the software is included in the Debian release. Debian 11, Debian 12, the Odoo software is right there. And you get a barcode scanner, a printer, an Epson printer, all these things, put it together, you've got a point of sale and ERP system for $500, not $30,000. And then the person can help the customer set this up, fill it in, start using it. And there are companies which will sell second or third level support to the student in case they need it. But typically the students don't need it because there's a vibrant third community system that helps them through some of the harder issues. In Argentina, you come in and out of the airport and all you see is this billboard that says Odoo on it, nothing else, just Odoo. And there's 4 or 5 companies in Argentina, there's 9 companies in Brazil that supply second and third level support. But the student is the frontline support for this. This is the company's wet dream. A unsalaried, commission-only sales force and support. It's also a person-to-person thing. The student is acting personally with the customer. So no longer, if you're a second or third level support person, you get a telephone call from a customer that says, it broke. You know, eventually you have to hop in the car, drive 4 hours to the customer's site. No. Here, the student is there. They're the front line of support. And when you talk to the student, they tell you what's wrong with it, and you help them fix it. So that's one product. And in January, we're going to be launching this in full scale. I'm going to have mentors set up for the students. I'm going to contact universities. I'm contacting universities right now to see if they would like to participate in this program. There's another product, freedombox.org. This is started by Eben Moglin, a professor and law professor at Columbia University in New York. 15 years ago, he started to get nervous about people putting their credit card numbers and stuff in the cloud. He said, I think it would be better if they could store it in a small, secure server that you plug into the wall in your house. And it's one thing if we people in the United States put our information up in AWS or Google Cloud or anything like that, because we have this piece of paper called the Constitution, which protects us from people taking that and spying on us. But if you're outside the United States, you have none of that protection. In fact, if I talk to people outside the United States, I don't have that protection. And so, if you want to be secure, you might start with something like Freedom Box and allow people to have a secure server inside their house. Again, all of the Freedom Box software is in the Debian distribution. And you can get hardware that has no blobs in it at all. You have the source code for everything, the firmware, everything. It has a nice panel. I'm not saying that this is mom and pop simple to set things up, but certainly anybody in this room who has any type of systems administration would find it easy to set this up with the front panel when setting this up to software. You set up a web server, you set up a database, you set up email, anything you want, and very secure. You can actually add Nextcloud software on top of that and Fediverse software on top of that and have a community server for a small community of people that would also be secure. And you can even get gratis certificate for it for your websites. Here's another one, home entertainment system using Kodi. Put together a nice 5.1, 2.1, 7.1 surround sound system with Kodi. But you can add on top of that IoT software from Home Assistant to control your lights. I can turn my lights in my house and my air conditioning on from here and turn it off from here. And if somebody breaks into my house, I have motion detection software that takes a picture of them and sends it right here. So I can then call the police and tell them to go to my house and beat the living heck out of them. This was the thing I just set up at CeBIT just to show people some of the capabilities of it. It's a very minimal system, just 2 stereo systems, PC speakers, and then I hooked the single board computer on the back of it using the ESA mount. And there were over 400,000 open source projects that you could put together with open hardware to make products that you could sell and support to other people. So my project, which we call Project Kawan, is going to teach technical people, computer science people, computer engineering people, how to run their own business. We're going to supply sample skeleton contracts for these people to fill out, talking with the customer. These are the things I can do for you. This is how much you're going to pay me every month. And we estimate that if each student only has 6 customers and they spend 4 hours a week with each one of those customers, that's 24 hours a week that they're working, earning money, and the rest of the time they're studying, going to school. They might have to spread a 4-year degree into 5 years, but at least they get through. And they're learning something other than how to flip hamburgers or how to be a night clerk at a hotel or how to wait tables. So this is something that they can carry on after they get out of university, or they can sell it to somebody coming in so that the customer continues to have support. So you can build these with your friends. You could make this a project, particularly if you're going to university, but there's nothing to stop you from doing this. You don't have to write to me. You don't have to say, Mad Dog, can I do this? You don't have to sign any papers, because everybody's going to be able to read everything on the website. Only if you want to ask questions, to interact with the system, to interact with other people, are we going to ask you to do the minimalist thing, to sign a code of conduct, that you're not going to tell people you're crazy, or you're stupid, or you're ignorant, or you're gay, or you're trans, or something like that. That's the only thing you have to do. And if you want to call yourself a Project Kawa professional, if you want to get discounts on business insurance and stuff like that, then we'll ask you to do one more thing. We'll ask you to sign a code of professional conduct that will say, I will treat my customer with respect. I will be on time. I will put in the time that they paid for. And so you can set up one of these systems, set up one of these businesses, not by taking out huge loans and stuff like that have to be paid back on high interest. You can go to friends and family and say, here's my business plan. Are you willing to give a couple $100 to help me get started, and I'll pay you back? And then eventually, you will own the entire business. So how much will this cost for you to participate? Absolutely nothing. We've worked it out. We have a business plan that will keep this funded into the next century. And you, the user, the student, the customer, will not be paying anything to Project Kawan. With that, I'll be happy to answer questions, and I think I probably went over my time, so we would have the drawing and stuff like that. Thank you very much.
Please raise your hand if you have a question.
We're working on the final website now. We expect that the final website will be available on January the 1st, and it's projectkawa.org. Very simple. project.caua.org. I'll be around. You know, you can ask questions if you're shy.
Thank you. Up next, we have the raffle results, I believe.
Yes. Another big hand for Mad Dog. Thanks so much. Not only for your support now, but as Beth Lynn pointed out, for so many years that you've been a big help for OLF.
You're welcome.
I also wanted to extend all of our thanks to all of the speakers and presenters and the OLF Institute instructors we have. People come here, they willingly share their experience, their knowledge with us, and that's the reason why people come. So thanks so much to all of the speakers that we've had. We also appreciate very much our sponsors. It obviously takes money to put on an event like this, and they contribute quite a bit to funding everything. We have also our volunteers and staff who organize everything. Volunteers do lots of stuff like handling registration and doing introductions today in this room. And the staff works on stuff throughout the year, and it takes a whole group of people to put an event like this together. Last but not least, I want to thank all of you, the attendees. This is why we do it. This is why we spend the time to put this event together, is because all of you come out. It's fantastic to see folks in person. We especially appreciate the support that we get from the people who buy the supporter tickets and the OLF Institute training. Again, that is a big chunk of what lets us put on an event at this facility. So thanks so much for that. And even the folks who are here online, we would love to see you in person. It's always great to be able to see somebody face to face. But if you're not able to, it's great to have you watching here either live or after the fact. So thanks so much for coming out. And I will let folks know we're going to have the after party over in the McKinley room right after we finish up with the raffle. So we'll find out who all of these fabulous prizes are going to. So take it away, Beth Lynn.
Thank you, Vance. It's always an exciting time to have the raffle revealed. But first, I want to thank everyone to make sure that the real winner was the Ohio Linux Fest Corporation, raising $1,677. So thank you so much, everyone. We have some fabulous prizes to give away, so let's get started without further ado. So for the Mad Dog's Vault prize pack with the license plates and the BSD blink in the ears, we have Amber Grainer. Then we also have Chase Christensen for the 3D printer. Amber, you apparently wanted Chase to win the 3D printer and brought him for the first time this year. So thank you so much. Awesome. So we have also quite a few other fabulous prizes. Let's see what we got here. We got the If You Can Hack It packet that has been won by Savvy. I think somebody knows Savvy here? Yeah, over here. Okay, fantastic. And you know what? She also won the digital microscope.
Okay.
So Savvy couldn't be here today, but you'll make sure that she gets these fine prizes?
Yes, I will.
Okay. Oh, yeah. Well, hey, it was the last one for sale at Micro Center.
Oh, wow. Lucky us.
So there you go, and there you have it. Okay, let's see what else we have here to give away. We've got, oh yeah, we've got pies. So it was the you get a pie, you get a pie, and you get a pie. There is the Raspberry Pi 400. So what this is it includes a full keyboard and with a Pi embedded in it. And the lucky winner of this fine pie is Douglas Johnson. Then we have another fine pie winner. That would be Rain Clark. That was a combination of a Pi Zero and the Pi Handbook. So I see Rain coming up to claim them. Right here, Rain. All right, great. So then we had Jordan Brown for the Pi Zero. Here you go, Jordan.
Thank you.
Then we had the Tiny Gaming Dev Handheld Pi. And that was Stephen Hinton. Right here for you, Stephen. But oops, something embarrassing happened. We had a hidden pie. The drama builds. So there was a hidden pie that was hanging out at the junkyard table over there in the expo, otherwise known as Tom's Records. And this is a functional Pi 4 with a little touch display. And the winner of that, I'm still going to tease you. Okay, what else do we have? So, we have an HCII mug with other splendid mystery gifts, and this person also won the $55 off of the raffle, the 50/50 raffle, and that is Catherine Devlin. Is she still here? Yep, there you are. And there are other miscellaneous prizes. Okay, miscellaneous prizes for you. Fantastic. And then we have Robert Niemeyer, also for one of these HTCIIs. And you, sir, you get your pick between this motherboard or this cassette. You take the cassette? All right, fantastic. Fantastic choice. Thank you so much. And Scott Redman has a HTCIA travel mug, and he also gets the Walking with the Penguin. Motherboard optional. Scott, is Scott here? Okay, well, if we have to ship it to Scott, then we have to ship it to Scott. So I finally decided who won the pie, and that's Mike Kiwakowski. Is he still here? He left. I'm gonna have to ship him another pie. I shipped him 2 pies a couple of years ago when we did the first iteration of you get a pie, you get a pie, you get a pie, you get a pie. So he got a surprise pie again. Fantastic. Thank you everyone for making this quite a success. We will have a after party on the other side of the wall to ensue with, yes, free as in beer. And Mad Dog, is that what you wanted to know?
No, what did you mention you won the 3D printer?
The 3D printer was won by Chase Christensen. Yes, the artwork was won by Scott Redman, who also wasn't present, but okay. Yes. Yes, we need to introduce the man behind the curtain, which is actually true this year. Sam Jabber, our production manager, take a bow for anything. This would not at all be possible online or in person. Say something, Sam.
I was totally not expecting to say anything, so thank you for attending. It's always fun to see everyone here and be able to assist with volunteering. So if you are interested in volunteering, please contact us for next year.
Fantastic, and we could do it without our fabulous team. And I'm going to introduce people as I see them. So this is my mom, Susan Rose, who will be answering all your questions on social media usually. And we have Michael Schultes, who's our corporate treasurer. And we have Vance Kofendorfer, who has been our amazing speaker chair this year. Is Warner still in the house? Okay, well, I'm going to embarrass Josh, who's come back to volunteer with us after how many years away?
4, I think.
Yeah, he's come back after 4 years, but did an amazing job making sure that we could get program guides here for our conference. So that's some kind of fabulous. And yes, we have Warner, Patrick, and Kyle. So Kyle was kind enough to step up to do the Birds of a Feather. And we also have Warner Moore, my counterpart of vice president. And if it wasn't for Patrick, we wouldn't have such a well-maintained, curated expo. Not really sure where Charlie is. Do you know where Charlie is?
I think he's cleaning other stuff up.
Oh, Charlie is cleaning other stuff up, but he was responsible for making sure that we finally made the journey on to PeerTube, so that if you missed any presentations in the open source solution stage that you were afraid that you weren't going to catch, well, we've got that content for you, and we'll be able to distribute it through a federated sort of way. and we'll see if we can go ahead and put it on our YouTube channel as well. So we are OLF Conference, Open Libre Free, Ohio Linux Fest, whatever you want to call us, that's fantastic. Just believe in free software. Thanks, everyone. Now let's party!